do inaugurate the seminar and wish the organizers the very best to have a very fruitful deliberation. Thank you very much. Good day to all.
Thank you, sir, for your inspiring words. Now, we invite Dr. T. Sajida Rani Ma'am, Dean, College of Agriculture, PADANNAKKAD, for lighting the lamp. We request all the dignitaries on the dais to join.
Thank you, ma'am, and all the dignitaries. Today, we are honored to have amongst us Dr. Rajendra Pillankatta, Professor Biochemistry and the Dean of Students' Welfare, and the former Dean, School of Medicine and Public Health, Central University, Kasaragod. We welcome you, sir, for the special address.
Respected President of this function, Dr. T. Sajida Rani Madam, Honorable Vice Chancellor, Dr. B. Ashok Sir, and Senior Scientist and well-known plant pathologist, Dr. Pitamaran Sir, former Dean, Dr. Govindan Sir, and Dr. Bini Madam, and my dear friend and President of Malabar Plant Protection Society, Dr. Sri Kumar Sir, Dr. Saina Mol Kurian Madam, Secretary of Malabar Plant Protection Society, distinguished scientists, and my dear students, research scholars, industrialists, and farmers. I think farmers also here. A warm good morning to all of you. First of all, wishes of World Plant Health Day, that is tomorrow, I think 12th May. Last month we have celebrated World Health Day, that is in April 7th. And I think when Professor Sri Kumar Sir called me, I told that whether I am the right person to speak in this before this audience, because I am not from the agriculture science background. My background is from biochemistry, and I work in human pathogens, mainly focusing on viruses. And a couple of occasions I came here and delivered 1 or 2 lectures regarding that area. And Central University of Kerala has got a close association with the Agriculture College, PADANNAKKAD, from the beginning itself. Just now Govindan sir mentioned, when I was telling, because as a Dean Student Welfare, Central University of Kerala, in the campus, the main problem what I am facing is I have now sleepless night just because of lack of water. And exam is just starting tomorrow, end semester assessment. So the word resilience, I think it is required everywhere nowadays. When the morning when we switch on the TV, there itself we can see war is one side, resilience is required. Human health problem, resilience is required. Everywhere resilience is required. The only protective weapon for that is the one, probably the first time in India, they coined that word in our policy, that is none other than our missile man Abdul Kalam ji, the word innovation. The one thing which is coined, I think, back in 2003, when science, till that I believe science and technology policy was existing in India. After that, our great missile man coined the term, science and technology alone cannot survive. I mean, we need innovation. That's what I think probably 2020 silently, one policy came, STIP, that is Science, Technology and Innovation Policy. And it was later on interpreted as science to solve and technology to transform and innovation to impact. That's what probably needed to have resilience against various factors. And I know that this seminar is not only for agriculture scientists, it is not only for research scholars, it is required for, I think, each and every individual of our country, and more than 140 plus crore people probably it is maybe going to shoot up after our census, and also for the 800 crore people across the globe. So when we take it as, so that's why, first of all, my thanks from my heart for inviting me to have this a small session in here to give a small talk. So I thank the organizer for inviting me and giving me an opportunity to be here on this great occasion. So today, one of the biggest problem is, health management. It is not only health management. The moment health management, people always think about the human health. If you open and see the logo of One Health, the logo of One Health, it is very clearly, the pictorial it is represented. There is a cow, there is a plant, and there is animal and a farmer. You can see the beautiful concept of the One Health. So health of the planet is actually combination of health of human, animal and plant. So as a biochemist, I feel that to become more resilient, we need to have more innovation using the latest technology. We know that, meanwhile, scientists also should be more aware of our demography and the demographic dividend and how the community is spread. For example, I will tell you a small point here. We have digital technology, we have AI, we have everything, but if we go and see in a community health center or go and see in a small health center, we can see our senior citizens are sitting there from morning to, I think, from 8 o'clock till doctor comes, and a huge queue will be there. So if we have a proper OP ticket in a CHC, if you have a proper OP ticket in the digital technology using what we are talking about, we are not getting that. So when precision agriculture is coming, precision agriculture technology is telling that, like it is precisely, if you have a huge hectares of land where agriculture is there, if you have a pathogen, can you handle from the point by using the prognostic tool? Maybe you can use advanced imaging technology. For example, I was just thinking, Dr. Rajesh of CPCRI, my close friend, everybody knows him. Recently, I met him in the train. He told Rajendra, I am having severe stress because of the Arakanet plant issue in our Dakshina Kannada and this belt, where you can see recent infection of later on they published also this Arepa virus. Arepa virus, which is actually causing a severe damage for the Arakanet plant. And then he was telling, can we do something? Well, I mean, we were talking and talking. then I was thinking, what I can do as a biochemist. So, but immediately I thought, okay, can we have some prognostic tool? So he told, okay, let us amplify cDNA, and I started. One of my PG students recently amplified and expressed the arepavirus code protein. I mean, it's code protein, so that can we have a lateral flow assay in the field to test the farmer immediately and tell what it is, arepavirus or some other mineral deficiency or some other pathogen. So the thing is, we need to have more precise technology. When we are making more precise, we need to have more AI tool, more digital technology and all. But the problem is, there is a big debate which is happening, it's actually digital divide. So, suppose we are sitting in the research center and all, we are making big tools. Let us say satellite imaging of the leaf in a huge hectares of land. Satellite is making an image and telling that there is some issue, is alerting us. I am telling in a hypothetical situation, I don't know whether it will happen. And can we take sample digitally? So whether these kind of technology, whether our rural population is aware, and if it is happening also, how it is going to be implemented. I don't think we have any lack of policies. I think we have a lot of policies. Implementation is the problem. So digital divide is also need to be considered when we are going for AI tool and precision agriculture and all, because 70% of our Indian population is in the village, rural area. I myself, studied till my BSc. We didn't had any power in the corner of Kasaragod. So what I am telling is, the modern area, when we sit and discuss, the real ground reality need to be correlated. We can have a lot of statistics in front of us and lot of diagnostic tools in front of us. So coming back to the point, the arepavirus, my student, I told you have to express that protein and in a bacteria and let us have a lateral flow assay. So I can see the fire in that student also. So that is regarding the prognostic tools. And regarding coming back to the One Health thing and the biosecurity, all these things are clubbed together. Now we know that recently the Nipah outbreak of Kerala is always, the moment you go somewhere and tell I am from Kerala, they are thinking that I am a bat and I am carrying Nipah. So that kind of feeling is in Nipah is a big problem, for example. So why? Because it's just because of fragmentation of the habitat. That is what caused Nipah. I think so. It is fruit-eating bat was there from earlier also. Bat, we cannot destroy. Bat is such a useful animal and it maintains our ecosystem, but it is a dead end of lot of viruses. The problem is human-made. We are actually fragmenting. Deforestation is one of the cause for that problem. And it has to live in this nature, so it comes close to us. Wherever there is a habitat, wherever our fruit-bearing trees are there, probably the ecosystem, favors that. So that's what another big issue, biosecurity biosecurity for food security. That is the theme for this year World Plant Health Day. So biosecurity, to have that in terms of plant as well as with reference to humans, biosecurity is a big issue now in the current scenario. Even SARS-CoV-2, when it came, we thought it is a security breach. Till now, we don't know how it came. That's also is a problem. And Nipah also, we are trying to find out actual reason. But the thing is, again, it is our own man-made problem. The One Health is the ultimate concept. I mean, late 19th century only people became more aware of One Health. But our nation told since the beginning of our, probably, if I tell that maybe I don't know how it will be interpreted, but I'm telling our Vedic philosophy onwards, we were telling that, price the tree, price the thing. I mean, it is not that there is a God or something. We can create an awareness of the people. Our sacred groves are not. So, like that, sacred groves is another thing. We don't have that many. And I think resilience, when you see some of the plant, yesterday I was talking to my colleague Dr. Jasmine, and she works in epigenetics of plants actually. It's wonderful, one of the very wonderful area where probably we have to, whether epigenetic change in plant can be inheritable. That is an important question. The geographical geographical change. One particular geographical area, the genetic makeup and epigenetic changes over that, epigenetic imprint, can it be, inherited? So if it is inherited, probably we can actually apply that in the agriculture practice to get more yield or something. That kind of innovative research can happen. So I was talking to her, see, recently after this road construction, many of the plants what we used to see early, now it is not there. So Malabar Plant Protection Society, I was very happy when Sir was telling, even though I am not a taxonomy expert, I was thinking that molecular taxonomy is also one of the key player there. Probably Malabar Plant Protection Society can, definitely collaborate with the Central University of Kerala. We have a biodiversity park and botanical research center also separately. And we are actually, conserving many plants in that. So, like that, then I came to know that I think probably that for interest for the Malabar plant, they also knowing that one of the plant discovered by S.R. Yadav, Professor S.R. Yadav, famous taxonomist, he discovered one plant species in Periyar. It is, I think it is only existing in the world, it is in Periyar, that is, has got a 13 feet long leaf. Actually, it is there in the stream, which is flowing. 13 feet long, I think it's Crinum malabaricum, its name, Crinum malabar. It came in a very famous news. He discovered in 2012 from Periyar. Now I think anything grows in Periyar can be growing anywhere because severe heat and laterite and that's what with Govinda Sara he was discussing. So that kind of thing. So anyway, I am not extending much because I am not having expertise. My thinking is like this. Probably in agriculture practice, we have to have more innovation, we have to have more interdisciplinarity from the modern science. Even we have CRISPR-Cas9 technology to manipulate the plant genetically. Earlier we were doing gene silencing, now we can do gene knockout by using the CRISPR-Cas mechanism, and you can play around with the plant with that and then actually have a great innovation. And in this occasion, I wish that all land will be very fertile and all crop plant will be very healthy. Let all communities they will have food secured. So with that wishes, I conclude my special address, and I know that we are all waiting for very enthusiastic lecture sessions. I wish all the very best for the program. Thank you once again for inviting me. Let us have discussion ahead. Thank you very much.
We request you, sir, to release the digital abstract of the seminar. We request you to release the digital abstract of the seminar.
Thank you, sir.
Thank you.
We now invite Dr. C.K. Pidambaran, former Director Research of KAU, for the felicitation address.
Respected members on the dais, my dear friends, students, and colleagues. First of all, I'm very happy that we have started an organization of Malabar Plant Protection, Malabar Plant Protection Society. So why I'm happy is mainly because, see, if you look at the history of plant pathology or plant protection, whatever paper you see and whatever articles you see are mostly skewed towards the southern part of Kerala. Northern part of Kerala is completely neglected. And many of the papers, many of the projects are mostly towards the southern part. The agroclimatic situation and also the system of agriculture and the plant protection needs for the northern part of Kerala is entirely different. Water deficient, so soil is different from other parts of Kerala, highly lateritic, highly acidic, not able to absorb water, and also even the plant population is different. We are mostly and water plants which are able to grow in a water deficient soil and not a very economically viable crop in the certain parts. And we have got certain crops, economically important crops like arecanut, which are not, apart from Thrissur, it's not cultivated in any other part of Kerala. So our needs, our plant protection needs are entirely different from other parts of Kerala. So what I am saying is that this society will take active steps in helping the farmers to solve their problem in this part of the Kerala and also help them become economically viable. I wish the society all the success. Thank you.
Thank you, sir. Next, we invite Dr. M. Govindan, former Dean, College of Agriculture, PADANNAKKAD, to felicitate the occasion.
Good morning, everyone. Dr. Ashok, IAS, has already inaugurated the seminar. Dr. Rajendran, Dr. Saina Mool, Dr. Sri Kumar, Dr. Sajida Rani, and many distinguished guest speakers. Today, we are celebrating the World Plant Protection Day, Plant Health Day, and also conducting a national seminar on resilient agriculture. The topic is very relevant. The Malabar Plant Protection Society has selected this topic, and it is very highly relevant in this context. Last year, we have witnessed very severe rainfall, and thousands of young rubber plants were damaged. Technology is there, but farmers could not adopt any practice for controlling the disease due to the heavy rainfall. Similarly, in arecanut, nearly 20 to 30% of arecanut were damaged because it was torrential rainfall, and farmers could not adopt any spraying measures. So similarly, due to this heavy rainfall and the 6 months drought period, as Dr. Pidambari sir has rightly pointed out, we are facing an entirely different situation comparing to southern parts of Kerala. So, in the seminar, we'll be providing an insight to many solutions, technical situations. So that important topics will be discussed, and also there are sessions to honor memorial lecture, honor Dr. M.R.G.K. sir and also Dr. Samraj sir. So they will be remembered, or they are remembered. We remember them based on their contributions, work, dedications, and other valuable achievements they made in this field of agriculture. So it will be an inspiration for all of us. I would also like to thank the organizers and the Malabar Plant Protection Society, and Kerala Agricultural University, and CSIR who have combinedly organized this function. So also, I would like to remember that, remind that the Union Budget 2026 aims to make Indian agriculture resilient, technology-driven, and globally competitive. Let us all work together for the growth of agriculture and do our best to achieve this goal. So let us all join together and make this event a great success. Thank you.
Thank you, sir. Next, we request Dr. Mini PK, Professor and Head, Department of Agricultural Engineering, College of Agriculture, PADANNAKKAD, for the felicitation address.
Respected Dean, College of Agriculture, PADANNAKKAD, Dr. T. Sajidarani, who is presiding over the function, Honorable Vice Chancellor, Dr. B. Ashok, IAS, Distinguished Chief Guest, Dr. Rajendra Pillankattu, Professor, Biochemistry and Molecular Biology, and also Dean, Students Welfare, Central University of Kerala, Dr. K. M. Srikumar, Dr. Pidambaran sir, former Director of Research, Dr. Govindan sir, former Dean, College of Agriculture, PADANNAKKAD, Dr. Sainamol Kurian, all invited guests, researchers, teachers, delegates, and students. A warm good morning to all of you. So it gives me immense pleasure to offer a felicitation during the inaugural session of this national seminar on resilient agriculture, innovations in plant health management and biosecurity, jointly organized by College of Agriculture, PADANNAKKAD, Malabar Plant Protection Society, and CSIR, in connection with World Plant Health Day 2026. So the theme of the seminar is highly relevant in the present agriculture scenario. Ensuring plant health and strengthening biosecurity measures are essential for building climate resilient agriculture, the system which is capable of facing challenges such as climate change and emerging pests and diseases. So this seminar provides an excellent platform for the researchers, students and delegates to exchange ideas and also share innovative research results. And I sincerely appreciate the dedicated efforts of our organizers for coming up with the very meaningful seminar. I am confident that the deliberations and discussions during this seminar will generate valuable insights and strengthen collaborative efforts in the field of plant health management. My best wishes for the grand success of this program. Thank you.
Thank you, ma'am. Now we invite Dr. Sainamol Kurian P., Professor and Head, Department of Plant Pathology, College of Agriculture, PADANNAKKAD, and Secretary, Malabar Plant Protection Society, to deliver the vote of thanks.
Respected dignitaries on and off the dais, esteemed guests, scientists, teachers, dear participants, and my dear students. It is my proud privilege to propose a vote of thanks for this memorable program, in which a new chapter in the history is born. First and foremost, I take this opportunity to express gratitude to science, the savior of mankind. It was during 2020, when we were all slowly getting out of the COVID pandemic, that the UN General Assembly took this resolution to celebrate May 12th, dear students, it is May 12th, that is tomorrow, as the World Plant Health Day. Annually, we will celebrate May 12th as the World Plant Health Day. So that resolution was taken after celebrating the year 2020 to 21 as World Plant Health Year. So it was Dr. Sajish who brought this piece of knowledge to our college, written on a piece of paper, like May 12th is a World Plant Health Day. It was in 2023, and we took the decision to form a society in the name of Malabar Plant Protection Society. So now, as the secretary of the MPPS, on behalf of all members of the society and the loving PADANNAKKAD family, I express our great our heartfelt gratitude to Honorable Vice Chancellor for inspiring us with the inaugural address and for officially inaugurating the program. Sir, your visionary words and encouragement have truly motivated all of us. I also extend our sincere thanks to Dr. Sajida Rani, Dean, College of Agriculture, PADANNAKKAD, for all the help and support she has extended to the organizing committee and also to the Malabar Plant Protection Society, and also for her inspiring presidential address, which set the tone of this academic gathering. We greatly acknowledge Dr. Rajendran Pillankata, Dean, Students' Welfare, Central University of Kerala, for the digital release of the abstract book, and we sincerely appreciate your gracious presence and valuable contribution to this academic event, sir. Our special thanks go to Dr. M. Govindan, former Dean of this college, who offered felicitations and blessing, even though we invited him very late, I think, only during the last week. So your encouraging words have added great value and inspiration to the event, sir. And sincere thanks are due to Dr. Mini PK, Head of the Department, Agricultural Engineering, and lovingly called by us as Mini Teacher. She volunteered and called for meeting of members of various committees many times. Thank you, Dr. Mini, for the motivating words as well. I extend profound gratitude to the eminent scientists and teachers who have joined us to deliver memorial lectures and lead talks, especially to the two stalwarts in the field of plant pathology and entomology respectively, Dr. C.K. Pidambaran and Dr. K.D. Prathapan, who will be joining us in the afternoon to deliver the two memorial lectures in today's first technical session 1. My heartfelt appreciation goes to all the participants, teachers, students, and delegates from more than 15 institutions all over India who have enthusiastically joined and made this event successful. I would also like to especially thank the students and teachers of this college for their wholehearted cooperation and support. Actually, words cannot express the love and unity I relish from them, not only during the seminar, but always during any such programs. And our sincere thanks are also due to the media for giving coverage and visibility to our program. And I extend special appreciation to the technical staff for ensuring the smooth functioning of all the technical arrangements throughout the event. I also thank the authorities and staff of the university for their cooperation and support during the program. And special thanks are due to the heads of institutions of KAU and ICR institutes, our neighboring ICR institutes, who have kindly deputed their staff and permitting students to participate in this seminar. A special word of appreciation goes to the students, PG students of the Department of Plant Pathology and Entomology, and also my loving colleagues from the departments for their untiring service, sincerely, coordination, commitment, which have contributed immensely to the grand success of this event. Finally, let me take 15 seconds to place on record our apology because of any overlooking or rather overconfidence from our part has caused difficulties to the dignitaries on the dais, and it is told that to err is human and to forgive is divine. So I take this opportunity to place on record the apology from the part of Malabar Plant Protection Society and the organizing committee for any such difficulties or omissions that has caused during the conduct of the program. Finally, I thank each and every person who directly or indirectly contributed to the successful conduct of this program. And with sincere gratitude to all, I conclude. I wish this lamp at the Temple of Science shine brighter and brighter and enlighten future generations. Thank you.
Thank you, ma'am. Here we conclude the inaugural session. We kindly request all the delegates to assemble in front of the dais for the group photo session.
Requesting all the participants and delegates to join for the photo session.
Dear teachers and students and delegates, please come forward. We will stand facing to the balcony so that a group photo can be taken from the balcony also. Dear students, please come. It is a group photo. Please come forward and stand in front of the dais so that photo can be taken from the balcony.
Thank you all. Now it's time for a short tea break. Tea will be served near the registration venue. All are requested to reassemble at 10:45 a.m. We will begin the technical sessions of the seminar after the break at 10:45 a.m. Sorry, we will begin the technical sessions of the seminar after the break at 11:15 a.m.
College of Agriculture, PADANNAKKAD. Rapporteurs for this session will be Dr. Dahlia Mall, Scientist, CPCRI, Dr. Rajesh Kalladan, and Dr. Dhanyalakshmi K.H., Assistant Professors, Department of Plant Physiology, College of Agriculture, PADANNAKKAD. Dr. Pidambaran completed his bachelor's and master's degrees in agriculture at the College of Agriculture, Velayani, before earning his PhD from G.B. Pant University, PADANNAKKAD. He began his career in 1968 as a lecturer in plant pathology and went on to serve Kerala Agriculture University with distinction, retiring in 2005 as Director of Research. We humbly request Professor C.K. Pidambaran sir for delivering the memorial lecture. Sir, please.
Dear friends, I'm very happy to be here to deliver Professor J. Samraj Memorial Talk and also on a lecture on biosecurity. Dr. J. Samraj was my professor and a guide for MSc, and I think I'm the sole person alive who was a student of J. Samraj, as a guide of Samraj. See, I was very fortunate because after he used to take classes for me for BSc, and it was only because of that I joined plant pathology. And again, I am fortunate because even for my PhD, I was a student of two eminent pathologists, Dr. R.S. Singh, who wrote the books on plant pathology, half-dozen books on plant pathology, and Y.L. Nene. You must be knowing about this. He was a professor of plant pathology as well as the ICRISAT head, and he was responsible for bringing out the Ayurveda thing. See, when I used to go for many interviews as well as for selection board and for MSc and PhD students, thesis evaluation. When I asked them, tell me some names of plant pathologists, readily comes the answer: Antonio D. Barry, Michelangelo, then Prevost, Berkeley, and D. Barry. I said, I don't want any international thing, old man. I want something from India. Then comes the word Butler, Munkur, then Dastur, then about Patel and all these things. Then the third question I asked, any from Kerala? Mumk, no answer at all. As if there was no plant pathologist in Kerala or a plant protection. I am basically thinking of plant pathology, but plant protection, I was saying only plant pathology. But it's a sad affair because there are equally credible, equally competent, equally, very knowledgeable persons in Kerala who we have forgotten, completely forgotten. So my idea here is to at least project one such person, J. Samraj. He was my, as I told you, he was the first plant pathologist in Kerala. The first plant pathologist in Kerala. Then, say, I'm just giving you a bird's eye view of the legacy of J. Samraj. So, he's a great scientist. Something is wrong here. Side lamp. Yes. See, the question before coming to this thing, why do we say all these memorial lectures? What is the purpose of these memorial lectures? See, we just say memorial lectures, See, we celebrate or you give the memorial lectures first to commemoration, to his life values and all these things. And that is the first step. Second come knowledge sharing. Say I was talking with several eminent persons like Govindan and Singh. Then I asked him, do you know anything about Samraj? He said, I don't know. Because his contributions, they know him as a professor of plant pathology, but they don't know what his contributions to the field of plant pathology in Kerala as well as in India. And that is for knowledge sharing. Inspiration. That is, see, I told you that I joined plant pathology department only because of Samraj. And I even now I am interested in plant disease diagnosis, and it's only because of Dr. Nene, because he taught us a course in plant disease diagnosis, the first course in India on plant disease diagnosis. So that's an inspiration. Then community building. Community building is an important thing. Why? Because, see, all the scientists should not be in airtight compartments. It should be watertight compartments so that plant pathologist remains a plant pathology, entomology became entomology. So we have to build a community of persons who work in the field of plant protection or any other science for that matter. Then that is one thing. And what is the role played by these eminent scientists on this community building? We should know about that. So that's another thing. Then continuity of vision. What is their vision? And we have to know about their vision. So I'll just skip through some of this, his research finding. There is something wrong. It is either my fault. Sometimes, legacy. So here's, I just keep that. Born in 1920 and all these things, that's thing. School, Kottarakara, BSc, University College, Trivandrum, BSc Honours, Presidency College. Then he was one of the first person to receive the Fayon Prize for the best student from Presidency College. And associate in IRA Delhi, and that was in 1947, 46-48. And do you know, till 1948, there were only less than 100 associate in IARA in plant protection. In plant protection, less than 100. He is one among that. Then PhD from Imperial College of Science and Technology, London, and DIC from Imperial College of Science and Technology, especially Rothamsted. He worked in Rothamsted, and diploma in Imperial College. He got a diploma in Imperial College. So this is his this thing. So, there is something. Where to press? I am pressing I. There is, yes. Say his profile, entered service in 45, 46, 7 in associate, 47 mycology, 49 mycologists, 85, 55, 57 lecturer, 57, 60 deputy PhD and IRA. Junior professor of plant pathology, professor principal dean. And I know Dr. Samraj as a person about 5 feet 2 inches, wearing a clean white dhoti and a jubba, white jubba. And I just wanted to find out how he looked in England. So I went to his house, searched all these things. I got his passport, old passport. That is one of the photos. He was wearing coat and all these things. Then his thing. Then I am going to sue Samraj as a teacher. Then you may ask me, why this cigarette thing and the snuff box? So when he comes to the class, he is a chain smoker. When he comes to the class, he takes a tin of cigarette, either capstan or player, and a matchbox on the top of which he carries from the pathology, his room in pathology department, smokes till he reaches the class and put it off and keep the cigarette and the match there. And by that time, his peon comes, clean that board, and that's what I'm saying in 1962 when I joined. Then cleans the board, keeps a set of colored chalks, white chalk, a set of books, that is on mycology, plant pathology, some Burton books. If you got some doubts, you may refer that. Then that is it. Then after 2 years, doctor advised him not to smoke. Then he switched on to snuff. But typical of Dr. Samraj, he carried not a snuff box like this. He used to have a Horlicks bottle full of snuff. So he used to carry, and a small cap, everything. Every 5 minutes, and going near him was thing. He smells like a rat. So, because of snuff thing. So that is this. Then coming to, so that is, so undergraduate teaching. As I told you, he used to come to the class and he takes only one section, one group, basidiomyces, smut and rust and all these things. He is a specialization in basidiomyces taking class. Then after taking class, he need not study at all. Even Puccinia graminis, I remember the day he took the classes, and with colored chalks. He danced in front of the thing, in front of the board, and draw and all these things. And his speeches are so interesting that we never used to go out of the class. It is so interesting. Then postgraduate teaching, again, he was doing that. And as a guide, he used to say, suppose a subject, for example, mine is a Sarcospora, I taught Sarcospora, and he used to give at least half a dozen theses on the same subject, so that he never completes a thing. He said, you have to complete that topic. Then there is no one Sarcospora, one alternary, no. He completes a series of projects on Sarcospora, and interestingly, his media, fortunately I was also involved in that, was the first one to produce spores in Sarcospora, that special media. Then again I come to the research guide. And the research guide, so what he used to do is, when you write thesis, we used to go to his house, but he is staying alone. We got married only at the age of 45. I think 45. Then he say, there is no tea or coffee, I'll give you some black tea. He used to brew black tea and gives to us. And he works with us. And immediately after coming back from England, he built a huge house with a fireplace. Think in Trivandrum, with a fireplace, copying his house in Rathamstead. And he used to stay there and like that. But interestingly, he used to come to the class only if he is prepared for the class. So when I joined as a lecturer, I came to know this thing. When he is not prepared, he will tell any of us, you go and take the class. We are not prepared. So I came to know about it only after a couple of things. Then we used to at least, who were pathologists, junior pathologists, we used to prepare at least for one class. So that when he says there is, I don't have time, that means he has not prepared. So he used to read. I used to go to his room quite often, and he used to read all these things and take classes and say once you sit in the class, that's it. So that is how his thing. Then, as a scientist, see, many of us don't know. As I told you. Say, if somebody asks you who are the important plant protection persons in Kerala, nobody knows about Samraj. But he was the first person to work in virology on tomato leaf curl and confirming Bemisia tabaci as the thing. The section of plant virology, epidemiological foundation was laid on virology, as well as epidemiological foundation was laid by Dr. Samraj. And interestingly, his paper was the first time in India the tomato leaf curl is transmitted vector Bemisia. Then identified subsequent research and focus on all these things was done, and that paper was published in Phytopathology in 1948. And you see, was there one Samraj in Singh. In 1948. He published this article in an American journal in Phytopathology. That was a landmark. Suppose if you refer any of the leaf curl diseases, any work on leaf curl disease, and you will see this reference coming the first, because that was one of the first papers on Bemisia tabaci in leaf curl. Then also as paper. Then others feel, because I was told them by me, the organizers, only 15 minutes, I have to complete that, so I'm just running up. So aerobiology, you know what is aerobiology? Aerobiology plays pivotal role in plant pathology. You might have studied about Puccinia graminis, how the Puccinia graminis spores move from South India, Afghanistan or Nepal to India, and the work of 1935, the work of Mehta's work, all these things. But they used just the plant samples. First, they will just find out where they are seeing Puccinia infection first. If it is seeing in the Pune region, the spores are from Nilgiri Hills. Or if it is from Punjab region, it is from Afghanistan region. If it is in Tarai belt, it is from Nepal. So different strains are there. So there is only six. Then came the collection of spores. Collection of spores, different methods are used, and he was the person who first brought in the automatic spore trap. Hearst in 1921, along with Green. These were the two persons who worked on this thing in Rothamsted Station. Samraj sir was a student of Hearst for his PhD. And he worked, originally it was these types of selections. We used to plug in all these things. Another one, then these are other new methods. Then in our laboratory, we designed this thing. This is the spore trap design for the study. The first work in India on spore trapping. This was the thing designed by Samraj and his student, Chandrasekhar M.C. Nair. Then, okay. This is the spore trap. It is called his spore trap. He brought this spore trap from England to India in 1961. The first spore trap in India. And we used to work, there are about half a dozen theses on this thing. And they collect spore samples, and his work on blast and other diseases, vegetable diseases, Maheshi's work, and also Malik's work, all these things are by aerobiology work in Kerala. Then comes the third one, rhizosphere. See, rhizosphere is 1960s as the formative stage in India. So his work was on the rhizosphere. Then also on actinomyces, different antibiotic producing actinomyces, he did that, and that was thing one. When you see coconut and Arakan disease, immediately using that first paper, I don't say paper, it was a note, was by boron deficiency. He said there is an acute boron deficiency in Kerala. Now we are saying boron deficiency is seen throughout. The first note was by Samraj, and he worked on the, and also he was the first person to spray area application oil-based fungicide against leaf rot disease and coconut palm. First oil-based thing. Then Phytophthora. See, when somebody asks you about Phytophthora, the first, who is the scientist in Phytophthora? They may say IESR, Calicut, Sharma has done the work, all it. But the first paper on Phytophthora on pepper, confirming the toxicity by Samraj and Jose. First paper. Then there was all sorts of things on Phytophthora. Then Sarcospora, I mentioned about Sarcospora. Then fungi of India, at those times fungi in India, different fungi of India used to work on that. But interestingly, our MSc examination is interesting. Not one batch, many batches. For the practical examination, mostly Rangaswamy used to come, then C.V. Subramanian used to come, T.S. Sadashivan used to come for our examination, the old salvers. So what he say, we are giving you 1 hour. You go to the field, collect as many samples as possible, identify the sample, and say why these symptoms are these. That was one of the pet questions he asked. So we used to run to the thing, maximum collection, who is getting a maximum gets a maximum mark. So that is a practical examination type. So fungi of India, you were very, say, boron deficiency or zinc deficiency, I told you, he was the person who started that. Then first aerial spraying of paddy in late 1960s. And I was fortunate in one of the member of this thing. So we used to go by the helicopter in the Kuttanad belt, spray there. I stayed there for 3 months in Kuttanad, just spraying these things, and all sorts of things connected with that. So that is the thing, 1969-70, their first spraying in thing. How many of us know about that? All these things were the work of Samraj. Nobody knows about it. But he was such a genius in that. As an administrator, I have very, very poor opinion about him as an administrator. Because he's a scientist of course. But administration was forced upon him. He was forced to become a principal, dean, and all these things. But I don't say he was a good administrator. He don't know how to administer. He either believes somebody or don't believe somebody. So with the result, there is always a quarrel. So all these things. But as a head of the department, he was very good. Pathology department was one of the best departments in Agriculture College Vellayanil, with the best equipment available, and all these because of Dr. Samraj. And he was able to bring in many materials free, because his connection in North India, he used to bring all the materials from there. And our laboratory was one of the best laboratories. And microscopes, one of the best microscopes available. Scarl's is the Zeiss microscope with the temperature control on the stage is available to us in 1970s. Then he was also in plant quarantine. So as a dean, I don't have much opinion about him, because I don't say he's a good administrator. There is no point in always praising somebody when call a spade a spade. So that is Samraj. And so this photo, this line drawing, pencil sketch of Samraj. So I gave it to him, and he signed. That is his pencil sketch. That I even kept it even now with me. So that is Samraj. I think he almost looks like this in the old photograph and this thing. And it is not my thing. I arranged somebody to draw a picture of him and took him to Samraj. And so that is it. Thank you very much. That's about Samraj. So I want to say more about Samraj, but I didn't have time to say. So next comes the other talk on biosecurity. So, I delivered this talk first at a conference at CPCRI Kayankulam on the 2nd, is it on 2nd? 22nd April. And slightly modified this thing because in the last moment he said that you want something about biosecurity. So I just modified this talk and I'm presenting it here. So, first of all, what is biosecurity? Biosecurity refers to a comprehensive and integrated approach that encompasses policy frameworks, regulatory measures, and management strategies aimed at preventing, controlling, and enhancing risk posed by pests, disease, and invasive alien species, and genetically modified organisms. IAS is not Indian Administrative Office alone. This is also invasive alien species. So we have got two different IAS, alien species, sometimes the IAS. So we have got two. Then in context of globalization, international trade, travel, and all these things, this is becoming more important to us because biosecurity is now a main problem. Say, coming to my topic is limited to horticulture. Biosecurity in horticulture planting materials, prospects and challenges. Say, coming to horticulture, horticulture accounts for 30.4 of the total GDP of the agriculture sector, even though it is using only 13.1% of the area. 13.1% of the area is contributing 30.4% of the total exit. Thanks to this is only because of that seminar. I read your abstract. One of the papers it was there. So, focus mainly on diversity, productivity, and value addition. So now, whenever you say something about horticulture, we are interested in only three things. We want diversity, horticulture diversity. Second, we want productivity, more production. We want value addition. But we never are bothered about the problems based by the biosecurity. Concerns are not discussed in horticulture or for that matter agriculture. Hidden dimensions, biosecurity, planting materials not just carriers of promise. They can also be carriers of peril. So this is the one thing you should always bear. We always say that the biodiversity, good for the country, everything. Agreed, it is good for the country. But if it is not properly managed, it is also the carriers of peril. Typical example, coconut, Eryphid mite, bungee top, brought from Sri Lanka. Again, it's a peril. That's something. Crops are proposed vegetatively. Most of the horticulture crops are propagated vegetatively. And that is the ideal thing from biosecurity concern. You can multiply very fast and all these things. Increased trade, climate variability. So, pest migration, making quarantine, enforcement difficult and all this. So, I'll come to all these things. So, international. What are the organizations involved in that? One, coming to International Union for Conservation of IUCN, Biodiversity, and Invasive Species Specialized Group and all this. International Prawn Protection Convention. These two are the major organizations involved or helped in the biosecurity. That's one thing. Then comes the other international organizations. We have got IPCC, Regional Protection. These are all different organizations. Asia Pacific Plant Protection Commission. Like that, there are different types of plant protection organizations in the world. They are looking after all these things. I think I can give you the PPT here. You can copy it, no problem. So it will be here, available here. You can just contact Cynamol, and that will be there. You can, if you want, you can always take it. Don't bother about taking a photograph. So, Indian community, Canada, health quarantine, all these things are. Then come to India. National Indian Biodiversity is led by Directorate of Plant Protection Organization and Storage, Faridabad. Then there is a National Plant Protection Organization, NPPPO. and they are in charge of these. Then comes the challenges. So far, I just told you the horticulture, the problems faced by the horticulture, this thing. Then, what are the organizations which are responsible for this thing? Now let us see the challenges faced by the thing. One comes the regulatory fragmentation. Why is that many of the uninvited guests of plant disease and pests are coming to India? That is mainly because regulatory fragmentation. The same thing are controlled by different agencies. For example, research, we have got international policy matters are there, EPIDA is there, MPEDA is there, all sorts of agencies are there. One says you can import. Say, for example, the plant breeding department. Plant breeding departments wants X many plants are possible to be brought to India so that we can increase the biodiversity. Not bothering about the problems of pest, disease and all that. The MPEDA and EPIDA is interested how to export things maximum and also bring in foreign currency. Quarantine is responsible for that. They don't want any pests to come inside that. So these are working, each one is working against the other one. One want import, other don't want to export, all these things. So we coordination disciplines for all these thing areas are germplasm exchange, biosecurity protocols. Germplasm exchange. Do you know the major challenge in cashew, in pepper to India is from Vietnam, all this area. Is it not? Why? Because after the Vietnam War, India-Vietnam Friendship Treaty was signed. And when it was signed, we sent the best agronomists, pathologists, and all this to Vietnam. And Indian government gave them permission to carry the best varieties available in India. They took the varieties, they knew all the best practices, they cultivated, and they are the threats now. About a year back, I was in South Africa for some of the work. So when I went to South Africa, I saw different varieties of mango from India. Muwand and all these things there in Bismarck's great-granddaughter's farm. Great Bismarck's great-granddaughter's farm. And another thing in Kenya, I went to a pepper farm. Instead of Panayar, it is called variety Panayar. Panyur 1. It is called Panayar there, and they released the variety in Kenya. In many other African countries, in Tanzania, Kenya, Liberia, I travel all these things because of this thing. All places our planting materials are there. But then where is the plant quarantine? Plain quarantine. Now, I am working in I am working in Oman. The government of Oman wanted to introduce cashew from Kerala. We are going to enter into a contract with the government of University of Kerala about these things. But I am against it. So they are bringing in plants from different parts of the world. They want to have a cashew farm in Oman, Salalah, a region called Salalah. We are having about 20,000 acres of palm. Coconut, we already started planting coconut. We brought an airlifted coconut from Sri Lanka, from Lakshadweep. These big plants were airlifted from the thing, and they are planting it there. Then also we will be planting cashew also. So, the regulatory fragmentation, weak coordination, limited role of plant protection experts in germplasm exchange. So when there is a germplasm exchange, both the entomologists or pathologists Now, the problem is not for entomology and plant pathology. Now, a third problem has arisen. One, the nematology. Nematology, we don't know whether it is pathology or entomology. In agriculture university, it is under entomology, but in other countries, many of the other universities comes under pathology. So, let's say till now, nobody is bothered about nematodes. But nematode has become a major problem nowadays. Many of the countries wanted to have a nematode certification program. So that is a thing. Shortage of experts in national, state level of nematology. We don't have any experts. And next talk say the afternoon, I think K.D. Pratap will be giving a talk on MRGK Nair. MRGK Nair was the first person to start the nematology section under entomology in Kerala Agriculture University. So that is expert. Inadequate expertise in certification system. We say, I'll tell you one thing. Next week I am going to Andhra, a place called Kadayam. Kadayam is a place where extensive nurseries are available. And I wanted to take some plants to some other place. I wanted certification on nematodes. Then I asked them, the nematode people, the nursery people, I want a certification for nematode. They said, we don't have a certification process in nematodes. Then I contacted this thing, that is a NIFC, National Institute or something like that. I asked them, I got a nematology department. Then they told me, we had only one nematology department, and she was transferred to Northeast. No, that section is not working. And there is now another department, there is an institute called DIF, the Directorate of Floriculture, DFI, something like that, Directorate of Floriculture. Fortunately, one nematologist is there, so I am going to meet her just to find out if it is possible to. And another thing is, we are certifying, it is not. But in the case of, again, Phytophthora and Pythium, spread of formerly Pythium and Phytophthora was not a big problem in Kerala. But now it's a problem. Who is responsible? We are responsible. Dr. Sharma used to say that ISR is responsible. No, I don't say it. But we are, IKU is responsible. Why? Because our soils are infected with Phytophthora. We are taking the soil from Phytophthora, infected soil, and spreading throughout Kerala. Pythium, we are spreading throughout Kerala. We are not certifying. Nobody is certifying the nursery soils. We don't know how to certify. The isolation of Pythium from nursery is very difficult. Phytophthora is also equally difficult. So we are not exporting in lakhs. None of the nurseries have got a certification method. So we are responsible for spreading Phytophthora, Pythium, and we say now the new route has come that we have to go in for a soilless media. For me, how can it be possible? Because coco peat is prohibitively expensive. Moss is not available in Kerala. So how are you going to do it? So these are some problems faced in that. Diagnostic limitations. Do we have a proper, for example, even banana virus indexing? In Trivandrum, there's only one place in agriculture college indexing, but they don't do it. You had a space, but only limited plant. I have got a tissue culture laboratory, and I am trying to say, since I am in pathology, I wanted a certified banana suckers and all that. I am trying to work with the College of Agriculture, Vellani, to certify. But no other universities, they don't know about it. Then informal trade channel, that is important. Informal trade channels. You are bringing in one plant, is it not? One plant. Say bypass. Say I was just told you last time that I was saying. I was in Calcutta airport. I was coming from Burma, Myanmar, present day Myanmar. So somebody was carrying some floriculture plants, orchids. I told her, this is the banned variety in India. You should not take it. She said, no, you should take it. Then, fortunately, I saw a plant protection board there. I went to that place. At that time, I was working in the plant protection, some part of plant protection. So I told him, that lady is saying, then do you know his answer? is a dam. 1 or 2 plants don't make any difference. At the same time, if you go to Australia, from one district to other, if you are taking a fruit, they won't allow to carry a fruit from one district to other. Either you have to eat or destroy it. No. If you go to this place, I was surprised to see that in Sri Lanka, Singapore airport, there are 2 boats. One boat, death is the punishment for drugs. That's the one boat. Next to that, there is a board. Illegal bringing of planting materials is punishable. So he reads both these things. Whether I will be killed, it's just like a drug. If he that, so that is it. But we don't know. How many of us know that we cannot carry bungee top infected, or we cannot carry banana suckers from Kerala to other states? There is a rule. We are not supposed to carry suckers of banana from Kerala to other states, because districts, because other states, because Kerala is a bungee top infected area. There is a rule, plant protection rule. We don't know. Even the agriculture officers don't know about it. So that is it. Informal trade channels, climate change. Climate change now is a problem. Do you know now the thing is, many of the pests, he may be giving more thing more about that. The pests are moving towards the hill stations. Why? Because the temperature is high here. So they want a cooler area. So they are slowly moving towards the hill stations. And again, in the world, if you take the world from tropics, the pests are moving towards the poles, towards the pole. So because the temperature is there. So all these things are there. Awareness, like I told you, nobody knows about the rules and regulations, and we are not teaching. Our pathology department doesn't have a course on awareness of biosecurity. Do we have? No. No. So that is it. So awareness is there. Awareness is not for pathology students. Awareness is not for the agriculture officers. Awareness is not for the department of clan quarantine. Awareness is not for the department of clan quarantine. Awareness is not for the NBPGR. These are the agencies which are responsible. So awareness. Resource constraint. We say that we want to have a course on this thing, but where is the experts? There are very handful of experts in Kerala. Not even a handful. Experts in plant quarantine. How many experts are there? See, I studied because I was a state plant quarantine person. When I was also in many of the countries, I was a plant quarantine agency head. So I know some of the rules. Then here comes, so resource constraints there. Together these challenges create a fragile system where risk can easily outpace responses. That is it. So the risks are more. In Kerala, again another thing, which district has got the maximum number of pests and diseases are seen for the first time? It's in Ernakulam. Because the port, the packing materials are there. Now second is going to be Trivandrum. When Adani port starts functioning, second is going to be Trivandrum. But in Trivandrum, we don't have any facilities for that. Ernakulam, for name's sake, there is one agency, but nobody is doing that. So that is the problem that you are facing. These are the challenges. But prospects, we are going to work on this, that the government is doing something. One is the clean plant programs. How many of you have heard about the clean plant program? Only very few, is it not? Out of these, only very few people know that. Because now the government is spending about, say, about 900,000 crores on these things. On 9 agencies, only 9. Of which 9 CPP program for grapes, oranges, pomegranate, apple, almond, walnut, mango, guava, avocado, and lychee. The first one is started in Maharashtra, in I think Pune belt. That started that, and in only one in South India, that is Bangalore, IHR Bangalore for mango, mango, avocado, and pomegranate. They're not going to start. And this is a big organization. The government is spending crores of rupees on this thing, having the best facilities. Digital traceability. That's another thing we are planning. That is, we can now we have. I think last our white paper, we are saying that all the nurseries should have a QR code. The plant, you say QR code. Just find out from where it is coming from, which plant it is coming from. All these things. It is not a big thing. It's a very simple thing. For the first time in Kerala, Kadakuttam Coconut Nursery started this thing when a lady was there. Whenever brought up coconut, she puts a digital code on that, and we can trace the thing. That is easy. Then comes the advanced scanning entry point. See, entry point for human beings, there is a proper scanning. Is it not? All the bags are scanned. But they are scanning only for metals, gold, all these things, but not for plants. But here, dual energy X-ray system is being introduced. CT scanners, AI enhanced screening, and specially trained sniffer dogs. That is a new thing that is going. Till now, sniffer dogs are only for drugs. But now they are training the sniffer dogs for identifying the plants. Not the plants, not the particular plant, whether the plant is there or not. If there is a plant, sniffer dog will say there is a plant inside that. So the people can go and see the area. Then enhanced surveillance can create weather trade, all these things can be done. Then another thing is portable molecular, we have got PCR kits are bringing lab level detection to the field. Formerly, if you want to go into for any identification, we have to go to the laboratory. But now portable kits are available. Regional cooperative strengthening is there. Then public-private partnership is there. Capacity building is there. Training models. So these innovations show that biosecurity can evolve from being reactive to being proactive. So that is a thing. It's not moving. Can you? So now we'll just go to the Kerala study. See, for 2 years, I did a detailed work of the agro-biodiversity of the states of 8 districts. These are the 8 districts. Now the remaining 6 districts are being done. I am not involved in that. I was leading this particular work. And we found out that 1,659 varieties of plants are there in this agro-biodiversity, not this thing. Then, interestingly, so these are the plant food varieties. I am just giving only the fruits here since it is horticulture. Say all the red ones that you see here, all these things, apple, apricot, all these things, dragon fruit. I questioned them, from where did you get these plants? Their reply was, I went to abroad and I brought a couple of plants. So they came to India, they came to Kerala not because of ignorance. There is another reason also there. Because a Kerala Awards. Is it not? Best biodiversity farmer in Kerala. They never bother about from where the plants have got. They are giving an award to a farmer who is having the maximum biodiversity. So he is trying to bring in, say there is a farmer in Wayanad where there is a very good collection of apple. He has brought even apple cuttings from Israel. So these are all these things from different parts without quarantine. Without quarantine. Say introductions, for example, jackfruit, rambutan, all these things. They are not brought in without this thing. I'll just give a grey markets, the nurseries, this thing there. Native loopholes. See, this is the native loophole. We are bringing in new varieties of jackfruit. And they are finding no problem in this. Why? Because they say that jackfruit is available in Kerala. So what's the problem if I bring a new variety? Jackfruit is originated in Western Ghats. So they think that is a loophole. They are saying that jackfruit is there in Kerala, but a new jackfruit, if I bring it, mango is available in Kerala, a new, they are not saying. They think that ignorance and negligence are the part of travelers, officials. I told you about the Calcutta airport, so all these things happen. This one, just read this. ഏകദേശം 20 വർഷങ്ങൾക്ക് മുൻപ് ഔദ്യോഗിക കാര്യത്തിൽ തന്നെ മലേഷ്യ എത്തിയ കാലത്താണ് അയാളുടെ പേര് ഞാൻ വിട്ടിരു ഡ്രാഗൺ ഫ്രൂട്ടിനെ അടുത്തറിയുന്നത്. അവിടുത്തെ വിശാലമായ ഡ്രാഗൺ പഴത്തോട്ടങ്ങൾ കണ്ട് മടങ്ങുമ്പോൾ കയ്യിലൊരു തൈ കൂടി കരുതി. നട്ടു വളർത്തിയ തൈ വളർന്ന് വലുതായി രുചികരമായ പഴങ്ങൾ വന്നപ്പോൾ കേരളത്തിൽ ഇതിന്റെ കൃഷി സാധ്യത ബന്ധപ്പെട്ടെന്ന് ഇതിലേക്ക് തിരിഞ്ഞു. ഘട്ടം ഘട്ടമായി വളർന്ന് കൃഷി ഇന്നിട്ട് നിൽക്കുന്ന 20 ഏക്കറിലും വർഷം കണക്കാൻ ടൺ കണക്ക്. This I took from a journal published in May 2026, a case study. This is the case with almost all fruit crops. I just purposely erased the name of the person and the name of the farmer and all these things. So what does it show? Then next comes in the paper advertisement, dragon krishi cheyu, swarnam koyu. Is it no? Is it not? All the advertisement is like the newspaper is. That was what at one time that was the typical of a root crop. It was that Viagra. What is it? Huh? Whatever it is. Not vanilla. No vachola. It is it is sama. You Sornam Kayu. That is a nursery in Pune. That thing is there. It's a Viagra, something producing Viagra. No. And their advertisement is you cultivating that crop, then that suddenly comes coins of gold. Everyone started cultivating that without knowing from where they got it. So this is the problem. In many of the nurseries, they bring in new varieties. None of the government is questioning the nursery from where they got the plants. So that's a biosecurity problem faced. So then question comes, why no court cases? So they're saying, in most cases, the reports are settled through the administrative orders rather than litigation. So far in Kerala, there was not even one case. It is for Srikumar to take up. He's into all these things. I can't do that. So because I don't have the capacity. He has got the capacity. He can fight. Why there is no court case for introducing plants into Kerala? Say, if it is a new variety is identified, they issue report to the Krishi Board. What do they go to? Krishi Board. Then they go to the BMC. BMC, they enter into the PBR. KSBB, Biodiversity Board, issues a technical advisory. This is introduced plant. Then they may go back to the department. The department say, we already reported. There is no case. There is no case. So it is solved. Suppose in all our airports, if there is a poster saying that if you bring it, the punishment is for 10 years imprisonment, at least we may, it is equivalent to smuggling. So we may do. Why can't we do that? It's a small thing. This is the. So if you have got all the strategies, all rules and regulations, they can either mitigate risk or preventing introduction, create risk. Say the success of biosecurity efforts depends on how well the government policies align with the One Health principle, which require a careful balance between economic, environmental, social health related technical scientific consideration. Do we have adequate biosecurity regulations? I'm asking you, do we have revisions? But the answer is yes. We have got Kerala Plant Disease Pest Act in 2025. In 2025, they have got a new rule. And biodiversity rule 2008 of KSBB, including illegal introduction of exotic species. So there is a rule. Then there is a maintaining biosecurity KSBB 2025-35. So here, a key pillar is the move towards white list for nurseries. What is a white list? We can give a nursery a white thing where if the nursery is good, they are permitted to bring in new plants. They should give all the other plants are not allowed. Then can utilize. We are using the Toilurpu. Why can't they use Toilurpu to kill all the new plants? So we just give them a list. These are the plants. Wherever you see, you kill it. So we can do all these things. Policy circles, we have got different policy. I'm not going to the star rating system. We are planning to KSBB, because I am also now involved in KSBB. So KSBB thinking about a star rating of nurseries. We can star rate nursery, 1 star, 2 star, just like our fridge, 1 star fridge, 2 star fridge. So you can star nurse, 1 star fridge can, or nursery can bring in these plants. Second, like that, 5 star, we can bring all these things. Traceability, coding, all these things. Then phytosanitary amnesty, health audits, pest risk analysis, all these things. Then here, potting mixture, I told you about potting mixture. We have got a fungus like Phytophthora, Fusarium, Pythium, bacteria, Ralstonia, nematodes, weeds, soilless medium. But there must be some method other than the soilless medium. Soilless medium in the research stations is possible. But in a large billions of planting materials, there must be some method. We have to think about some other method for these things. So these are in short, because I pass about 10 minutes more. Every planting material carries two possibilities: the promise of productivity or the peril for pest invasion. Our responsibility as scientists is to ensure that only the promise prevails. So that is in short about biosecurity. Sorry that I was not able to do justice to talk, because I didn't have much time for that. So thank you very much. Thank you.
Thank you, Pidambaran sir. A very relevant topic. And also remembering about Samraj sir. One minute, sir. We have 1 minute. Some questions or queries can be made. 1 minute only. We are running around 1.5 hours behind the schedule. So we have and sir will be with us tomorrow also, no? Today.
Tomorrow after
so
12
there is
o'clock.
sufficient time for interaction with sir. Sir, I have one question only. Recently, the central government has introduced bulk plant import scheme, no? So that is, and is that not bringing lot of insects and other problems?
See, during, I'll just give you feedback. During 1950s and 60s, PL480 scheme, we have acute shortage of food grains in India. With the result, we permitted wheat to be imported. Along with the wheat came all your parthenium, all these things. There was no other method, way out. So once we are self-sufficient in food grains, now we are worried about the fruits, horticulture crops. The government is taking up steps just to make India the horticultural hub of the world. For making a horticulture hub of the world, we want the best varieties from different parts of the world by beg, borrow, or steal. So one of the method is to bring in large quantity, and along the merchants are very, very, very accommodative, or in the inverted comma accommodative. They bring in new varieties without this thing. So that's it.
Many of the pests were detected in Coimbatore area, near Pollachi Coimbatore area, where large number of nurseries are there. They are bringing a lot of ornamental palms. Along with that only, all the white flies came, which are severe pests of coconut nowadays.
See, the problem here is we are looking at the short-term benefits. We are not looking into the long-term benefits. Short-term benefits, if you bring in a new variety, the nursery can multiply. A few articles, a few advertisements here and there, the persons are there to buy it. And that is the easiest method by which a pest is spread throughout the state or throughout the country at a very short time. So that's happening, I think. We don't have, and first of all, ignorance. I basically think it is all ignorance. See, you will see a fundamental difference in airport. If you paste a thing near the entry point, you bring a plan, 10 years of imprisonment, no questions asked. See, nobody's, that is a simple thing. Just like the Singapore, you put a board, you'll be killed if you have got a drug. So that's why the least drug trafficking is taking place in Singapore. Death is the punishment, no questions are. If you have got even a gram of MDPA, they will kill. Nobody knows about it. Nobody knows whether he is live or dead, but he is not there. Yes.
Dandelion. Recently, I have seen dandelions in Kerala. So weed in temperate countries.
Yes.
It is present in Kerala. I have seen in 1 or 2 places.
See, there are,
be very conscious about it.
There are different, you see, one main problem which are facing by us. See, you read many of the new journals and magazines. They are, again, these issues of the journalists I showed you, they are criticizing the government and Kerala Agriculture University not conducting research on the newly introduced fruit crops of Kerala. But the question is, we have not introduced, officially we have not introduced. So how can you work on that? So that's the one thing. And another thing is, our syllabus is at least 20 years behind. We are also responsible for that. We are not teaching them, we are teaching, do you know, in Kerala, we are giving maximum number of hours for teaching paddy. Is it not? In package of practice workshop, even 1 day is spent on paddy. What is the area of paddy? We are not spending even an hour on fruit crops. Is it not? Our syllabus, you see, we study the disease and pest of paddy, all the details of paddy, but are we teaching them the pests of newly introduced crops? It is not there in the book. The teachers are ignorant about it. There is no book on this thing. See, so that is a problem. Our syllabus has to be revised at least once in 2 years. And introducing all these things. And even now, the entomology and plant pathology syllabus is cut short every year. Is it not? Formerly, when we were studying about, there are 4 or 5 courses. Now only 2 courses, I think. That's all. So that is it. So these are some of the problems that is faced by now.
Sir, I have one query, sir.
Yes.
Sir, I was in ACRP nematode project, and in that we have introduced the documentation of horticultural nurseries to what extent the nematode infestation in nurseries, and we have collected samples from many nurseries, and there is 80 to 90% of the fruit crops, especially guava, pomegranate, and the black pepper seedlings were infested with nematodes. So, even though we report it to the Department of Agriculture or horticulture, horticulture mission, but there will not be any initiative from their part, or even for collecting the samples, they will not assist. And we have to pay money to purchase the infected seedlings, and we have to check whether there is infestation or not. And many of the guava seedlings were infested with the Meldog and Enterolobi, and many of the seedlings were coming from nurseries in Andhra Pradesh. So, and even this potato cyst nematode, which was reported only from Nilgiri Hills, now spreaded to the Himachal Pradesh, Uttarakhand and Jammu Kashmir area in Patni Top. From there, the samples showed the presence of the cyst. So this is the condition in our country. So what we can do? Because
see, we long back, a potato research station was established at Kufri. Why at Kufri? Because there the pest cannot survive, is it not? But now, even in Kufri, the pests are there. And another thing is, those days we spotted the area for to start a nursery, knowing that this particular area doesn't have any pest and diseases. But now we are having say, a research station by push and pull. Sugarcane research station was started at Coimbatore after a series of research. But now they say we want it here, even if sugarcane is not growing. So nematode is a big problem now. Kadayam is the area which exports maximum number of plants throughout the world. You can trace all the nematodes. And interestingly, I contacted a nursery person in Kadayam, one of the leading exporters of plants. I told them I want the samples to be tested. He said 101 excuses, said there is no facility, all these things. He was exporting in millions of rupees. So I am going there next week just to find out, but he won't allow me to enter his nursery. I am sure that. So what to do? It is a mad on my part to do. It's only my personal interest. I am doing all these things because I don't have any other work to do. So I just doing all these things. Yes. Thank you. Thank you very much.
So it was a very, very
Thank you.
interesting and very interesting session. Sir is available for interaction with us. Please.
Thank you, sir. I humbly request Dr. K.M. Sri Kumar to confer the MPPS Professor J. Sam Memorial Lecture Award 2026 to C.K. Pidambaran, sir, in recognition of his outstanding contribution to the field of plant pathology. Thank you, sir. Now I request Dr. Sainamol Kurian to present a memento to C.K. Pidambaran, sir, as a token of our gratitude on behalf of Malabar Plant Protection Society. We are also presenting a gift to C.K. Pidambaran, sir. I request Sainamol ma'am to present a memento to the chairman and co-chairman of the session. I request Sainamol ma'am to present a memento to the chairman and co-chairman of the session. I request Nisha ma'am to come over the stage and receive the memento. Thank you, ma'am. Here we begin the first technical session of the seminar, which focuses on phytomicrobiome, soil chemical ecology, and next generation phytoprotectants for the plant health and food security. Chairman for the session is Dr. C.K. Pithambaran, former Director of Research, KAU, and co-chairman is Dr. Joseph Rajkumar, Principal Scientist, CPCRI, Kayangulam. Rapporteurs for the session will be Dr. Sanju Balan, Dr. Dalia Mole, Dr. Krishnashri V, Mrs. Leena MK, Mrs. Shaili C, and Dr. Manju KP. Humbly requesting the chair and co-chair to conduct the session.
Hello. We are starting our technical session. The technical session first is phytomicrobiome, soil chemical ecology, and next generation phytoprotectants for plant health and food security. The first talk, lead talk is by V.G. Malathi, Principal Scientist retired of ICAR IARA, New Delhi. She'll be doing it online. Her research focus has been on the characterization, diagnosis, comparative and functional genomics of whitefly transmitted gemniviruses infecting green legumes, cotton and tomato. So she's also worked in different other crops. These viruses are different crops. And she has received several awards and recognitions based on her work, including the Best Teacher Award, the Askuta Memorial Award, Kauzami International Award, Best ICR Award, DBT Task Force Lifetime Achievement Award from Phytopathology Society. So I request Dr. V.G. Malathi to give the first lead talk on phytomicrobiome. Dr. Malathi, please. Yes.
She was there. She was online. Yes. Dr. Bharati, can you? She's on a phone. Dr. Malati, can you hear us? No, it's not audible. I think I see unmute. Please unmute. No, not audible. Something not audible. Did you have to unmute? No. Sorry, Dr. Malabi, it's not audible. We are sorting it out. We are sorting it out, please.
Ma'am, can you hear?
No, she cannot. Sorry, Dr. Malati, there is some technical problem. So we'll connect you after the second lead presentation. Second lead talk is by Barin Petros, Professor, Department of Entomology, Kerala Agriculture University. So Barin Petros started as assistant professor in the Kerala Agriculture University, and he is holding a charge of director planning in Kerala Agriculture presently. He is the professor of entomology in entomology department. Is a scientist which I appreciate highly for his publications. He had about 90 publications and about several books. Apart from that, he is basically a person who is easily approachable by many in the field of entomology and plant production. And he received several awards. And I know he's a good scientist on this field in plant production. So I request Barin Petros to deliver the lead talk.
So, good afternoon all respected Pidavaran sir, Joseph sir, Sri Kumar sir and all the faculty, scientists, students over here. It's indeed a great pleasure and honor to be back to this campus where I learned the basics of entomology from Srikumar sir and other teachers. So the topic I have chosen for this is how we are moving ahead from the traditional target sites for insecticides. If we see how insecticides evolved, we are moving on to newer and newer target sites for achieving better specificity, better selectivity, and also to reduce the mammalian toxicity. So what I will be presenting can be a bit higher level. Usually this topic I used to teach them for PhD students in their advanced toxicology course. So please bear with me because this is a diverse audience consisting of entomologists and pathologists. So please bear with me if it does not suit your interest, but I have tried to simplify it as much as possible. So let's see a quick recap on the history. 1939 we had the DDT, Paul Muller, though it was synthesized way back in the 1870s. Then in the 1940s, all the organophosphates along with the other organochlorines or carbamates came in 1950s. Synthetic pyrethroids, and put it as 1970s because the photostable pyrethroids came in 1970s. 1960s it was photo-unstable. I'll give you a timeline later. And if you see all this, up to about 1990s, these four major groups, organochlorines, organophosphates, carbamates, and synthetic pyrethroids. That means from 1940 to 1990s, almost 50 years, we had only four major groups of insecticides. Most of them were acting on sodium channels, typical examples DDT and synthetic pyrethroids, GABA-gated chloride channel inhibitors, that includes cyclodines, and acetylcholinesterase inhibitors you all study with the organophosphates and carbamates. All of them were neurotoxins. So this is just the timeline. 1940 and 1950 we have organochlorines, cyclodines, organophosphates, carbamates. 60s we have the photo-unstable pyrethroids, Niristox analogs. Still we use Cartap. So that was way back in 1960s. 1970s we got the photostable pyrethroids, one of the older group of pesticides still going strong in the pesticide market. That is photostable pyrethroids. Octobabine agonist, we have only one insecticide in that, Amitraz, not widely used in agriculture but in veterinary entomology it's used. 1980s we had the avermectins, still widely used. 1990s saw the landmark year with the introduction of neonicotinoids. Still, this occupies almost 25% of the global pesticide industry now. That's how the neonicotinoids rule the agrochemical industry. We have pimetrozin. I will discuss in detail about pimetrozin later in my slides. 2000s we had diamides, another landmark group with targeted entirely new site. It's muscular poison acting on rhinodine receptors. We have oxidizons, only one insecticide, not much used now. Spiromazepin, the acetyl-CoA carboxylase inhibitors. Flunicamid, again another pesticide we will discuss in detail. In 2010s, we have the metadiamides, though this group of pesticides was introduced into our country only 2-3 years back, but it was discovered and introduced in foreign markets in 2010. And 2020, we are still in 2026. See the number of groups which was introduced. I have taken the year not according to the year of discovery, it's according to the year of introduction in the market, globally, anywhere in the global pesticide market. Isoxazolines, acinonapyr, that's only a single pesticide with a new mode of action. RNAi, we are familiar with it. Then dimpropyridas, oxazosulfide, all those are in 2020s. So this is just a timeline of how pesticides are being introduced. Now, before going into how these pesticides, the new pesticides differ from the older pesticides, I will just try to see how the pesticides act on different points of the insect nervous system. The first entomology course, the fundamentals of entomology, we have an insect nervous system and we study about the neurons, how impulses are transmitted and all. So let's see a bit about it, then we will go into it. And it's not a theory, sorry, because it's a diverse audience, that's why I picked it up. See, if you see, we have the synapse. On the synapse, we have different kinds of receptors to which the neurotransmitter binds. It can be nicotinic acetylcholine receptors, I call it nicotinic acetylcholine receptors because till now we have only insecticide targeting nicotinic acetylcholine receptors. We have glutamate receptors, we have GABA receptors. On the axonic conduction, we have sodium channels, we have pesticides acting on sodium channels. Once the impulse reaches the muscles, we have acetylcholine, the neurotransmitter, we have insecticides acting on acetylcholine esterase enzyme which affects the synaptic transmission. Then we have insecticides acting on the muscle contraction, that is rhinodine receptors. So if we see the insecticides at these points, phenylpyrazoles are, most of the entomologists may be familiar with, the students may be familiar with the chemical fipronil, which is acting on this GABA-gated chloride channels. Then we have avomectins, which we are acting on the glutamate-gated chloride channels. Nicotinic acetylcholine receptors, we have multiple insecticides, major one are neonicotinoids and spinosins. Sodium channels, we have pyrethrins, pyrethroids, oxadiazines, semicarbazones. Both of them comes under the same group. And acetylcholine esterase, we have OP and carbamates. And on the neuromuscular point, on the muscles, we have the rhinodine receptors. This is still the most common modes of action of most of the pesticides in now registered in the country. So this is a tabular format of what I described. Acetylcholine esterase inhibitors, we have OP and carbamates. Sodium channels. Specifically, if we see the Iraq mode of action classification, even though we say that it is acting on sodium channels, specifically if we see, it can be a diversified mode of action. Modulators are DDT and pyrethroids. Blockers, we have oxadiazines. The name of the pesticide is indoxacarb, which is a sodium channel blockers. Hope the audience have a bit of understanding what is a modulator and a blocker. Then on the GABA-gated chloride channels. In the previous slide, I have shown you phenylpyrazole, which is a GABA-gated chloride channel blocker. In the timeline, I have mentioned about metadiamides and isoxazoline. Both is a new mode of action that is again acting on GABA-gated chloride channel, but it's not a blocker, it's an allosteric modulator, metadiamides and isoxazoline. Nicotinic acetylcholine receptors, we have neonicotinoids discovered way back in 1990s. They are competitive modulators. Spinosyn, bit old allosteric modulator. Blockers, oxadiazines. So there are not much new pesticides in the nicotinic acetylcholine receptor group. Coming to glutamate-gated chloride channel, we have only one, avomectins, bit old. Octopamine receptors, again it's a bit old, amitraz, only one, not of importance to agriculture. Acetyl-CoA carboxylase inhibitor, we have spiromycin, spirotetramat, etc. Again, almost 20 years old. Rhinodine receptors, we have diamides, again 20 years old. See the next one, chordotonal organs. In the chordotonal organs itself, we have three types of action. It can be inhibiting nicotinamidase. We have an insecticide called flunicamide. Then we have a target site, again on the chordotonal organs itself. That is TRPV channels. We have three insecticides, pimetrozin, pyrifluconazole and afidopyropen. Then there is one more insecticide which is acting on the chordotonal organs itself, but their exact site of action is not yet identified, that is dimbropyridas. So if you see chordotonal organs, it was not a target site. Pimetrozin was discovered in 1980s if you see the timeline, but its mode of action was not yet discovered. If you have followed the Iraq mode of action classification, till about 2020, it was classified as unidentified. it was given a gray color because it was, the mode of action was not a so once it was discovered, it was placed in the chordotonal organ. Then 2 years back, it was clearly placed under TRPV channel. So this is the specific mode of action, one novel target site for insecticides. Now, the next. If you see the channels, ion channels in which in the insecticide targets, we have sodium channel, we have GABA-gated chloride channel, we have glutamate-gated chloride channels, etc. We didn't have any insecticide targeting potassium channels. Now, we have an insecticide which is targeting potassium channels, which is calcium-activated potassium channels. I will come to it in detail. It is modulating the calcium-activated potassium channel, that is acinonapine. Then, RNA, I don't think that it is in books and in the laboratory. Commercially, an RNAi based sprayable pesticide is available in the US market. Its trade name is Letprona. And the last one is an extremely interesting mode of action. Last year it was introduced, that is vesicular acetylcholine transporter inhibitor, oxazosulfide. So I'll be concentrating only on the 3 to 4 novel target site for insecticides. First, GABA-gated chloride channel allosteric modulators. Blockers, phenylpyrrosol, fipronil are blockers. These are allosteric modulators. So if you see the GABA-gated chloride channel, this is the ion channel. If you see this is the binding site for fipronil. This is the binding site for fipronil. Fipronil binds over here, it blocks this ion channel. Whereas the metadiamides and isoxazolines binds at a different site. That's why it is called as an allosteric modulator, not the exact site. Binds at a different site and modulates the activity of this GABA-gated chloride channel. That's how the same target site, but a different mode of action. One more thing, the people might be wondering how it brings selectivity. So GABA-gated chloride channels are present in humans also, how it brings selectivity. Fipronil is an insecticide which is marketed for household pesticide use also. So we can use it in our household. So how it becomes selective? See, if you see the specific structure of GABA-gated chloride channel, in insects it's a homopentamer. That means all the protein subunits are of the same structure. Whereas in the humans, it is a heteropentamer. That means the subunits are different. We have alpha as well as beta protein subunits. So that makes the difference, that makes this target site unique for us. Brings selectivity to insects and less toxicity to human beings. Now, chordotonal organ. The first few classes of morphology, insect morphology itself, we study about a chordotonal organ. Most of the students of entomology and agriculture will be familiar with that Johnston's organ present in the second antennal segment. So we are familiar with this term, chordotonal organ. They are internal mechanosensory receptors. Mainly they are stretch and sound receptors, and they are mainly located in the joints, exoskeletal joints and body segments. So their major role is detecting the limb position. If consider this as a joint, these chordotonal organs will be located in these joints, and whether the limb is stretched, extended, or the position of the limb will be conveyed to our body with the help of this chordotonal proprioception. It also detects gravity, vibration, and sound. In insects, the common examples are Johnston's organ, subgenual organ, and tympanal organs for detection of sound. So let's see it one by one. We had seen 3. One, the mode of action is still not identified. The other 2 are acting on nicotinamidase inhibitor, and the other one is on TRPV channel, transient receptor potential vanillate channels. So on nicotinamidase inhibitor, we have the pesticide flunicamide. So this nicotinamidase, this enzyme is present in the chordotonal stress receptor neuron, and the role of this nicotinamidase is to convert nicotinamide into NAD+, nicotinamide adenine dinucleotide. So that is the role. So if nicotinamidase is inhibited, it will lead to the accumulation of nicotinamide. So that is how it works. So flonic amide, once we are applying, it leads to the accumulation of nicotinamide. So here, if you see this picture, this is from the paper, 2025 paper, which has clearly described how it acts on it. So this is the control container. Drosophila exhibits negative geotaxis. That means if we keep Drosophila in a container, it will tend to move upwards. That is the control. This is a container where we release Drosophila and Drosophila tends to move upward. But if we apply flonic amide onto it, it loses its ability to detect gravity. You see, its ability to move against gravity is lost. Most of them are remaining at the bottom of the container. That's how it affects the insects. So that's the unique mode of action. Now, coming to the next codotonal organ, TRPV channel modulators. I forgot to expand it. TRPV channel means transient receptor potential vanilloid receptors. Transient receptor potential receptors are very common all over the animal world. Scientists are now increasingly working on these receptors. 3 years back, I forgot the name of the scientist, they received Nobel Prize for Medicine or for their research on transient receptor potential channels. There are at least 7 such channels. If my memory is correct, there are 7 such channels. One is vanilloid receptors. Again, they are involved in the detection of vibration, gravity, and stretch, and they convert those signals into electrical signals. So the examples are pimetrozin, afidopyropin, etc. See the grasshopper treated with, first is DMSO, that's the control. Second is treated with pimetrozin and afidopyropin. I took the example of the extension of the limb. See, the grasshopper has lost its ability to detect how its saltatorial leg is positioned. It will always be kept in a stretched position. So that is how these insecticides act. Pimetrozin and afidopyropin. The earlier one was flonic amide. All of them acts on codotonal organs, but at different target sites. Now, calcium activated potassium channels. See, if you see the potassium channels, ion channels, potassium channels are different types in insects itself. It can be voltage gated because a change in the voltage can lead to the opening and closing of the channels. There is inwardly rectifying potassium channels. We call it, abbreviate it as KIR channels. The another one is calcium activated potassium channels. The opening and closing of these potassium channels is controlled by calcium. One typical example is acinonapyr. This is not an insecticide, this is a typical acaricide. Why I took this is the first insecticide to act on potassium channels. So scientists have started looking into other more target sites, including potassium channels. Now, coming to the last novel group, vesicular acetylcholine transporter inhibitor. This is pretty interesting. This is the thing which we all know, the synaptic transmission which we have studied in our UG itself. We have the synaptic vesicles. Once the signal reaches over here, the synaptic vesicle reaches over the presynaptic membrane, releases the acetylcholine. Acetylcholine binds to acetylcholine receptors. In insects, we have 2 kinds of acetylcholine receptors. One it is nicotinic acetylcholine receptors and the other one is muscarinic acetylcholine receptors. We don't have any insecticide acting on muscarinic acetylcholine receptor. Maybe the next 10 years we may find an insecticide acting on muscarinic acetylcholine receptors also. So, to stop the signal, this acetylcholine will be acted upon by acetylcholine esterase enzyme and it will be broken down into choline and acetic acid. This choline will be taken back to again synthesize acetylcholine into the presynaptic membrane. Then choline acetyl transferase will again resynthesize acetylcholine, and this acetylcholine will be brought back into the synaptic vesicles. This transport of resynthesized acetylcholine into the synaptic vesicles is through vesicular acetylcholine transporters. Now we have insecticides which inhibit this process. Vesicular acetylcholine transporter inhibitor. So what happens? There will be synaptic vesicles. These synaptic vesicles will not be having any acetylcholine. Even if the signal reaches over here, the acetylcholine will not be available to be released into the synaptic cleft. The signal transduction will be lost. Only one insecticide is still discovered, that is oxazosulfide. This is a broad spectrum insecticide. So, the next is RNAi. That's what I told. This is not in the laboratories. Now it's in the market. So, we all know what is RNAi. We'll have double-stranded RNA. This double-stranded RNA can knock down essential genes and lead to insect mortality. RNAi can be of three ways. One, it is the gene silencing can be in three ways. One, it is host-induced gene silencing, spray-induced gene silencing, and virus-induced gene silencing. Host-induced gene silencing is nothing but a kind of transgenic. We insert the gene to produce the double-stranded RNA in the plant itself. But we all know how transgenics work, how the regulatory hurdles are extremely difficult to overcome in transgenics. The second is spray-induced gene silencing. Just like a conventional pesticide, we can spray it over to the crop and lead to RNAi or gene silencing. Virus-induced gene silencing. The gene for producing this double-stranded RNA can be inserted into a baculovirus. The baculovirus infection will lead to the production of double-stranded RNA in the insect and can induce gene. I will be mainly focusing on spray-induced gene silencing because that is how the conventional spraying way of pest management will be done. So, in the spray-induced gene silencing, usually double-stranded RNA will be sprayed. It's not usually injected. So, when the insects feed on the plant, chew or suck on the plant, the double-stranded RNA will be activate. But the major problem is those who are working with DNA and RNA know their stability. We need specific kind of formulations, stable formulations, so that the RNA can be sprayed in the environment on the crop and remains stable. So, a company in US has registered a product, Ledprona. They have branded it as Calantha. This is the first sprayable double-stranded RNA pesticide. It targets Colorado potato beetle, Leptinotarsa decimlineata. One of the major drawbacks with spray-induced gene silencing is it is mainly targeting coleopterans. Till now, they are not yet found out a double-stranded RNA targeting lepidopterans and hemipterans, commercially viable. Paper-wise we can see, theoretically we can see. I am concluding, I am not taking too much time. So, what are the takeaways from this? The advances in the insecticide target discovery have significantly expanded the scope of pest management. We have novel targets, codotonal occurrence, calcium activated potassium channel, vesicular transport systems, and RNAi, which demonstrate the sophistication in insecticide management technologies. And these novel targets provide better selectivity and low toxicity to mammals. And this will help in mitigating resistance and less damage to the environment. The future success of the use of this pesticide depends on innovation, regulation, and ecological sustainability. Thank you.
Thank you, Berin. I know that many of the students and the others The topic might have gone about. I know that. But that is the problem of our syllabus. Again, coming back to syllabus. We are even now teaching the old insecticides and fungicides, but not to the newer skill. I was just remembering about the Muller's. Muller got his Nobel Prize in 1948. But his Nobel Prize, even now I remember his Nobel Prize lecture, where he said, I have invented a chemical which can kill all the pesticides, irrespective whether it belongs to one group or other. And he got a Nobel Prize for that. Similarly, in fungicides, even though he did not get a Nobel Prize, mercury, the same action, they said that mercury can kill all the fungi.
Yes.
And both these things are banned. Both the things are banned. But see, in many of the books, I am just coming to the syllabus project. In many of the books, we are now even teaching DDT, we are teaching mercury, and spending even half the semester on teaching all these things. So no, that is the one problem that you are going to face. And this one, unless we teach the students, the agricultural officers, of the newer molecules of pesticides, we won't be able to manage the pest in a safe method. So that is exactly what I am saying. So thank you very much. So this particular thing.
Once I prepared the slide yesterday, I sent it to my student and now a faculty of Kerala Agriculture University. She is very good in the mode of action of insecticides. So she said one thing, sir, covered things well, but she was afraid of what it may go above the head of most of the lay audience. I was a bit sure about it, but at least I should throw some light on what is happening in the pesticide discovery. We can't discuss on rhinodine receptors and diamides still, because the world is moving before that.
Wonderful, Dr. Barin. I think the audience can give him a big salute to him, because that was a wonderful piece of information from the entomological point of view. Why I say that is, when a new generation molecule comes, where it acts, how effectively it acts, and how it is safe to the mammals. That is what the important topic is all about. We are all worried about the human safety. So in that case, these new molecules are definitely fitted to that. So big salutes to Dr. Barin to that. One small question, how many of these new generation molecules are registered in our country?
Sir, if you see the codotonal organs, all the three groups are now registered. Flonicamid is there, Ulala is there, Pimetrozin, Chess, currently now it's off patent, so multiple trade names are available. Dimpropiridas, I forgot the trade name, last year it is launched. Aphidopyropin, its trade name is Cefina. Bayer is now marketing at least 4 years in the market. Acinonapyr and oxazosulfide. Acinonapyr, I heard it is registered in the country. Oxazosulfide trials are going on, not yet registered. So metadiamides. Broflanilide is registered, isocyclone is cycloserum is registered, fluxametamide is registered. All the three are currently available in the market.
I think, thank you, Dr. Barin. Now for what up?
I wrote a book on pesticides long back, and the second edition has just come out. It's in Malayalam, as the language institute wanted. None of these chemicals are there in the book. So that book, there's a demand for the book, but unfortunately none of these things are there in the book. So they are ignorant about all these things. I just a request that is applies to this Malabar, our Plant Protection Society, and the Department of Entomology and Plant Pathology. See, if the speaker agrees, they should keep all the PPTs in the thing, because otherwise, say, that may be of use to them in a future date. But what happens? These presentations, they don't bother. They can always change their presentations. So if they keep their presentations in a just like the library, PPT collections. They can use it for the teaching. Then also because preparing these PPTs are difficult, not that easy. So either the society or the college should take initiative in collecting all the presentations, not only today's, all the presentations wherever you get. Presentations, a storehouse of presentations of all the talks, or wherever you get. So that would be nice. We can think about that. The society can take the lead. Thank you very much. Any questions, please?
We can do that. Very wonderful. Lucid presentation, Dr. Barin. Congratulations.
Thanks, sir. Thanks.
Now, many of the people, administrators, and politicians, everybody are the prisoners of Silent Spring, I would say. Still they are the prisoners of Silent Spring, but we have a lot of newer molecules, and this quite new array of new molecules you have just presented to the audience. Very wonderful. What about the price of these chemicals? Are they too much heavy, high priced?
I will just take the example, recent market trend. See, 2008-9 we saw the introduction of chlorantraniliprole and flubendiamide. At that time, the roughly a per acre application rate for a chlorantraniliprole used to be about 1,100 rupees. If it is further, the granular formulation, it was somewhere about 1,000. Coragen sprayable formulation, if including the labor charge, it will come to 1,100 rupees. Now, last year, they have introduced tetraniliprole. Last year they promoted it vigorously, tetraniliprole. Roughly, the cost has doubled to the farmer. It's almost 2,000 rupees per acre. So that's the cost. So what we suggested the farming community in Thrissur last year, Thrissur and Palakkad, because now I concentrate on the rice farmers of Thrissur and Palakkad. What we suggested, because we had a very extremely good study on the resistance of leaf folder across the state.
I've seen that paper.
Yes. So we had an idea which older molecules are working.
That is an indirect indication to stop that discussion. Okay. So we'll stop the discussion.
Okay, just a minute. I will just finish up. So what we found out was, acephate there was no cross resistance. Cartap there was no cross resistance. So fipronil there was no cross resistance. So all these three are cheaper molecules. So we gave a rotation with these three molecules, avoiding the costly newer molecules. Still we have older molecules which is working.
So thank you, Barin. Okay. As a token of appreciation, we are going to give you a memento. So please, the society can. Jyotirakshmi, Dr. Jyotirakshmi or Dr. Marathi?
So, Madam, I think we are running short of time. For want of time, you can restrict your talk to a period of 15 to 20 minutes. Sorry for this, because you are a wonderful teacher. We would like to listen to you. Over to you, Madam, please. I think she.
Ma'am, please check whether it is audible.
Hello, good afternoon, everybody. Am I audible now? Yes, ma'am. Am I audible now? Yes, ma'am.
Yes, I'm so sorry. First, I apologize to all of you, but there has been some technical glitch, I don't know what. And respected chairman, co-chair, and other organizing committee members, thank you very much for inviting me to give a talk. And before I get into it, Professor Pidambaran talked about Samraj. Sir, just to let you know about myself and Sumia, we worked more than 50% of our scientific career I spent on the virus that Samraj had been trying to characterize. So it is such a nice coincidence that today is Samraj's commemorative lecture, and I got an opportunity to talk to all of you. Thank you very much for that. And in fact, my previous speaker introduced the topic of how RNAi is used. As he said, it's no more a theoretical imagination, but a practical thing which we have to quickly follow. So I will just briefly summarize. My next slide, please. And see, there are small RNAs between, my next slide, please. Next slide, please. There are about 21 to 24 nucleotide length small RNAs. Hello, next slide, please. Next slide. See, these small RNAs, we are very familiar with messenger RNA, and this is to briefly tell you, what I'll be talking about. Next slide, please. So we are familiar with, next slide, please. We are familiar with messenger RNA and transfer RNA, and there are 4 more small RNAs, but the 2, the miRNA and siRNA only I'll be concentrating today. And next slide. miRNA is generated from the genes that are already present in the plant. So from the endogenous gene, miRNA is generated, which will be complementarily alleling with the mRNA and either repress the translation or inhibit it totally. Next slide. Whereas the siRNA is generated from next slide, please. The siRNA is generated from a double-stranded RNA intermediate, and it goes through the RNA-mediated silencing complex, and then it is chopped into 21 to 24 nucleotide siRNA. So we are familiar with all that. Next slide. But in 2013, next slide, please. 2013, it was shown that these small RNAs are traversing from one kingdom to another. That means from plant to the pathogen and from pathogen to the plant. And this is now called as the cross-kingdom RNAi. It is RNAi, but across the kingdom. And that is a new tool or the technology that is being used, and it is available now. Next slide, please. But it is not that we were not aware of it. We were aware of it, but now we have got tools to identify it. See, this is what is given as a graphic representation here. From the fungal pathogens, the small RNAs are produced, which will enter into the host cell, targeting the immunity-related genes. When I say immunity-related genes, all those defense mechanism genes like PR protein, PR1, 2, 3, or any of the MAP kinases, or any of the pattern receptor kinases, any of these genes which are activating in the defense. The same way, the host plant also produces small RNAs, which will be cutting across through the cell wall, through the plasmodesmata, enter into the pathogen, and then, affect the virulence genes. Next slide. So this concept is available, but how do they move? What is the proof for it? And that was given by Kai et al. By electron microscopic studies. If you can see it, all those infected plants always produces what you call as vesicles, the membrane outlayered vesicles. So these RNAs are packed in these vesicles, and vesicles move across the plant, through the plasma desmata into the pathogen. And this was shown definitely in the case of botrytis cinerea infected Arabidopsis. So we know now that it moves within the plant across the vascular system, and we know that it moves from the host cell into the pathogen cell. Next slide, please. Next slide. And it's not that we were not aware of it. For example, Plasmodium para, the malarial parasite, we know that the sickle cell people are resistant to malarial infection, mainly because they produce microRNA targeting the Plasmodium. Next slide, please. We also should have thought about it because we know that one common parasitic plant is Cuscuta. So, the Cuscuta produces what you call as a small haustoria-like thing. And in that haustoria, we have got lot of small RNAs which are targeting the host plant genes. So the concept, whatever the experiences we had, but we were not able to scientifically tell what is a concept. Now we know very clearly that it is the cross-kingdom trafficking of RNA. Next slide, please. So there are so many lists where the pathogens have been shown to produce small RNA targeting the defense-related genes of the host plant. I have listed it so that students can go through the references. Next slide, please. You will see that the host plant also produces genes which are targeting the fungal RNA. So on both sides, the informations are now enough. Next slide. We now know that they are producing. So how do we employ it? As our previous speaker said, either we have a transgenic plant in which, we can introduce to the gene which will be targeting the genes of the pathogen, or you can synthesize these small RNA or the double-stranded RNA and spray it on the plant. So it is either Higgs or the 6, which are very much being used, and we will see just few examples. Next slide, please. Next slide, please. Okay, both the categories I have shown. In one case, the transgenic plant is produced, which will be producing the small RNA, which will migrate into the pathogen. In another one, we either synthesize the small RNA or we have the dsRNA put into a bacteria, and the bacteria will produce a small RNA which will be isolated and sprayed onto the plant. So both ways we can use it. Next slide, please. But the fungi do differ in their uptake, but at least the major pathogens like botrytis, sclerotinia, rhizoctonia, and all have been shown to take the double-stranded RNA very easily. So it is not very difficult to follow this particular protocol. Next slide, please. So I will just give you the first example given by Wang et al. In 2013 itself is that the small RNA targeting the TCL enzyme of botrytis cinerea, that is spot applied onto the tomato, grape, and even lettuce and other vegetables. And you can see that the infection is very much mitigated when this small RNA is applied as in the last row. Second slide, please. Next slide, please. Next slide. So it is also shown in the case of wheat against the Puccinia striaformis, which is becoming a very big problem. Next slide, please. The very interesting example is the rice pathogen Magnopothium oryzae. So you can have a small RNA targeting the transcription factor of the rice, and even in the culture when it is applied, it was shown that the conidia production was less and the conidia was abnormal in structure. So the structural proof was given that the small RNA is working against the transcription factor. Next slide. And they also produced the transgenic rice, having all those small RNA constructs, and the transgenic rice was able to very much reduce the infection of Magnopothium oryzae. Next slide. This one has been applied in the case of the head blight, Fusarium graminearum of wheat. And here also, as you can see, that the particular sporulating factor, CYP1, if you are producing a small RNA and applying it on the leaf, it was able to reduce the infection of the head blight. Next slide, please. So the interesting example comes from the Verticillium dahliae, Here also sRNA was produced, and that is targeting the very important hydropene gene. And next you can see that, next slide, you can see that the cotton plants which are treated with this sRNA could definitely inhibit the verticillium infection. Next slide. Next slide. So, it is not only small RNA, you can also spray a double-stranded RNA. When you say double-stranded RNA, it is just about 150 nucleotide to 200 base pair nucleotide. It can be either produced, synthesized, or we can introduce the gene into a TCL deficient bacteria and make it to synthesize. And that, the dsRNA, when it is sprayed, you can see that in all these plants, fruits, and vegetables, it could fight against the botrytis infection. Next slide, please. The same can be applied. For example, the bacular protein, sorting protein of rhizoctonia and dynactin protein of rhizoctonia, you can apply it, and it was found because for rhizoctonia, till now there is no solution, and that is one major pathogen having a very wide host species. So such approaches will be of very useful. Next slide. So that is what I want to conclude. As the previous speaker said, the small RNA application is no more a theory or a laboratory experiment, but it is being used. And in fact, in TNAU Coimbatore, we have made the small RNA targeting many viruses, and we found that it is very much useful against GBNV, TOLCNDV, and also against MYMV. So it is for us to, apply it and then achieve the resistance with minimum ecological pollution and sustainability. I once again thank the opportunity, the organizers, for giving me the opportunity. Thank you very much.
Thank you, Dr. Malathi, for throwing light on the new methods of management of plant diseases. And the concept is very nice, and we don't know how this will be accepted. It will be accepted, but how many years will it take to be a part of the general plant disease management program in the state? So that's the main. The research findings and the actual use in the state. It's taking a lot of time. That's the main problem that you're facing. So I think we should take some initiative in this step. The society can also think about explaining this concept to the Department of Agriculture to find out whether this is easily accepted by the department. The main problem here, another problem which you are facing is the higher ups in the department are not aware of this new concept that is happening in the world. They only think about the old pesticides. See, even now they are going for dithiocarbonates, all these things, and even some of the pesticides, in fungicides. But the newer pesticides, the most widely used pesticide in Kerala is SAF at present. That's your old pesticide. That's the most, anything you ask, apply SAF. It contains a systemic fungicide as a contact fungicide. That's the definition. But this is the one thing. Thank you very much once again.
Thank you. Thank you very much, sir.
Thank you, madam, for your wonderful talk once again. As a teacher, you have inspired many of the virologists in the country are all your own beloved students only. So we are really proud to have you in this very important meeting and for sharing a novel idea of using how best you can transgene a plant or even how to spray a double-stranded RNA to make the plant safe against the pathogens or insect attack. Thank you so much, madam. Wonderful talk.
Thank you. Thank you, sir.
So, on behalf of the organizers, we are running short of time. We specifically and wholeheartedly thank you, madam, for your valuable time to come online and enlighten our students at this very August college. Thank you so much, ma'am, for your time. We will give a memento on post to you, madam, soon for this particular talk. Okay, thank you so much.
Thank you so much, sir. Thank you, thank you.
Requesting the chair and co-chair to present a memento to Dr. Malathi through her student, Dr. Sumia, present here.
Yeah. Oh, that is wonderful.
Yes. Thank you.
That's really wonderful.
Dr. Sumia is accepting the memento on behalf of Dr. Malati.
Thank you, Sumia. Thank you, sir. Sir, your talk about Dr. Samaraj was a real revelation because we have been citing that paper more than 100 times, but we were not aware of it, whatever he had done. And it was so thrilling for me that today I should participate and then I should hear you and all, It's so sad that we don't come to hear about him, but thank you so much, sir.
Dr. Mahadi, I think we have met several times in Delhi IARI. I was in... I didn't remember you, but I know that during the year where you worked there, I used to come to IARI from PADANNAKKAD. I was in PADANNAKKAD.
Oh.
So I used to come there and to meet you. Thank you very much.
Thank you, sir. Thank you.
Other speaker is ready online? Lunch break, huh? Okay. Yeah.
Thank you, ma'am.
So I think, please carry on.
Now it's time for lunch break. All are invited for the lunch and are requested to reassemble at 2:15 p.m.
Requesting all the persons to reassemble at 2:15 p.m. Thank you.
Dear delegates, those who are registered for the seminar, if not having any food coupon, please collect it from the registration desk. Thank you.
Technical session, the part 1 and second session, and the third presentation of that, Dr. Jyodhakshmi Vadasheri. Dr. Jyodhakshmi Vadasheri is a scientist 5 of the National Institute of Plant Genome Research, NIGPR, in New Delhi, India, where she leads a research group focused on understanding the molecular mechanisms and underlying the plant defense mechanisms. She did her BSc from Kerala Agriculture University, MSc from IARA, and PhD Schiller University, Geneva, in Germany. And she's pursued postdoctoral research at USA and the Max Planck Institute of Chemical Engineering before returning to India, continuing her research career in NIPGR. Has been recognized with several prestigious honors, including election as a fellow of the Indian National Academy of Science, NISI, and Janaki Amma Memorial Women Bioscience Award, and selected as a EMBO Global Investigator. I request Dr. Jyodhakshmi Vadasheri to present the paper on this.
Thank you for your kind introduction. I hope I'm audible.
Yes, you are audible.
Yeah. I would like to first of all thank Sri Kumar sir for the invitation, and it's always a pleasure to give a talk in the institute where I did my undergraduate. So my study today will be on a work we did in our lab on use of high throughput metabolomics to study host plant resistance on biotic interaction, and the biotic interaction I'm talking today is on plant insect interaction, essentially on Spodoptera and maize interaction. So briefly, I'll just tell what my lab is working on. For the past 12 years, I'm in NIPGR in New Delhi, and my lab uses two model systems, Arabidopsis and maize, and two chewing pests, Podoptera litura and Frugiperda, as the model system. So we look at plant immunity majorly, and we do both cell biology and chemical ecology-based research. And in the cell biology research, we looked at calcium channels in plant immunity, which helps plant recognize insect herbivory. We are looking at characterizing these rapidly activated signaling pathways. And the third aspect is on the metabolic networks, which are responsible for host plant resistance, which I'll be presenting today. Apart from the plant part, the fourth arm of this is we are also looking at the insect side. We're looking at insect salivary gland proteins that can modulate these immune responses. So I'll just take a pointer option. So the talk today will be on Podoptera frugiperda, which is a major agriculture pest. For all these years, Podoptera frugiperda was an invasive insect pest which can feed on many host plants, but it has a strong preference for maize. So it was usually restricted pre-2016 to the Americas. However, due to many factors, with climate change being one of them and travel, many other details, this pest started migrating to other parts of the world, including in 2016 in Africa and in 2018 in India and 2019 into China. So it causes around 73% yield loss, and you can see how it impacts different parts of maize when this fall armyworm is coming. So when it reached India, we did not have any sources of resistance against Podoptera frugiperda specifically, and this was a major point, and this was a limitation in controlling this pest. So we decided to come together to understand with a group in ICR as a part of an NSF project to understand and see how can we screen for germplasm. So before we screen for germplasm, it's important to know how plants respond in general about chewing pests. What does the literature say that how does it respond? So when there is an insect feeding, one of the first responses that is activated is an early calcium signal channel activity, which in turn leads to the activation of a plant hormone called jasmonic acid, and this is the bioactive form of jasmonic acid that you see here. So 70% of all responses, plant responses to chewing insects are via the jasmonate pathway, which in turn leads to further secondary metabolite upregulation. So it was important for us to study this pathway and to look at secondary metabolites, which might be potential markers for host plant resistance with respect to fall armyworm. So we started a screening of the maize germplasm against fall armyworm under artificial infestation. This was done at the IIMR Winter Nursery in Hyderabad, where many CIMIT lines and IIMR lines were screened, and using a Davis score rating, the fall armyworm was put on the young developing maize, and it was scored based on resistance is 1 to 4 rating, moderately resistant 4 to 6, and susceptible will have more than 6 to 9 rating. So this was undertaken as a part of this NSF project. So once we had screened many, we identified one highly susceptible variety, which is BML6, and 2 sources of resistance, the CIMIT maize line 71 and the DMRE 63. These are the 2 resistant lines that was identified to be highly susceptible. So how do you identify them? You can see that the leaf damage rating, it's highly low in the resistant line, whereas in the susceptible line, it's very high. You can also take the weight of the larvae, and you can see that it feeds more on the susceptible variety than the 2 resistant varieties. So once these genotypes were with us, I went further and I wanted to identify why are these genotypes specifically resistant against fall. What can we understand from them that we can use for fall management in future in India? So my lab is specialized on metabolomics as well, and so I started with identifying the metabolic basis of host plant resistance. So why didn't I go for genomics first? So the output of genomics is metabolomics, and the genomics data really depends on the time point that you take. So if you take different time points, the effect of genes would be very different. And so metabolic basis is really the end point of this whole interaction, and hence it's more reliable to take a metabolic basis of host plant resistance when you want to work your way up. So essentially what we did, we harvested the maize samples after for feeding and subjected them to high resolution LCMS and high resolution GCMS, which are part of the untargeted metabolite profiling network. And then we did a data interpretation, and we went to confirm these metabolites which were upregulated here. We also went for targeted metabolomics. So I'll walk you through what we found through this step. So first we started with the GCMS. We took these susceptible and resistant varieties, and we did an untargeted metabolomics. And as you can see, both in the susceptible, resistant, and the two resistant varieties, you can see differential upregulation of many metabolites. And since it is a GCMS, it will be more, enriched in primary metabolites, and that's what you see. If you categorize these metabolites, you can see a lot of amino acids coming up in both resistant and susceptible varieties. So we decided to focus on why is amino acids such a big point in these varieties. So what we did, we developed a method where we can quantify it absolutely using LCMS. These amino acids alone. So we were able to develop a method where within 20 minutes you will get a fingerprint of all amino acid. So this is the control plant, and this is upon feeding. So this is the susceptible variety, and this is the two resistant variety. So when you look at this picture, immediately you know that the susceptible variety has a lot of amino acids which are upregulated, which gives us a hint that actually this high amino acid, in this susceptible variety is actually beneficial for the insect, and it uses it as a very good food source. And this could be one of the reasons of its high susceptibility due to high induction of amino acid, both in the control and upon fed condition. Whereas in the resistant varieties, the distribution is quite different. So this is one resistant variety without feeding, and this is after feeding. And you can see that after feeding, this resistant variety completely does not upregulate amino acid as a way to prevent insect from feeding it more. Whereas in the second DMRE63, it enhances only production of selected amino acid, which are precursors for secondary metabolites. So both the resistant varieties behave very differently with respect to amino acid accumulation when compared to the susceptible variety. We just plotted two amino acid just to show you the stark difference between the resistant and susceptible variety. So amino acids are very good marker. If you have higher amino acid content in your plant, it is one way to say that the herbivore will prefer feeding on such genotypes, and it could be used as a genotype screening in long term. So once we went from the GC, we also did the LCMS based on an LC Orbitrap MS. So this is the susceptible variety, and these are the two resistant variety. So you can see in the susceptible variety, there are very few metabolites which are induced upon 24-hour feeding, whereas in the resistant variety, many metabolites are induced in both the resistant variety. So when you do this kind of metabolic profiling, it is important to identify what these metabolites are. And we found that many specialized metabolites, including primary and secondary metabolites, were identified from this exercise. So one of the key things that came from this untargeted analysis was that a lot of JA related metabolites and signaling components were enriched in this data set. As I told you, jasmonic acid is crucial for herbivory defense, and it is this form which is being recognized by the plant to activate immunity. You will see an immediate JA burst upon wounding and herbivory. And if the plant doesn't have a JA receptor, this is how it will look like. If the plant cannot sense jasmonic acid, it will be completely finished off by the larvae. Hence, it is very critical. So it was important for us, once we got a hint that many hormones are up and down, the untargeted metabolite profiling is never an absolute quantification. So we had to go for a targeted metabolite quantification to quantify LCMS in the lab. So for that, you need an instrument which has high sensitivity, and since phytohormones are highly low abundant, you cannot detect them easily by HPLC. So it was important that we make an LCMS-based method, and we used it. We used this isotopically labeled internal standards, and this is the gold standard for hormone estimation anywhere in the world. So this, once we established, what we did is that this is the unfed varieties, so the BML6 and the 2 resistant varieties, and this is the fed. So you can obviously see that upon feeding, you have more red color, that there is induction of a lot of hormones, even in the susceptible variety. But the important hormone, for example, jasmonic acid isoleucine, is not very much induced, but there are many others which are looked to be also in the susceptible variety. But the resistant variety, DMRE63, has a high induction of all plant hormones, and the CML71 also do seem to have more induction of the hormones. So we went ahead. This is a 24-hour time point, and if you look at a hormone profile, this is a relatively late time point. So what we did a time course of 3, 6, and 24 hours. We had already done the 24-hour. We also did the 3 and 6 hour, which should be an early time point. And what you can see, as you can very clearly see, the BML6 is hardly able to induce jasmonic acid or jasmonic acid isoleucine. They are highly non-significant. Whereas the resistant genotype, especially DMRE63, you can see a very high induction of JA and JA isoleucine. And in CML71, also it is not very quick, but it does induce jasmonic acid isoleucine and JA as well. So this tells us that these hormones are critical for plant immunity, and in the resistant varieties, these are coming up very fast. But there were some hormones, if you looked at that heat map, there was something else which was red in the susceptible variety. So what we found is that the susceptible variety is showing a lot of 12-OH-JA. It is a form of jasmonic acid which is inactive. So a plant always cannot activate this pathway and keep it on, because then it is detrimental for plant growth. So once you have a JA isoleucine burst in plants, the plant will convert it into many inactive forms, so that this burst doesn't last for so long that it is detrimental to plants. So one of this component, 12-OH-JA, is such a form where the active JA is converted to 12-OH-JA. So the amount of this form, so we are able to quantify all these forms of JA, jasmonic acid, and all of them in a 15-minute run. We can quantify entire plant hormone profile, and we found that in the susceptible variety, it is this form which is high. So now all the JA that is responsible for activation of this pathway is getting converted to this, non-active form, and that is why BML6, which is a highly high-yielding variety, a genotype actually, is not able to mount a defense. So there should be a reason for even a susceptible variety to be susceptible. And this is what we find that in the BML6, the OH-JA is responsible for this low production of low activation of this entire pathway, because it is a metabolic shunt which is inactive. So once you have this idea, it is important to know which are the genes involved in production of this, conversion of JA to this inactive JAOH. And in Arabidopsis, it was discovered recently that jasmonate oxygenases or JOXs, there are 6 of them in Arabidopsis, and we went ahead and looked at how many are there in maize. So we found also 6 JOXs in maize. We call them ZM JOX-like, and they are also, highly induced when there is feeding, telling us that these genes are, induced in this susceptible variety. Now, what is the importance of discovering such a JOX? The importance is that, you can use it as a target for editing in future if you want to do CRISPR editing. Here you have a negative regulator called JOXes, which is converting JA to JAOH. And if you edit it in this DML6 susceptible variety, we can probably overcome this, reduced immunity in these lines. I hope you're able to hear me. The second, I hope you're able to hear me.
Yes, it's audible. Thank you.
Yeah. So the second thing after hormones, what we found from the secondary metabolite profiling is that this specific secondary metabolites called benzosinoids, which are tryptophan-derived metabolites, which are very, very well known in maize to be induced upon herbivory. You might have heard about them, the Dimboa class. But Dimboa is not the only form of it. There are multiple forms of, benzosinoid which are available in plants which can protect against immunity. For example, H. Dimboa, Dimboa 2A, various forms of it. And fall armyworm has learned to detoxify Dimboa. And so this H. Dimboa forms are the one which are now active against fall armyworm resistance. So it was important for us to be able to quantify all these forms, the stable forms and the toxic active forms. So that's what we did. We developed a method where we can quantify all the benzosinoids in maize and the method development to quantify it. Now, again, like I showed in hormones, these are untreated, unwounded, susceptible and 2 resistant varieties, and this is the level of all benzosinoids in the after 24 hours of fall armyworm feeding. You can see it like day and night. You can see that upon feeding in the susceptible variety, there is absolutely no induction of benzosinoids. And why? Because the JA pathway, which leads to induction of benzosinoid, is shut down in the susceptible variety. Whereas in the CML71, you do get a high induction of CML71, and in DMRI63, a very high induction of the benzosinoid pathway. DMRI63 is very interesting because even in the constitutive level, where the plant hasn't seen the insect, all the benzosinoid levels are high in these genotypes. As a result, these genotypes are also, due to this increased defense, they are also shorter in their height. So there is a growth penalty because in the control condition itself, they are activating this secondary metabolites. So that's what we found from this metabolite profile. So I'll just briefly conclude. So the resistance against FAW, what we believe is regulated by multiple primary and secondary metabolites. Primary is amino acid and secondary metabolites are benzosinoids and jasmonate. And you can easily use benzosinoids and jasmonate as an excellent metabolic marker for resistance screening, which is crucial to identify maize resistance to FAW. We also identified a susceptibility factor called the JOX genes, which can be manipulated by CRISPR editing in future to convert high-yielding susceptible genotypes to be more immune to this insect herbivore. Apart from this, from this study, as I told you, we did an untargeted metabolite profiling. So apart from the known hormones or the benzosinoid pathway, we also identified many novel metabolites which seem to be highly upregulated in the DMRE63 genotype. And one of them, a novel alkaloid, I don't want to say what it is, but it's a novel alkaloid that we found to be highly induced upon herbivory. And once we isolate this metabolite and feed it on the insect at different concentration, you can see that it is highly phytotoxic to the fall armyworm. You can see that the weight of the larvae is decreasing as you increase the concentration of this metabolite in the diet. So this is a technology that we want to take further forward as a novel biopesticide against fall armyworm. And this is something that is we are trying to make a formulation for this metabolite patented, and together with IPFT, try to do field trials that it can go to CIBRC as a release, as a phytochemical which can protect against fall armyworm. You've heard about dsRNA many times in this in the morning session. And dsRNA is also one way to resist Podoptera frugiperda. So in our lab, we have identified multiple targets that we can use, that they are essentially insect housekeeping genes. It's a published work in 2025 from our lab. And we have identified these alpha and beta genes and the GSTU. The chitin synthase is very well known to be very effective, but these three are novel genes in Spodoptera. So if you spray them onto the plants, you can see that the insect doesn't feed it as well as in the control, and they gain lesser weight if you silence all these housekeeping genes. So what we are currently doing is there are no dsRNA pesticides available in India. So there are multiple challenges. One is to how do you produce a lot of dsRNA that you can spray into the field? This in itself is a big challenge, because you have to be able to produce it in fermenters that this dsRNA is enough for you to do a spray. Second is its stability. So for that you need very special formulations. So we, as a part of a DPT biomanufacturing initiative, along with IPFT, we are now trying to mass produce these dsRNA constructs and make a formulation which is environmentally stable. And we hope in some years we are able to come up with this dsRNA pesticide, which will be the first of its kind in India at least. With this, I want to end my talk. Most of the metabolic work was done by Paramita Bera, who is a postdoc in my lab. This is my group, and I would want to thank them. This is our institute. We are a DBT, Department of Biotechnology Institute, located in Vasant Kunj. And I would like to thank funding from DBT, and also this entire metabolic work was funded by ICR NSF project to me, and to the IMR under Dr. Sujay Rakshit, JC Shekhar, Supi, Saujanya and Yatish, and would also like to thank the metabolic facility. I also want to tell the audience that we have an excellent state-of-art metabolomics facility in NIPGR, of which I am in charge, and I have set it up. So this is an open facility. Anybody in India can pay and use this facility. We have standardized every method that you would need in entomology. You can quantify many metabolites, and I would request that you can use it for your research as well. Feel free to contact me for the same. Thank you very much.
So excellent, madam. I think it's a real eye-opener to the students as well, how to proceed with the research, to start with the fundamentals of resistant and susceptible variety, to identify the metabolites, and how to take forward as a novel biopesticide. So she has made it very, very clear, and the important signal transduction pathway, she has done it. Excellent. I think we will invite one question at least from the student community to see how best you have understood the topic. At least one question from the students, please. Okay, otherwise, Madam Jyotirishmi, it was wonderful listening to you. Not only the basic science were made, how best to present, how the data has to be generated.
Hear me?
Yeah, now I can hear you.
So it was a very wonderful talk, wonderful research work. We all appreciate you. We are proud of you. I have one question, that is why the susceptible plant do not have that chemical, methyl jasmonate? Why it is devoid of that chemical? Because it has to fight, no? It has to fight. It is living in a world where lot of scent. It is absent.
It is not that it is absent in that susceptible variety. It is just that the ratio of the active jasmonic acid is less. It is converting it into an inactive form, probably for growth needs. So it is converting 80% of its jasmonic acid to JAOH. Some kind of a growth defense trade-off. So the amount of jasmonic acid it has for immunity is very less as compared to what the resistant genotypes are having. So it is we have to study this further as to why it specifically does it. But from the literature, what we know is some genotypes have this when they have this growth hormone pathways upregulated, and so there's a crosstalk between, say, the growth hormones and the defense hormones, and in some genotypes you do see this response.
Okay, thank you.
Thank you, sir.
Lakshmi,
Can I ask a question, please? Yeah. Hi, Jyoti. Very nice work and good to see you.
Thank you,
Jyoti,
sir.
my question is, in susceptible variety, BML6, is that the free amino acid content is naturally high in susceptible variety? And my second question is jasmonic acid also regulating the free amino acid content? And one more question is, what is the significance of this amino acid content as such under pathogen, insect attack?
So the first one, the constitutive level of amino acid is high in this DML6. They seem to be, very, very good for the insect to feed on because they'll get a lot of dietary requirement of their amino acid. So constitutively, they are high. Also, upon feeding, certain amino acids are high in susceptible genotypes. So this is one reason why they could be highly susceptible because of its nutrient content. Second, amino acids are induced from feeding, even in the resistant genotype, one of them. So not all amino acids are, just the diet for the insect. Amino acids are also precursors for many secondary metabolites that we know of. So they are critical. Some of them are critical that they are induced in the resistant genotypes because that is what will lead your secondary metabolite production. But in DML6, it's all through very high. So this is also a reason for its high susceptibility.
Thank you.
Thank you.
More questions? If not, thank you, Jyoti Lakshmi. So we'll wind up this session. And now we go for the oral presentations.
We request the chairman to we request you to present a memento to Dr. Jyoti Lakshmi. I request Sajeesh sir to receive the memento on her behalf. So I request Sajeesh sir to receive the memento on her behalf.
Thank you very much.
Thank you. Now we move on to the oral presentations.
So, we are passing into the technical session, oral presentations. This is on a competitive mode. So, the presenter must limit his or her talk to 7 minutes and questions for 1 minute. Altogether, there will be only 8 minutes for the presenter. And I request somebody to timing.
Somebody can record the timing, please.
The rapporteurs. No. It's okay. Timings. So I will call upon the first presenter, that is induced systemic resistance in maize, PCR-based evaluations of defense genes activated by entomorphogenic bacteria against Spodoptera. Who is presenting? Ratnakala? Yes. Ratnakala, please. Yes, your time starts now.
A very warm good afternoon to everyone. I am Ratnakala, PhD scholar from the Department of Entomology, US Harvard. I am here to discuss my research findings on the topic induced systemic resistance in maize, QRT-PCR based evaluation of the defense gene activation by the entomopathogenic bacteria against Proptera frugipada. The secondary form of the bacteria which is associated with the entomopathogenic nematode are known to be associated with the roots of the plant, which are free living and which promote in the plant growth as well as the defense against the insects as well as the diseases. With this hypothesis, we have formulated an objective, that is to understand or to study the genes which are contributing to the induced systemic resistance in maize in response to the bacteria which is associated with the entomopathogenic nematode and against this Proptera frugipada based on the QRT-PCR analysis. Here we have bioprimed the seeds of the maize with the bacteria, that is Xenorhabdus indica, which is symbiotically associated with the Stenianima abbasi, and the Photorhabdus luminescens, which is associated with the Heterobitis indica. And we have analyzed their effect on the in vitro seed germination of the maize. Here the Photorhabdus luminescens had induced higher shoot length, root length and the seedling vigor index, and also the highest germination of 93%, which is followed by the Xenorhabdus indica. The isolate is USD BIDS, and when we took it to the greenhouse studies, there also they have induced 100% or the complete mortality in case of the Proptera frugipada, that is the third star of this Proptera frugipada, and it was at par with the insecticide treatment, that is the imamectin benzoate, and also the biocontrol, that is Bavaria bassiana. And these are the pictorial representation of the cadaver of this Proptera frugipada, which is manifesting the infestation of both the bacteria, that is Xenorhabdus indica and the Photorhabdus luminescens, and also the feeding damage that is we have seen in case of the different treatments. And in order to understand the insecticidal property of these bacteria, we have conducted the QRT-PCR by taking the genes or the primers which are involved in the ISR as well as the SAR. For example, the PAL, which is the phenylalanine ammonia lyase, and the BX, which is the benzoxenoid, which is responsible for the formation of the DIMBO or the EMBOA, and the lipoxygenase, MPI, that is the maize protease inhibitor, and the HMGR. Among the housekeeping genes, the beta-tubulin was normalized across all the conditions and was taken as an internal control. The QRT-PCR analysis revealed that the majority of the genes were upregulated at 24 hours and were downregulated at the 48 hours. Among them, the lipoxygenase gene had the highest upregulation at the 24 hours. And on the contrary, the HMGR, which is involved in the malonate pathway, which was downregulated at 24 hours and upregulated at the 48 hours. The similar results are represented in the heat map. And this is the radar plot which shows that the relative expression of these genes at 24 hours and 48 hours post-infection by this Proptera frugipada. Here, in case of the 24 hours, we can clearly see that the expression of the LOX has induced the response of the ISR, that is nothing but the JA pathway. And at the 48 hours, there was a shift from the ISR to the SAR that was evidenced by the higher expression of the PAL gene. And The figure 3 represents the dendrogram, which illustrates the clustering of the different genes or the primers that were used in our study. Here we can clearly see that the HMGR and the MPR, which were co-regulated or expressed similarly, whereas the LOX had the independent expression or the distant expression from the other genes. With this, I would like to conclude that in addition to the insecticidal activity of these bacteria which are associated with the entomopathogenic nematode, the biopriming of these into the seed of the maize, it has induced which has promoted the plant growth, its germination, and also induced the defense pathways such as the JA, ISR or the SAR. And overall, these findings highlight that these bacteria which are associated with the EPN, which are indigenous to our country, because these bacteria were isolated from the southern part of the India. They function as an effective biocontrol agents, and therefore they could be used as an eco-friendly strategy for the sustainable management of these Propter frugipara in maize ecosystem. I would like to thank University of Agricultural Sciences, Dharwad, which is my host university, and the DST for providing the prestigious Inspired Fellowship, and the ICR NBIR. With this, thank you.
Thank you, Ratnakala. Any questions from the student side? No.
Madam, I have a very fundamental question to you. What is the mode of action of entomopathogenic nematode?
Sir, entomopathogenic, they act as a contact kind of insect. So they will enter, I'll explain, sir. They will enter through all the natural openings, sir. Either mouth, anus, or the intersegmental cuticle, wherever the opening is, sir.
Very good.
They will open through that, sir.
Then?
Enter through, sorry.
Then what happens?
They will enter and they will go to the gut or the hemolymph, sir. There they will release their symbiotic bacteria, which I have explained now. There are two genera, that is Xenorhabdus and the Photorhabdus. These Photorhabdus or the Xenorhabdus, they will take care of the insect. They will produce the toxins and they will kill the insects, sir.
Good. Now, from where you have isolated this Photorhabdus and the Xenorhabdus, which species of nematodes have you isolated?
Galeria, sir.
No. Which species of the nematode you use these entomobacterium?
For Photorhabdus luminescens, sir, it is Heterobitis indica, sir, associated EPN. And for Xenorhabdus indica, it is Stenenema abbasi.
Thank you.
I only have isolated, sir.
Thank you.
Thank you, sir. Thank you, sir.
Second oral presentation, microbiome regenerating as a novel management strategy for banded leaf and sheath blight disease of maize. Vineet Vijayan. Is it Vineet Vijayan is presenting now or online? Is she ready? Then we will go for the third one. Or we will just have a presentation by Pratap. Are you ready? 5 minutes. Then we can cover one more. That is Ashwati ready? Say, Ashwati, you can present, your presentation paper is a nanocytosan. Composite for the management of rice overhead bug. That is the presentation. Again, time you be 7 minutes and 1 minute. Okay, start.
Good afternoon, respected dignitaries. I am Ashwati, PhD scholar from College of Agriculture, Vilayani. I am here to present our research work on the topic nanophytosan, Lecanicilium succinate for the management of rice earhead bug, Leptocoryza acuta. Before going to the topic, I am glad to introduce our fungus Lecanicilium succinate, which was isolated from our cultivated soils of Fellaini in the year of 2014. We got the accession number in the year of 2015. Further pathogenicity and the field efficacies were carried out in the subsequent years. As a result, we have proven that it's a highly virulent endomopathogen against several hemipteran pests with spore dose of 10 to the power 7 spores per ml. Then the findings of Streja and co-workers proved that the speed of kill is attributed from the acetylcholine esterase blocking property of the fungal metabolite, where they detected so many compounds from the fungal metabolite, of which oosporin was the major toxin. However, the larger scale application of endomopathogenic fungus is difficult due to environmental fluctuation. So we have chosen nanochitosan as an efficient carrier. The main objective of our study is to develop a composite using nanochitosan as well as a fungus and to check its efficacy against rice earhead bug, Leptocoryza acuta. Moving to the materials and method, first part is the synthesis of nanochitosan. For this, we need two basic things, that is chitosan as well as the STPP, that is a sodium tripolyphosphate. For the synthesis part, we have to add this STPP solution dropwise into the chitosan solution under stirring condition. After 4 hours of stirring, finally we will get a milky white opalescent solution, that is our nanochitosan solution. Next slide. Second part is the extraction of crude toxin. Here we followed ethyl acetate layer extraction. For that, aliquots of our culture was mixed with our ethyl acetate, and then we have done the shaking at 200 rpm for 12 hours. After that, we have separated the ethyl acetate layer. We need that layer for extracting our toxin. For that, we have used this separating funnel for the extraction of ethyl acetate layer. Finally, the metabolite was concentrated in vacuum evaporator. Further washings with the hexane, we got the fine purified red wine colored powder, that is our crude toxin, Lecanicilium succinate crude toxin. Next slide. Slide changer. Okay. Next part is the synthesis of Lecanicilium succinate composite. For that, we have added the powdered of wine red color powder crude toxin into the nanochitosan solution under stirring condition. After 6 hours of stirring, after adjusting the pH, we got the fine wine red colored solution, that is our nanochitosan Lecanicilium succinate composite. This is about the synthesis part, and next we have to confirm the characters using the using various instruments to confirm their size, shape, functional group, structure, like that. Third step, to evaluate its efficacy against target pest, rice earhead bug, nymphs and adults using 3 different concentration of our composite. This is about the materials and methods, and moving to the results and discussion. Already we have synthesized the nanochitosan as well as the composite, and for the physicochemical characters, it's an important part, and here the major part is to identify their size, whether it is within this nanoscale. For the particle size, for the nanochitosan, I got in the range of 171.95 nanometer, and for the composite, I got in the range of 184.47 nanometer. It's mainly due to the incorporation of fungus onto the nanochitosan, and our studies aligns well with that of earlier reports. Second one is to identify their charge. If we are getting, that is theta potential, if we are getting in the range between plus or minus 30 millivolt, then we can say that our sample is stable. For the nanochitosan, we got in the range of 23.7 millivolt, and for the composite, we got in the range of 27.8 millivolt. And third characterization is to identify the functional groups using FTIR. For the nanochitosan, we have identified 3 important functional groups in the nanochitosan: hydroxylamine and glucopyranostrine. And for the composite, we got all these 3 functional groups. In addition to this, we got the alkane group, mainly due to the incorporation of the fungus onto this nanochitosan matrix. Fourth characterization is XRD characterization, mainly to study their structure. We have to study the structure in order to find out whether the sample is amorphous or crystalline in nature. For the nanochitosan, if you are getting the peak in between 20 to 30 degree, then we can say that our sample is in amorphous in nature. For the nanochitosan, we got in the range of 23.87 degree, and for the composite, we got in the range of 24.36 degree for the nanochitosan, and for the composite, we got an additional peak in the range of 15 to 17 degree, mainly due to the fungal incorporation onto the nanochitosan. Fifth characterization is to study their morphology. Using FESM characterization for the nanochitosan, we got the spherical uniform shaped spherical shape, and for the composite, we got somewhat larger sized particles, that is a quasi-spherical, that is approximately spherical shape due to the incorporation. And sixth characterization is HRTM characterization, mainly to study the shape and internal structure. For the nanochitosan, we got the uniform shaped spherical shape without. Here in this picture, you can see that there is no inclusions were present inside the nanochitosan. Coming to the composite, we can see that some dark dense domains were observed inside the spherical shape. That is our Lecanicilla succinate toxin, which means that fungal toxins were trapped inside the chitosan matrix. This is about the physicochemical characterization. Then final objective, which is the efficacy study. Here we have sprayed these different concentration of our composite on the target insects rice-ear head bug by the topical application. After 20 to 24 hours of treatment, the treated insect exhibited some abnormalities like convulsions, and it will lead to the jerky movements, and finally paralysis and deaths were observed. This is about the morbidity symptom. Then it is about the mortality data. In the table, we can it is evident that the mortality is completely a dose time dependent mortality, because in the nymphs that the mortality was rapid and pronounced. On the third day after treatment, the nymphs exhibited 100% mortality, and the adult also exhibited some mortality, but it is somewhat lesser. It is on par with the toxin, but we can't spray the toxin directly on the field, so we have chosen the toxin for this the field. To conclude, formulation is 100% natural, and chitosan is from the branchials, and Lecanicilla succinate is from the soil, and it's we can go for the management. Thank you.
Significance between these nanocomposite as well as the original Lecanicilla succinate directly.
Sir, actually nanochitosan, they possess a small size, sir. While spraying, it will easily enter into the insect body. But if you are going to the field condition, means some environmental fluctuations or the conditions, it ultimately degrade our Lecanicilla succinate toxin. Whereas the nanochitosan...
So you are ensuring the environmental stability here, right?
Sir?
You are ensuring the environmental stability by your nanocomposite.
Yes, sir, we are ensuring. Here the nanochitosan will ultimately...
How is that safe, biosafety point of view?
Biosafety, it will protect the chitosan from the...
From the human toxicity point of view, nanocomposite.
Nanocomposite, sir?
How far it is safe to the human beings?
Human beings, it is safer because we are using the chitosan. It's a biodegradable and a biocompatible carrier. It's a natural one, no, sir. We are taking from the branchials. So it is completely safe for the human beings.
Good presentation. All
yes,
the best.
Thank you.
Prathapan, are you ready? Yes. So
now,
no or yes?
Now we move on to today's. Hello. Hello. Now we move on to today's second memorial lecture as a tribute to Dr. Emma G.K. Nair. This memorial lecture will be handled by Dr. K.D. Prathapan, retired professor, entomology, and emeritus scientist, Kerala Agricultural University. Chairman of this session is Dr. K.M. Srikumar, retired professor, KAU, and the co-chairman is Dr. Nisha M.S., associate professor and head, Department of Entomology. Rapporteurs of this session will be Dr. Manju KP and Dr. Nisha Lakshmi. We invite Dr. K.D. Prathapan sir for delivering the lecture.
ആണ്.
So, we are going to have the memorial lecture. It is on Dr. M.R.G.K. Nair by Dr. K.D. Prathapan. Dr. K.D. Prathapan completed his graduation and post-graduation from Kerala Agricultural University and doctorate from University of Agricultural Sciences, Bangalore. After a brief stint in Indian Institute of Spices Research, Calicut, he joined Kerala Agricultural University in the year 2000. He has guided 5 doctoral and 2 MSc students. He is a world-renowned insect taxonomist specialized in flea beetles. He has authored 116 research papers, 1 book, and many other publications. His research interest score in ResearchGate is 3,100.
Good.
So, he has authored, his research interest score in ResearchGate is 3,159, citations 1,231, H-index 16 and I-10 index 28, which is very, very rare in any science in South India. He has won the prestigious Dr. S. Vasudev Award instituted by Kerala State Council for Science, Technology and Environment for the best science research project 2 times, in 2007 and 2011. He has published a policy research paper in the prestigious journal Science. He is the honorary editor of several prestigious international journals in the field of insect taxonomy and also associate editor of the
Thank you all. I'm extremely happy that I have been invited to talk about the life and work of the most illustrious entomologist the state has ever produced, Dr. M.R.G.K. Nair. Dr. M.R.G.K. Nair, he was born in Muttambalam, near Kottayam, on 21st February 1922 to Mr. Ramapanikar and Papiyam. His father was an Ayurvedic physician and mother a homemaker. He was married to Sarojini Amma, and the couple have 2 children, Vimala and Ramkumar. Ramkumar expired as a young person, and that was the biggest shock in the life of Dr. M.R.G.K. And he did his early schooling and graduation in Kottayam, most probably in CMS College, and his degree was awarded by the S2L University of Travancore. From Kottayam, he moved to the University of Lucknow to pursue MSc in zoology. And during those days, there was a provision for admission to MSc Zoology graduates at IAR. First, there will be a sort of a makeup course called associateship, and then they can directly enter the PhD stream. Dr. Amarji Nair completed associateship in 1960 and PhD in 1962. And his associateship thesis was Constitution of insect cuticle in relationship to insecticidal action. The PhD thesis was effect of diluents on toxicity of insecticidal dust. And he joined the Department of Agriculture at the Agricultural Research Station Pallam near Kottayam, which is no more there, in 1945. In 1946, he moved to the then Travancore University as research officer in entomology under the University of Travancore. And in 1955, when the College of Agriculture was formed under the University of Kerala, he joined there as a lecturer. And in 1963, the college started postgraduate courses. And Dr. Amarji was elevated as professor. By the time he was senior lecturer, and from senior lecturer, he was elevated to the post of professor in 1963, professor and head of the department. From 1963 to 74, 1963 to 72, and again from 74 to 77, he served as the professor and head of the Department of Entomology at College of Agriculture, Velaini, for long 12 years. In between, from 1972 to 75, he acted as the first director of research of the Kerala Agriculture University and retired from the formal service of the Kerala Agriculture University on 31/10/1977. And again, he continued for 2 more years as ICR Emeritus Scientist. And Dr. Amarji, he held several prestigious positions. He was a consultant to FAO, and neighboring countries such as Sri Lanka utilized his services. And he was there in several ICR committees. He was also a technical member in the advisory committee of the State Bank of Travancore. So he held several positions with dignity and distinction. So his illustrious career spans for long 34 years. And he is the guide or mentor of a generation of teachers in Kerala Agriculture University. He guided 8 PhD students and 36 MSc students. I had the opportunity to speak to several of his students. They all consider him as a person who never lost his temper, but elicited affection, love, and adulation. He was such a humble and earthly human being. This is a photograph of Dr. Amarji with his colleagues. Probably you can recognize most of them. K.V. Mohan sir, Dale sir, who was my guide, Rajanachari sir. These 2 persons, sir, can you please tell? These 2 persons, I don't know. 2 on the right side. No. The left sitting first person is Dr. Ramamani, then Dr. Susama Matai, Dr. Vishalashi, then Mohandas sir, this person I don't know, Sharadama teacher. This is again another photograph of Dr. Amarji with his colleagues as well as his own students. And this photograph was taken on 31/10/1977, on the day of his farewell. All the names of the people are given below. And Coming to the academic contributions of Dr. Amardike Nair, he published around 100 papers in various journals and 3 books. And I told you that he submitted 2 theses to IRA. First one on effect of diluents to toxicity of insecticidal drugs. Then constitution of insect epicuticle in relation to insecticidal action. Actually, the second thesis is a continuation of the first thesis. And from that thesis, he published a paper in Nature on October 11, 1952. And he happens to be the only author in Nature from among entomologists in Kerala. Think of publishing a paper in Nature in 1952. And this is an interesting paper. There was no data to show that the effect of contact insecticides such as DDT is directly related to the property of the epicuticle, wherein the solubility of the insecticide by the epicuticle is directly proportional to the toxicity. So they devised a simple method. Extract the wax compounds from the moult of 2 insects. One is a Limantria, which is highly susceptible to DDT. Another is a dermestid beetle, Trogoderma, which is highly resistant. So they extracted the wax material from the exuvia of larvae of these 2 insects and then dissolved them in organic compounds. And then the organic compounds were coated on microscope slides as a thin film. Then they sprayed crystals of DDT in ethyl acetone water mixture onto the slide and then observed the property of the crystal. If the crystal is getting degraded, getting dissolved into the lipid faster, that is considered as having high solubility. And clearly they showed that the resistant insect is able to resist the dissolution of DDT into its cuticular lipids. And in the same paper, they also showed that the solubility of DDT is directly proportional to the temperature. Till then, there was no data to show that lipid solubility and temperature are directly correlated with the toxicity of an insecticide to an insect. Then in CAB Directs, 87 papers by Dr. Amardike are abstracted. And his forte was toxicology. By training, he was a toxicologist. He worked on DDT and several other insecticides, including their mechanism, as we have seen in his biology paper. But when he came back to Kerala, he concentrated on the entire pest, crop pests, nematodes, insects, non-insect pests. Okay? So, most of his papers are the pioneer works on biology and management of major crops of our state: rice, coconut, black pepper, vegetables, fruits. He did a lot of work on rice, he as well as his team. And on black pepper, Prem Kumar, who was his student, did extensive work all over Kerala. They did survey, and they are the ones who showed that, statistically showed that high altitudes are free of the attack of pollubility. And he also recorded several pests as new to Kerala, and some of them, including Rhodophola similis, is a major pest now, originally reported by Dr. Amardike and his team. And his books. In 1975, Google published Insects and Mites of Crops in India. I would say that this is his magnum opus. Though it was published in 1975, when there was no computer, no internet, no email. That is a complete treatment of all insect pests of all crops in India. And even today, that continues to be the latest updated work on pests of crops in India. If you get a pest, just to see whether it is recorded or not, the first book to refer is Mardike Nayar's Insects and Mites of Crops in India. He single-handedly did all this, only when typewriters were available. Okay? And even today, this book is getting cited. There are 517 citations as of today in Google Scholar for this book. Next is a monograph on crop pests of Kerala, published in 1978. And this is also a similar treatment for crop pests of Kerala. And this includes the control measures and other management measures which were up to date during those days. And there are also very good illustrations. He got it made by an artist who was there in Vellaini. I think Ganavadi is his name. And very good illustrations are there. And moreover, every pest, the entire literature is covered. Not only in this book, but in the previous book also. If you want to go back to the original work, the entire bibliography is given. And now they are struggling to update it, even with the internet and all other facilities. But still, it is very difficult to update the book. And the third book is a Malayalam book, Karshiga Keeda Vijnanam. This was published, first print was in 1971. There was another print after 10 years, prize letter, ₹7 by Kerala Pasha Institute. And this book won UGC award for popular science literature. And Dr. M.R.G.K. Nayar was also an institution builder. Institution builder in the sense he identified people, and he wanted the Department of Entomology in Vellaini to be in line with the IRA department. So he organized small units. When I joined the department, or when I came to Vellaini as a student, 24 staff members were there. So they were a sort of continuing the tradition of MRGK. So there will be people who are working on nematodes, nematology, then some on apiculture, some on biology of insects. There was an insectary, a large insectary, exclusively dedicated to study the biology. And certain people were assigned systematics. So he organized teams like this and also built up state-of-the-art facilities for research and teaching in the department. Then another remarkable aspect of MRGK is that he built up an insect collection, though he was not at all a taxonomist by training. He built up probably the first collection and the largest insect collection in Kerala. I will come to that later. Then he also built up a department library. Library in the sense it is not only thesis. Review of Applied Entomology, several volumes were there. And more interestingly, large number of reprints, a huge collection of reprints. And as the first director of research, he is the one who initiated project-based research, and also he wanted people to attract external funding. That was the major change brought about by MRGK as the first director of research. And these are the reprints collected by him. Unfortunately, most of them are neglected and lost. Only very few are remaining in the department. These are not books, maybe isolated papers. He was in touch with people all over the world. I see when I checked the whatever is remaining, I see large number of reprints donated by foreign workers, foreign institutions, Smithsonian institution, then British Museum contributions, reprints from Australian workers, etc. And Indian forest records. There was almost a complete collection of Indian forest records on entomology, but most of it is gone. This is a Plant Protection Overseas Review, reviewing journal. We can also see his signature on the top. Then coming to the insect collection, which is called Travancore Insect Collection, which was built up by him. This includes specimens from I have seen specimens collected in 1908, 1910, 1911 by foreigners in the Nilagiri Hills there. Probably, I don't know how it reached Vellayanni. Probably they were all part of the entomology session of the Travancore University. When there was an entomology session and the staff came to Vellayanni, the collection was also moved to Vellayanni, probably. This was the largest insect collection in Kerala. And after the demise of Dr. Marjike, this collection was in the department where the staff used to sit. It was in a large hall. When after his demise, people changed, priorities changed, and the entire collection was dumped in the cellar, along with his papers, all other old documents. Okay? Nobody took care of the collection or the records, not for a single year, for decades together. I joined the department as a regular staff in 2002. Then I went to the cellar and I saw it was pathetic. 95% of the specimens were gone. And nobody cared to curate or preserve the material. And some of the teachers, when they have a class, I have a class at 4 o'clock or 3:45, I would go to the room, pull out specimens and give it to the UG students. Then it would never be returned to the collection. There was a leather-bound book. I have not seen it. I was told by Rajanachari sir that it was completely catalogued, and there was a leather-bound book which I have not seen, and it was lost. There was also a collection of several boxes of trip slides collected and identified by none other than Dr. G. N. Ananthakrishnan. And these people, they were all in contact with each other. And probably Dr. Ananthakrishnan donated these slides to Dr. Marjike. And when I was a UG student, I was not knowing the significance of the slide. I saw some of the slides being kept for identification. And then there was an examination. I saw the teacher peeling off the label on the slide and putting it under the microscope for identification. And that slide collection is almost lost. I have seen it with some people who are using it for UG teaching. And this is the insect collection. And I could salvage only very little. And this is a collection of coccinellids and some chrysomelids. And Dr. Marjike, with the C.N. Newman, published a small note, a first report of a Kalispa on coconut. And whatever, though Dr. Marjike was not a taxonomist, he knew the relevance of voucher specimens. When he published the paper, he sent specimens to specialists, S.P. Shukla and R.N. Mathur. You see, he sent the specimens to 2 people for cross-verification, and then the specimens were returned. And he kept those specimens in the reference collection, and Marjike's collection was a complete collection of reference material of all croppers and other insects, which was completely spoiled. And fortunately, I could salvage a few boxes because they were beetles, they are hardy structures, and all the moths were gone, and many other things. And I found out 4 specimens of this Calispa because they never identified it to species level. It was an undescribed species. When I started working on Calispa, I found out that this is a new species. And there is a paper by MRGK. How do you know that this is that? The only way to show that what MRGK published as Calispa species is the new species is to check the voucher specimen. Fortunately, 4 voucher specimens were there. I described it as a new species of Calispa, Calispa carum. And his specimens, 4 specimens, were designated as paratypes and they were sent to IRA for preservation. And similarly, I am currently doing a paper on tortoise beetles of Kerala. Several beetles I could not collect despite years of efforts. But when I checked MRGK's collection, they are there with identification label from the British Museum. Those specimens were identified by great people like Spade, a French entomologist, Jacobi, who worked in British Museum, then Maulik, Samarendra Maulik, a Bengali, who was in London and published the Fauna of British India series under the Chrysomelidae in 4 volumes. Okay? And Dr. MRGK was also instrumental with Dr. K.K. Nair, a well-renowned insect physiologist who worked in Kerala University in the formation of the Association for Advancement of Entomology. And MRGK was the founder president of the association from 1975 to 1998. Dr. MRGK requested the general body that he should be relieved of his duties as the president. And it was accepted. Within a few months, he expired. And the association started publishing Entomon in 1976. Of course, MRGK Nair, K.K. Nair, T.N. Anandakrishnan, all these great people were involved in the publication of Entomon. This is the first issue of Entomon, first volume, first issue. We have now digitized everything. We have uploaded all the volumes in the Internet Archive for the use of anybody who wants to use them. And this is the current volume, the March 2026 issue. That is, Entomon has now completed 51 volumes. It is indexed in Scopus, Web of Science, Master Journal List, Zoological Record, and other CAB abstracts and other relevant abstracting journals. And Dr. MRGK was also a perfect family person. He is with his grandchild, Jagakrishnan, who is in US now. This is MRGK family. On the left side is Jagakrishnan, who prematurely expired. Then his son-in-law and daughter. And Jagakrishnan is sitting between Mrs. and Mr. MRGK. And I saw MRGK only once. When he came to Velaini, when I was a second year student, if my memory is correct, second year UG student, to deliver a talk on Ramakrishna Paramahamsa. He was very closely, intimately associated with the Ramakrishna mission, and very extremely pious and extremely kind person. And I am extremely grateful to Ms. Vimala, her husband, Mr. Govinathan Nair, Dr. C.P. Radhakrishnan Nair, who retired from CPCRI, then Dr. K. Sharadamma, Dr. C. Nandakumar, and of course K.M. Srimar for the Malayalam book. And all these people kindly gave me the information for this talk. And I am extremely thankful to the organizers for the opportunity to speak about Dr. Marjiki. And this has been a great learning experience for me also. And most of our people die. And they leave nothing, but MRGK has survived. His work has survived. Even today, we consult his work. We use them. And I am sure that for generations, his work, he is going to survive through his work. Okay.
Thank you, Dr. Pradhavan. Give him a big applause. He has just explained about the life and work of a legendary entomologist, Dr. MRGK. We used to hear about MRGK, sir, when we study in the second year about pest of crops. Then all the people will have one Bible for entomologists in Kerala, that is monograph of crop pests of Kerala. We used to consult it as our Bible, and we used to copy the pictures of the pests from that book only. Everybody will be having a personal copy. When there is a book bank scheme, the first book to buy was that book only. And now the entomologists of Kerala have started, we have made a very earnest tribute to, we are trying to make an earnest tribute to MRGK sir by revising this book. Then only we came to understand the tough task we are facing. It is for the past 1 year we are doing that. So a legendary entomologist. It was actually Dr. Joseph Rajkumar from CPCRI in one of the first discussions about conducting this seminar. Then he only suggested that there should be a memorial lecture about MRGK sir, and Dr. Pradhavan made it, and it's a very, very interesting one, very, what I would say, ഹൃദയ ദ്രവീകരണം ഉള്ള ഒരു ടോക്കായിട്ട് മാറി. Thank you, Dr. Pradhavan. Pidambar sir must have interacted with MRGK sir. So
Professor MRGK was my teacher. He was my teacher. And at that time, there was another great person in entomology department, Rengayar. Yes. Rengayar was as a taxonomist. He was much. He died very young. Rengayar died very young. Very young means he must be about 40s, 45s, and all that. But he was a great teacher. And after his death, MRGK took those classes. MRGK, then Mohandas, all these persons taught us. And it was MRGK who brought nematology into entomology field. And there were, first time we were shown a nematode, and plant parasite nematode in the department, not by MRGK, but Vishal Dithar. She showed us, Vishalam was working with MRGK. Then the saddest part is, during his last days, where he suffered much. For about a year, he was. I used to go and visit him when he was sick, and he suffered really very bad. A lot of problems, and but whatever thing is, his legacy is remaining. His book, and as you was mentioning, during those days, the entomology collection, say we all used to collect entomology insect box. So the MRGK used to collect whatever things he wanted from there and keep it in his collection. But nowadays the insect collection is not, I don't know, the students are collecting it not.
Very limited.
Very limited. So we could give 2 boxes of insect collection, say order wise, and MRGK used to take whatever thing he requires and he gives it back to it. So MRGK just one of the respected teachers of the department. And in the entomology department, MRGK, and pathology, our J. Samraj used to. Thank you.
Thank you, sir.
Sir, I appreciate Dr. K.D. Prathapan for the scientific legacy, for documenting the scientific legacy in a most respectful and scholarly manner. And as Sir mentioned, the first report of Rhadophilus similis in banana is in India is from Velayani, and it is because of that the department of the research work in nematology started in Velayani, and as a result of that, one center, that is the in All India Coordinator Research Project on Center, the Velayani Center was identified because of the report of this nematode and further work by the eminent scientists from CPCRI Kayangulam and CTCRI Srikaryam. Thank you, sir.
Sir, it's a real tribute to one of the greatest legends of entomology, Dr. MRGK Nair, no doubt about that. I think Dr. K.D. Prathapan has done a beautiful coverage. I think the way in which he has collected the information, put it in order and presented is something. Morning we have heard about Professor Samraj sir, also by Pithambaran sir. It was really wonderful. I think I am very sorry that only few entomologists are around. All the entomologists should have listened to this, because that is how the legacy is transformed to the next generation. So the next generation, it is a learning experience, no doubt about that. Not only the actions which he has made, not only the book he has written, the way the human nature of him, and the way in which he has taken entomology to that high level. We have to really salute him and his contributions, and the befitting talk by Dr. K.D. is second to none. Many congratulations, Dr. K.D. Prathapan, for this wonderful collection and narration of the information. Thank you.
Requesting the chair and co-chair to present the memento to Dr. Prathapan sir. Dr. Prathapan sir is requested to receive the memento from the chair and co-chair. Also, the organizers are presenting gift to Dr. Prathapan sir, inviting Dr. Sainamal madam. Sir, please. Dr. Prathapan sir is requested to receive the gift from the organizers. Now the technical session 1 will be resumed shortly. Requesting the chairman, Dr. Pithambaran sir, and the co-chairman, Dr. Joseph Rajkumar sir, to resume the technical session 1. We request the rapporteurs also to join the session. Rapporteurs of technical session 1. We request the rapporteurs to join.
We are continuing with our oral presentations. Did you check whether Vineet Vijayan is available? Vineet Vijayan is online. Is she available now? So just put on her. Requesting Vineet Vijayan. Requesting Vineet Vijayan to present the paper on microbiome engineering. Are you ready? If she is not ready, we pass on to the other paper. OP4. Is OP4 ready? Is OP4 ready? OP4 is induction systemic resistance by rhizosphere microbiome. Fourth is not ready. Okay, fine. Fifth, Rashmi. Yes, please. Again 6 plus 1.
Good afternoon and warm welcome to one and all present here. Actually, I am delighted to present the topic, biogenic synthesis of silver nanoparticles from Trichoderma species, an eco-sustainable strategy for managing soil-borne plant pathogens. Actually, soil-borne plant pathogens, they cause severe yield loss and are a threat to the global food security. Actually, they are difficult to manage due to the conventional methods. Of course, the chemical methods are effective, but they cause environmental pollution or they harm the microflora and they promote pathogen resistance. And so, employing plant biocontrol agents like trichoderma, it is an effective method for the synthesis of biogenic nanoparticles. Silver nanoparticles, they are found to be effective against many many microbes. So with this, the present study was formulated with the objectives: biogenic synthesis of silver nanoparticles using trichoderma species, and the characterization of the synthesized nanoparticles with various equipments, and their assessment of antimicrobial activity of the synthesized nanoparticles against important plant pathogens. So this is the methodology followed by the Consolo and co-workers. Here the trichoderma is grown in potato dextrose growth and it is incubated, and the mycelial mat is transferred to the sterile distilled water and again incubated, and this completely grown culture was centrifuged and the cell-free culture filtrate was obtained. And this cell-free culture filtrate is mixed with the precursor of silver nanoparticles, that is silver nitrate, in a ratio 1:1. And this reaction mixture shows a brown color, which is the confirmation of silver nanoparticle synthesis. And this reaction mixture is again centrifuged and collected the nanoparticles. And this is dried, and this nanoparticle is characterized using various equipments, and these are used for the further studies. So coming to the results, biogenic synthesis of silver nanoparticles, actually 3 strains of trichoderma species were used, that is trichoderma asperellum and trichoderma asperellum KU reference culture and trichoderma hasianum. And the cell-free culture filtrate, when mixed with the silver nitrate, which is the precursor, the dark brown color indicates the production of silver nanoparticles. All the 3 strains of trichoderma species shown successful production of silver nanoparticles. So the next objective was the characterization. First one is the UV visible absorption spectra of the synthesized nanoparticles. The peak in the UV visible spectra between 400 to 450 indicates the production of silver nanoparticles. And the second instrument was the dynamic light scattering, and it is for the ascertain of particle size, polydispersity index, and also the zeta potential, which is the measure of uniformity and the stability of the nanoparticles. And the isolate T9 silver nanoparticles shown the minimum size. Coming to the next characterization, that is the XRD, X-ray diffraction pattern. This, the 2 theta values in the X-ray pattern of 30 degree, 44 degree, 64 and 77 degree indicates a face-centered cubic center structure of, that is the pure crystalline structure of silver nanoparticles. The third one, the fourth one is the Fourier transform infrared spectroscopy. This is for the identification of functional groups present in the nanoparticles. This instrumentation, they've identified the alcohols, amines, and nitro compounds and various alkanes present in the molecules which are responsible for the production of silver nanoparticles. And the fifth one is the field emission scanning electron microscopy. This confirmed the spherical size of silver nanoparticles, and the graph shows the average size of silver nanoparticles, which is all the 3 isolates of trichoderma species produced silver nanoparticles having a size less than 100 nanometer. This is the energy dispersive X-ray spectrum of the silver nanoparticle. The peak in the graph at 3 kilo electron volt shows the presence of silver nanoparticles, and the quantification of silver nanoparticles, that is 89.25%, indicates the confirmation of silver nanoparticles. The same trend was followed for the next isolate, that is T7 silver nanoparticles, and also the same trend for T9 silver nanoparticles. Coming to the high resolution TEM analysis, here also the spherical structure and nanometer of size less than 100 nanometer indicates the successful production of silver nanoparticles. Coming to the results of in vitro evaluation of silver nanoparticles against the fungal pathogens. Here this is the antimicrobial activity of T2, first isolate against the major plant pathogens. The pathogens tested were the Phytophthora capsucci, Fusarium oxysporum, Rhizoctonia solani, Sclerotium roxy, and Pythium aphanidermatum. And the concentrations of the nanoparticles tested were 500 ppm, 750 ppm, and 1000 ppm. And here, as the concentration increases, the inhibition also increases. The same trend was followed in the case of T7 also, T7 silver nanoparticles. As the concentration increases, the inhibition increases. This is the third isolate. Here also the concentration increases, this inhibition increases. Coming to the tabular formulation of in vitro studies, here we can see the T7 silver nanoparticles was found to be effective against Phytophthora, Fusarium, Rhizoctonia and Sclerotium, and T9 silver nanoparticles was found to be effective against Pythium afanidermatum. Compared to T2 and T7, T9 silver nanoparticles were found to be less effective. In the case of sclerotium rholsi, the lower concentrations of T2, T7 and T9 were found to be less effective, whereas the higher percentage, 1000 ppm was found to be effective against sclerotium. Only T7 silver nanoparticles was found to be effective against sclerotium. So to conclude, integrating the biological potency of Trichoderma species with nanotechnology offers a high performance, sustainable and eco-compatible alternative for chemical pesticides. Thank you.
Say, what is the difference between the management, control ability of silver nanoparticles trichoderma and the normal trichoderma? How many percentage more?
In this is my PhD study, sir. I have compared the efficacy of Trichoderma aspergillum, that is the reference culture, along with the nanoparticles. Actually, we have seen more inhibition in the case of silver nanoparticles.
That more, I want to quantify that more.
Actually, it was, I think it was, in the case of Phytophthora, it was 84 or something. In the case of 70.2% in the case of Trichoderma, but it is showing 80% above inhibition by silver nanoparticles.
6% more.
Yeah, silver.
And again, your photographs about Phytophthora and Pythium.
Yeah.
Something fishy about that photograph. Can you show me that photograph again?
Phytophthora capsicii and Pythium afanidermatum I was used to.
Because that photograph doesn't look like Phytophthora. It is it is a shape of a star shape.
Yeah, the Phytophthora capsicii, it is growing like that only, sir. Phytophthora capsicii.
But Pythium also is growing the same thing. I don't know. Okay. Any questions?
It's audible. Okay.
It is after all silver nanoparticles.
Yeah.
So how far silver is a heavy metal and how far it will be safe in the soil? Whether there will be accumulation issues or something. And second one, whether what will be its interaction with other soil microorganisms, because it's an in vitro study here. There is no study on the soil conditions.
Actually, we are synthesizing the silver nanoparticles using the biological Trichoderma species. So the basic principle is that the extracellular enzymes or the phytohormones or the secondary metabolites produced by the Trichoderma species is using as the reducing agent or the stabilizing agent in the synthesis of silver nanoparticles. So it is found to be eco-friendly. And in the case of Trichoderma, there are various extracellular enzymes produced. So actually the biocontrol, Trichoderma species is known as well-known biocontrol agent. So it is having a dual benefit. What was the second question, ma'am?
Whatever methodology you have used, the final product is silver nanoparticles.
Yes, ma'am. Final product.
There is no change in that. No.
Yes, final product is silver nanoparticles. But is
That was the question I understand.
yeah, it is silver nanoparticle. But is the stabilizing agent, the reducing agent covering this? It is the extracellular enzymes or the phytohormones or the proteins produced by the fungi. So there is difference in the normal silver nanoparticle and the biologically synthesized nanoparticle.
That's fine. Okay. Because we are running short of time again. One final question to you. What is the principle of spectrophotometer? Used in your experiment?
Yes, sir.
Okay.
It is measuring the absorbance. That is when UV visible light.
Principle on which it is based. That's what I'm asking.
UV visible, when the UV visible light is projected to the sample,
Fine.
the absorbance is measured. So
Thank
it
you.
is measured in the wavelength.
This is the outcome of that. The principle is Beer-Lambert's law. Thank you.
Yes. Thank you, sir.
So she's Reshmi. She's. We need this ready? Online. Yeah. Your time starts, Dr. Vinith. Please proceed. Number 2.
Different compartmentation of a microbiome is there. There is I deal with microbiome. It is basically deal with the fungal part of the microbiome associated with plant. Here I am using management of disease, blended sheet and leaf blight of maize. It is a Rhistonia based disease and it is a soil borne disease. Come to major objectives. The major objectives are to decipher the structure and composition of microbiome in the maize and to evaluate biocontrol potential of a microbiome against this particular disease. These are major objectives we have designed for this study. And come to methodology. Here methodology we are considering India's 2 part of the sampling location. One is Delhi and another one is Bihar. And there is we are collected aseptically that sample means without any contamination. We are purely consider that microbiome sample. Then after we are considering same sample dividing and using for a metagenomics analysis and the culture method simultaneously. And from there we are identify that antagonistic reaction, that is with the dual culture assay and in vitro assay, like that all assays we are completely using for that antagonistic effect. Then we are bringing that more efficient group of the fungus into the field. There we are checking that efficiency. Then we are come to the genomic level. We are using that seed biopriming. Come to result. Result part we are dealing, first part is metagenomics we are broadly using and what are the genes presenting in the both region and Delhi and Bihar. Then we are simultaneously using cultural method. There is nearly 9 genes like Alternaria, Cladospecium, Fusarium, Pencilia, Aspergillus. Like that most of the genes present in the plant system we are isolated simultaneously. It is around 272 genes we are isolated and we are identified. And then we are come forward with the dual culture assay. Then there is some group I am highlighted there with a red column. That Aspergillus group from the Bihar region is performing more function. It is approximately top 47.817 mycelium inhibition is showing. That is Aspergillus is showing some significant inhibition of a disease. Then we are come to Delhi region. There Aspergillus genus group is already there. Then ultimately there is also Penicillium oxalicum genus also there. Their performance also nearly 53.133% is mycelium inhibition also showing. Then we are short down this group into some representative groups, like all representation we are bringing here Aspergillus, Penicillium, Cladosporium and all genus, and we are focusing mainly that good performing in vitro things. And there is again they are performing penicillium and Aspergillus is performing well. There is in plant assay in phytotrons facility they are showing below 20% disease incidence. That's why we are bringing that into the field for the identification of their performance. There we are concerned morely about that field level assay. There we are treating seed and foliar simultaneously. Then we are bringing some significant result like increment of field is at the time of disease also it is showing 31% and the disease incident level also reducing nearly 53%, 52.93 is significantly reducing Aspergillus. Then we are considering that same genus group as into the seed biopriming capability. Then it is showing Aspergillus and penicillium is significantly upregulating that significant gene beta 1,3-glucanase and catalase and peroxidase and polyoxidase and superoxidase dismutants, and like that genes are again upregulated. Among them, penicillium is significantly always showing a upregulation. Then come to these studies, the metagenomics analysis mainly showing that thermomyces, leptospirial, like unculturable human species are also we are getting. Then come to microbiome approach. There is a 9 genus, Alternaria, Aspergillus, Cladosporium, Fusarium, Almerium, Mucor, Penicillium, Cladarium, Culveraria, Purpurarium. Like that the genus also we are got. That is a significant part of first part. And then we are bringing to Penicillium and Aspergillus genus into the in vitro study. Then in plant study we are bringing into Penicillium and Aspergillus. From that we are bringing that field assay also. Then we are significantly bioprime that selected genus, and then they have some evolutionary relation. They are always communicating with that population. That is a significant study I am showing here, and I am acknowledging this part of the research is my PhD work. That's why I acknowledge my chairman, co-chairman, and all department of ICR, IRA. Thank you all.
Thank you, Vineet Vijayan. So I got just one question. Say, I have just one question here. Your results, did you have statistically analyze that result?
Yes, sir. Statistically analyzed.
But no CD value is given there. And many of the things are, difference is very, very minute. And
sir, significance, it is there, sir, but it is in grouply. It is all about isolate. It is isolate is selected from one location, sir. That's why that significance is not showing that much. In genus level, that significance is nearly almost same, sir. That's why I am significantly telling that a single value, sir.
No, without the statistical significance, how are you going to say that which one particular this is better than other?
No, sir. Among statistics we are analyzed, that all statistics analyzed, we are CD value we got. From there we are taken from most mycelial incubated isolate. From there we are selected, sir. About 273 isolates.
Okay. Any questions? If no questions, thank you, Dr. Vineet. Thank you.
Thank you, sir. Thank you.
So next is T1 OP6 Ashida Joy. T1 OP6.
Good evening, everybody. Today I'm going to discuss on my topic actinobacterial metabolites and in silico insights for the rice bacterial leaf blight management. Rice feeds half the world population And one of the major biological constraints of rice production is bacterial leaf blight caused by Xanthomonas oryzae, Pathover oryzae. And Xanthomonas oryzae, it is a gram-negative rod-shaped bacteria which will enter through the stomata or hydatodes, and it affects the entire vascular system. And this is a chloropleth map showing the high suitability zone for Xanthomonas oryzae, Pathover oryzae, and India falls under a high-risk zone. And the different symptoms of bacterial leaf blight: in seedling stage, it is a crassic symptom which leads to the total failure of the crop, and also in the earlier stage, it is a like bacterial leaf blight symptoms. Why bacterial leaf blight should be controlled using biological control? As the world is shifting towards sustainability, there is an increasing demand for the biological control of bacterial leaf blight using actinobacteria, because it leaves no pesticidal residue, and also there is low risk of resistance, and it is an eco-friendly approach. Why actinobacteria? Because it's a very good plant growth promoting agent, and also it elicits the plant defense. So here, from the native rice, like rice rhizosphere, actinobacteria was isolated and enumerated. Almost 42 actinobacteria were isolated using the serial dilution technique on starch casein agar, and the actinobacteria were screened against Xanthomonas oryzae, Pathover oryzae using the primary screening, and qualitative screening was done using the dual culture technique. Out of that, 8 were taken, and it was screened against the Xanthomonas in the secondary screening using the disc diffusion assay. 3 were found to be effective: AMGD 20, 16 and 502. And these were characterized molecularly. AMGD 16 is Streptomyces ginkgonus, AMGD 20 is Streptomyces siamensis, and already reported UDG 502, it is Streptomyces rhinosus. And they were biochemically characterized, and for all the growth promoting characters like the phosphate solubilization, potassium solubilization, and also for the IAA production, it was found to be positive. And also for the siderophore production and also the catalyzed test, it was found to be positive. And the one field, season Kharif 2023 and 2024 field experiment was done, and one glasshouse study was conducted where the consortium consists of the seed treatment at 10 liter per kg and foliar spray of 10 ml per liter with AMGD 16, 20 and 502 at the rates of 10 to 8 CFU per ml had found to actively or efficiently reduce the disease up to 49.7% compared with that of the inoculated control. And further, to understand what is the metabolites or what is the cause of this plant disease suppression, we have subjected the methanol extracts of the AMGD 20 for to understand its complete metabolome. We have subjected it to HRLCMS, which is high resolution liquid mass spectroscopy, and here we have found some antimicrobial compounds, that is anthralinic acid and maltol, azelaic acid and xanthone, and some of the other plant growth promoting compounds like biotin, choline. Choline is a very good osmoprotectant, and also betaine, anthralinic acid, and then IBA. IBA is many more IAA derivatives were also found, which might be the cause for the growth promotion activity. And to understand how these metabolites interact with the pathogen, we have subjected to this entire study for molecular docking. So one pathogenicity factor, that is PTHO1, was modeled. The protein was modeled using the modeler software. Why PTHO1 was taken? Because it binds to the promoter region of OS sweet gene, which will upregulate the sugar influx, and it gives a nourishment for the Xanthomonas pathogen. And here the integrity of the protein model was checked using the Ramachandran plot, and you can see that most of the amino acids fall under the allowed region, and only very little are there, only very little or minute number of amino acid residues fall under the disallowed region. That is a white color region. Most of them are concentrated in the red color region. And this is the molecular docking study conducted, where you can see the 3D structure. That A diagram is the 3D structure of the molecular interaction between xanthone and that of the PTXO1. You can see the interaction between the amino acid residue and also the ligand. And here you can see that xanthone has the least binding energy. So it is the compound with the least binding energy, and the maximum number of hydrogen bond is said to be stable. And we've got xanthone as a compound, and even salicylic acid and anthracite acid also had a binding energy below -5. And to understand how stable is a protein in an environment, we have conducted a molecular simulation docking between xanthone and PTXO1 protein, and you can see that the first is the RMSD plot. RMSD plot is nothing but the root mean square deviation. It shows, you can see that it is between the limits, so it shows the overall integrity of the protein. And RMSF also shows the fluctuation. All RMS, RG, area, everything is under the critical limit. So it entirely shows the stability of the protein. Thus, in a way, you can say that xanthone is a compound which has a potential to become a very good bioactive compound, and it is stable in environment. Thank you.
So, thank you. Say, one question. Which is a commonly used biocontrol agent for blast? Yes. What about Pseudomonas? But why I asked you is because, why did you use Pseudomonas as a control? Absolute control is ordinary thing, but Pseudomonas, in many places they are using Pseudomonas. Even the cow dung slurry, that contains Pseudomonas. Say, why didn't you use Pseudomonas as a control? Anything, because the most commonly used biocontrol agent, either directly or indirectly. Directly you are using Pseudomonas, or indirectly you are using cow dung extract. So that contains Pseudomonas. Then my question is, why you forgot?
Ashida, you may use the mic.
Otherwise, the work is good, but if I use the Pseudomonas as a control, at least is a saying in silico.
Bacillus as a control. I like
Bacillus is different. Bacillus is not commonly used. Most commonly used is the Pseudomonas.
Sir, I'm working in Dharwad, sir. There, Bacillus is and Trichoderma I have kept as control, sir. The USD strains. So it has better performance compared to the university control.
Okay.
Yes. Thank you, sir.
Okay.
It is like a first report. So if you have to go for the large scale production, we can go in for the microbial fermentation, sir.
So to amplify this xanthone.
Yes, sir. To amplify the xanthone. Already in market it is present. So now I have proved that it is stable along with the xanthone, like Xanthomonas oryzae, Pathor oryzae.
Thank you.
Next, we move on to the oral presentation, T1 OP7, Rosin Maria Aloysius. T1 OP7.
So good afternoon everyone, I am Rosin Maria Aloysius, I am a student from Sacred Heart College, Tevra. My work is on comparative gene expression and pathway enrichment profiling of Arabidopsis thaliana exposed to rhizobacteria. So Arabidopsis thaliana belongs to mustard family, and it is a popular model organism in research. And I have, in this study, I have used Agrobacterium tumefaciens and Rhizobium leguminosarum, and it is infected in Arabidopsis. The strains used are LBA 4002 and 99 bar 11478 PGPR. So my objectives of the study are to compare the differential gene expression patterns in Arabidopsis thaliana exposed to the two trials of bacteria, and to identify the functional significance of the DEGs through gene ontology and KEGG analysis, and to investigate the activation of plant defense pathways associated with ISR and SAR. So when it comes to the results, the total DEGs for AT is 305 and for RL is 233. And when it comes to the chromosome-wise distribution, chromosome 1 of 80 is showing highest percentage of DEGs, and chromosome 4 is showing less number of DEGs. When it comes to the RL, chromosome 5 is showing the highest number of DEGs, and in same way chromosome 4 is showing lowest number of DEGs. And we can also see the position of chromosomes when compare AT and RL. We can see the similar areas of DEGs can be expressed in chromosomes. And when it comes to the upregulated and downregulated conditions separately, in AT the chromosome 5 is showing the highest number of DEGs, and in RL chromosome 1 is showing highest number of DEGs. In both chromosome 4 is showing the lowest number of DEGs. When it comes to the downregulated condition, chromosome 1 is showing 1 of 80 showing the highest number of DEGs, and in RL chromosome 5 is showing highest number of DEGs, and the lowest number of DEGs in chromosome 4 and 3 in AT and RL. So when it comes to the types of DEGs, mostly protein coding DEGs are seen in both the treatments. So when it comes to the distribution, total uniquely expressed DEGs are 222, and uniquely expressed DEGs in RL is 115, and common DEGs are 83. So when it comes to the top 10 DEGs upregulated due to AT and RL, the mostly highly upregulated gene is kinase-like protein in AT, and in RL S-adenosyl L-methionine dependent medial transferase superfamily protein is highly upregulated, and we can see the extracellular lipase and VHLH family protein is in the top 10 categories in both the treatments. So when it comes to the downregulated DEGs, Kundi's family trypsin and protease inhibitor is highly downregulated in AT, and in RL bifunctional inhibitor protein is highly downregulated. So when it comes to the common, extracellular lipase is a highly upregulated DEG, and in downregulated condition, F-box family protein is the highly downregulated DEG. So when it comes to the gene ontology, biological process and cellular process and molecular functions are considered. First one, for common, the highest fold enrichment for biological process is seen in response to herbicide, and in downregulated condition it is for lipase activity. And when it comes to the total DEGs for biological functions in two treatments, in AT the region of ion transport is highly enriched, and in RL the shade avoidance is highly enriched. When it comes to the downregulated of the biological process of the total DEGs, in AT tryptophan biosynthetic process is highly enriched, and in RL ammonium homeostasis is highly enriched. So when it comes to the cellular process, total DEGs is upregulated due to AT and RL. It is only one pathway is highly enriched, that is secretory vesicle in AT, and in RL no significant pathways are shown. So when it comes to the molecular function in total DEGs, upregulated, in AT no significant pathways are shown, but in RL indole pyruvate monoxidase family is high fold enrichment can be seen. When it comes to the downregulated, in AT only one pathway is highly enriched, that is glucocurnosilane-4-medial transferase activity, and in RL cis regulatory regions we can specific DNA binding. When it comes to the KEGG analysis, the total DEG is upregulated and downregulated when we take the condition in AT and RL. Flavonoid biosynthesis, nitrogen metabolism and water proteins are the highly seen pathways, and in RL tropin, piperidine and pyridine alkaloid biosynthesis and plant hormonal signal transduction is highly seen. And in total DEGs in downregulated, that is phenylalanine, tyrosine and tryptophan biosynthesis and circadian rhythm pathway is seen. So when we compare when we select the unique DEGs in these two treatments, we can see that along with flavonoid biosynthesis in AT, we can also see the metabolism pathways, and in downregulated the same pathways are seen. So when it comes to the systemic acquired resistance in common and unique DEGs, AT-PDF 2.1 in AT is highly upregulated, and ALD1 ATP-DF 2.5 is highly upregulated in common, and in downregulated AT-PDF 1.2b, AT-PDF 1.1 LTP4 is downregulated, and in RL it is DIR1. So when it comes to the induced systemic response in common and unique DEGs, that is in AT BHLS 38 and BHLS 39, LHY is highly upregulated, and in downregulated in AT is PDF 1.2a, and its common is FRO2, and in RL no ISR responses are seen. So, salient findings and conclusion: Arabidopsis thaliana showed distinct gene expression response to Agrobacterium tumefaciens and Rhizobium leguminosarum. Arabidopsis tumefaciens induced higher transcriptional changes compared to R. leguminosarum. Chromosome-wise DEG distribution revealed that chromosome 5 consistently contained the highest number of DEGs, whereas chromosome 4 the lowest DEG frequency. Most DEGs identified were protein coding genes, commonly upregulated genes such as FR002, NRT 2.1, XL4 and VHLS transcription factors, and KEGG analysis showed a flavonoid biosynthesis and secondary metabolic pathways are highly enriched, and in R. leguminosarum plant hormone signaling pathways. In conclusion, Arabidopsis thaliana exhibited distinct molecular response to pathogen associated and beneficial isobacterial interactions. Agrobacterium tumefaciens triggered stronger defense and secondary metabolite responses. Various Rhizobium leguminosarum mainly influenced the hormone signaling and ISR related pathways. The study highlighted the differential regulation of defense signaling and metabolic networks during plant rhisobacterial interactions.
See, at least in future, don't speak this fast. we didn't catch whatever thing you are saying. It is not clear to us. That is, you try to cover the entire topic. Should I reduce the topic, the number of slides? Then, because of that, you are not able to clearly explain what is in your results. So, in future, at least, don't do this much of slides. For a 6 minutes presentation, not more than 10 slides. So, you have got about 30 slides. So, do that. Any questions?
Madam, excuse me. Now, in what way this can be used for our food security?
Food security. Sir, other analysis has to be done, then I have to conclude that the work is ongoing.
Oh, it's not yet concluded to give
Not
as a
yet
practical
concluded.
application. Thank you. Thank you.
I understand your work is in Arabidopsis and 2 organisms. But we have already spoke about ISR and SAR, but I expected something related to the upregulation of hormone, especially salicylic acid and jasmonic acid signaling, and it is surprisingly not seen.
No, ma'am, I am doing the work. I am only completed this much, so I presented only this much. So I am doing the analysis.
Yeah, it should be there. It should have been there in the pathways if that was the case.
Okay, ma'am. I will include it.
Please call the next person, please.
Next is an online presentation, T1 OP8, Tanuja. Online presenter, T1 OP8, Tanuja TT.
OP8 is online, huh?
Sir.
Tanuja, you may start the presentation.
Okay, sir. Good evening, everyone. The title of my presentation is Enhancing Indigo Performance Through Seed Scarification and Biopriming Treatments. So the phytomicrobiome plays a crucial role in maintaining plant health through a range of direct and indirect mechanisms. Among beneficial microbial groups, endophytic bacillus species have received significant attention owing to their adaptability, resilience, and multifunctional contributions to plant growth promotion. We all know Indigofera tinctoria. It is an important medicinal plant, and it is an economically important dye-yielding plant. Even though the cultivation of this Indigofera plant is limited because of poor and uneven germination, because the seed coat possesses hardness and also it have a thick integument. So it acts as a physical barrier and it will restrict the water uptake and delay seed germination. So a development of effective seed dormancy breaking and biopriming strategy is essential to improve this germination, plant growth and yield of this Indigofera tinctoria. So the prime objective of my study was to investigate the combined effects of seed scarification and bacterial biopriming on the growth and yield attributes of Indigofera tinctoria. And coming to the materials and methods, the seeds were collected and the seeds were subjected to various dormancy breaking treatments like sand scarification, boiling water dip for 1 second and concentrated sulfuric acid dip for 4 minutes. And after these scarification treatments, the seeds were subjected to microbial pre-treatments with the Bacillus species like Bacillus pumilus, Bacillus amyloliquefaciens, Bacillus thalacensis, and a combination of these three. And the seed without any scarification and biopriming treatment were taken as the control. So after the treatment, the seeds were sown in pro trays, and then 30 days after sowing, the seedlings were transplanted to grow bags. And the seedlings were evaluated at the flowering stage, that is 120 days after sowing, for growth performance and the productivity. And the results showed that the seeds scarified using sand and then pre-treated with Bacillus amyloliquefaciens showed maximum number of branches, stem girth, fresh weight of leaves, dry weight of leaves, fresh weight of shoots, dry weight of shoot, then number of effective root nodules, fresh weight of root nodules and dry weight of root nodules. Like that, the seeds scarified using boiling water treatment for 1 second and then treated with Bacillus amyloliquefaciens showed maximum plant height, the number of branches, fresh and dry weight of leaves, then root parameters like root length and fresh and dry weight of roots. So the effect of this combined seed scarification and biopriming likely enhance seed coat permeability, facilitating rapid water imbibition and effective bacterial colonization, which collectively improved seed germination, plant vigor and overall growth performance. The effect of this Bacillus amyloliquefaciens may be attributed to its capacity to utilize starch as a carbon and energy source through the production of amylase enzymes. And also, these amyloliquefaciens strains promote plant growth through the combined production of IAA, growth-stimulating volatile organic compounds like acetylcholine and 2,3-butadiene, and nutrient-mobilizing enzymes such as phytase. And because of all these components, they suppress several fungal pathogens. So presence of this IAA, it improves this cell elongation, root initiation and overall development of the plant. And also the presence of this phytase enzymes, they improves the phosphorus availability. So the main salient finding is in Indigofera tinctoria, the sand scarification combined with Bacillus amyloliquefaciens was particularly effective in enhancing branching, stem girth, leaf and shoot biomass and nodulation, whereas boiling water treatment combined with Bacillus amyloliquefaciens promoted greater plant height, root length and root biomass at the flowering stage. Integrating seed scarification methods with biopriming enhances growth, nodulation and biomass accumulation in indigo plant. Thank you.
What is her name? Tanuja? Can you hear me?
Yes, sir.
See,
Yes,
this
sir.
Indigofera tinctoria is cultivated in two countries. It is cultivated in Kenya and also in India it's Bihar. What are the common practices used by them to cultivate tinctoria?
Because of its yielding capacity.
Pardon me?
Sorry.
You were working on
Because of its yielding property.
Yes, I know, but what is that? The farmers, what is the technology used by farmers to induce germination?
So sand scarification.
Scarification with what? Sand scarification.
Yes.
But do you find any additional benefits from here by using these microorganisms?
No, sir. I did only the sand scarification, boiling water treatment, and then acid treatment, sulfuric acid treatment.
And the biopriming?
Biopriming with Bacillus species are Bacillus pumilus, Bacillus amyloliquefaciens.
No, what is the difference?
And
What is the
Bacillus
difference?
thalacensis.
I clearly understood the difference. How much more you are getting by the biopriming?
So after scarification, each seed were treated with this Bacillus species.
Then, what is the additional germination percentage?
The germination percentage was seeds scarified using sand. It performed above 75% in all the trials.
And with the biopriming?
So biopriming, first I did this scarification, and each scarified seeds were run with this biopriming with the Bacillus pumilus, Bacillus amyloliquefaciens. So totally I had this 20 treatments.
See, the point here is the interaction study should have been statistically done separately so that it would have better evolved the results. That's why sir was asking that in clearly. See, Bacillus pumilus, liquefaciens, as well as the scarring and everything should have been done separately with the interaction so that
Yes, sir.
holistically
I
you
have
can
done
say.
that separately also. S1T5 means it was done with sand scarification only. Then S1, S2T5.
No, the outcome should have been pooled in such a way that the interactive effect and the solo effect would have been very clearly spelled out. Okay, thank you. Any questions, please? Okay, thank you, ma'am.
Yes, sir. I did mention only the interactive effect only. Okay, sir.
Okay.
Now it's time for the tea break. The technical session 1 will be resumed after the break at 5 p.m. The tea is arranged outside. All the registered participants are requested to collect their bags from the registration desk. I repeat, all the registered participants are requested to collect their bags from the registration desk. Thank you.
Nilofer.
My slides are not presented.
That is OP9.
Yes, sir.
Till OP8 we have completed. This is OP9 online.
Next presentation, T1 OP 10, Prachi Patil.
Excuse me, sir, I'm present. Right now, my slides are not being displayed on the...
There's some technical issue just like after this waiting.
10, sir.
What about 9? 9. Slides are not ready. Okay, right. 10, please carry on. You are... Rashi Par.
Yes, sir.
Yeah, please carry on.
Sir, should I start? Good evening, everyone. My name is Prachi Patil. I'm from the Department of Agricultural Entomology and College of Agriculture, PADANNAKKAD. Today, I'm here to present our work on the first report of the nematode, that is Leidnima protentiose, which is associated with the coconut root grub, that is Leucophilus coniophora. As we all know, coconut root grub or the Leucophilus coniophora is the most devastating pest of the coconut plantation, especially in the southern India. And apart from the economic importance of the pest, one more interesting thing about the root grub is it possesses the hindgut fermentation chamber, which is most common feature of the scarabid larvae, which stores the several microorganisms and which aid in the digestion of the complex organic matter. And coming to the nematode, that is Leidnima, which belong to the family Thalassomidae. The Thalassomidae nematodes are most commonly associated with the many insects, and but their association with, particularly with the scarab larvae, has not been explored wisely. So here, in this context, we are reporting for the first time the association of the Leidnima protentiose with the coconut root grub Leucophilus coniophora, with the objective to identify the nematode associated with the root grub, to study its morphological and molecular characterization for the species identification. In this context, the different instars of the Leucophilus coniophora was collected around in 150 number, from the coconut and banana plantations of the instructional farm 1 of COA PADANNAKKAD within the period of January to October. Then the collected grubs were dissected using the stereo microscope, and the nematodes were isolated from the fermentation chamber. The isolated nematodes were further analyzed morphologically. Then PCR amplification as well as the sequencing and blast analysis was carried out for the species characterization. Here are coming to the results. First, the morphometric differentiation of the Leucophilus grub was carried out to differentiate the instars into the first, second and third, and based on the characteristics like length of the grub, width of the head capsule and weight of the grub. Here, the last column, we can see after dissection, the number of nematodes from each grub was calculated and averaged here, and the maximum number of nematodes were obtained from the second instar grub of the Leucophilus. Here is the, after isolation, the nematodes were first subjected for the morphological analysis, where we can see the morphological characterization revealed a cylindrical body of the nematode, which is tapering towards both the ends and having the distinct annulation throughout the cuticle, as well as club-shaped esophagus with the terminal distinct bulb was observed, and this is the distinct characterization of the Leidnima protentiose species. And that's why here there is a morphological confirmation of the Leidnima protentiose. The next, after morphological analysis, the molecular analysis was also carried out by PCR amplification. The amplified product was further sequenced and fed to the blast analysis by using the NICB database, and where the molecular analysis confirmed the 96, that is highest percentage of similarity, that is 96.40% with the Leidnima protentiose. Here, coming to the silent findings of the study, where based on the morphological and both the molecular analysis, here we first report the Leidnima protentiose associated with the Leucophilus from the India. The highest nematode population was observed in the second instar grub of the Leucophilus. The morphological and the molecular analysis was combined, and they are performed as evidence for the confirmation of the species Leidnima protentiose. Finally, I thank Kerala Agriculture University, Department of Agriculture and Entomology, College of Agriculture PADANNAKKAD, and College of Veterinary and Animal Science Manurti for their providing facilities and support for the study. Thank you.
Good. What is the functional role of this particular nematode? Or in your observation, did you get any endomopathogenic nematode in the gut or somewhere else?
No sir, it's not pathogenic actually. Based on the previous literatures, it has shown like mostly Laednima appendiculata was associated with different insect species, mostly cockroach, different species of cockroach, and most common is Periplaneta america. In that, its role is commensal. It's not parasitic, and in this study also there was no significant observations of any pathological symptoms or any kind of reduction in the body weight or length of the grubs.
So whether it has any role in the decomposition of the material which is coming into the gut?
Maybe sir.
But you have not done anything on that line?
Sir, the further physiological studies based on the digestion has to be carried out.
In your observation, did you get any endomopathogenic nematode beyond this Laednima? That's what I wanted to know.
Sorry sir?
Any endomopathogenic nematode did you come across? Because we at Kasaragod, our team has done a lot of work on this, using management of this particular grub using endomopathogenic nematode. That's what I am just curious to know. In your observation, did you ever get any grubs infested by the endomopathogenic nematode? That's it.
No, sir.
No. Okay, thank you.
Respected dignitaries, chairperson, scientists, professors, and my dear friend, good evening to one and all. I'm Huda Nilofer. I'm currently doing my master's research at ICR Indian Institute of Millets Research, and I'm a student from Professor Jayashankar Telangana Agricultural University, College of Agriculture, Rajendra Nagar, Hyderabad. Finger millet is scientifically known as Eleusine curacana, is a climate resilient crop, nutri-cereal crop rich in calcium, iron, and dietary fibers, and it is currently serving a stable food crop for the southern Africa and Asia. However, its productivity is highly affected by blast pathogen, that is Magnoporte griseae. However, chitinases are important pathogenesis-related proteins. The chitinases plays a key important role here by degrading the chitin, the structural component of fungal cell wall. Thereby, they arrest the fungal infection. Despite the chitinase gene studies have been done in many crops like rice, wheat, but its studies are highly limited and understudied in case of finger millet. So this study mainly focuses on dissection of chitinase gene family in finger millet, studying their structural evolution and potential role in blast resistance. Coming to the objectives, my two objectives are in silico characterization of chitinases, and second objective mainly focus on expression analysis of identified chitinases in response to blast pathogen at the seedling stage. Materials and methods. The first objective require in silico work, which incorporates the various bioinformatic tools. The major bioinformatic tools are phytosome. Phytosome is a plant genomic database from which I have retrieved all the 35 chitinases from finger millet genome. The second, PFAM and NCBI domain. The two different platforms are used for identification of domains, the highly conserved domains through which the identified chitinases can be classified into functional families, like the glycosyl hydrolase families. The next tool used is XPASI ProTparam tool for protein characterization, physicochemical characterization of all the identified chitinases. The Wolf-Pot and Cello was used for subcellular localization, and Muzzle Mega 11 was used for phylogenetic analysis and evolutionary relationship of these identified chitinases. The second objective requires the expression analysis work. The first, the expression analysis, the two germplasm line, that is FMG 127 and FMG 210 was mainly used. And after 21 days old seedling, the artificial inoculation was done, and a sample collection was done at 48 hours post-infection. Total RNA was extracted, followed by cDNA synthesis, and a real-time RT-PCR was performed. The relative expression levels were calculated using 2 delta-delta CT method, and the results are displayed. So coming to the first major analysis, it was done using the MEME software for identification of highly conserved motifs in the 35 chitinases. The 35 chitinases are listed against the p-value, and motif locations have been represented in the form of a block diagram. And the second major analysis is shown in the form of a physicochemical. Next slide, please. The next physicochemical characterization of all the identified 35 chitinases have been dissected. They are designated as leucine Korokana chitinase 1 to 35, indicating their gene ID, chromosomal location, nucleotide length, amino acid number, representing the variations, and then molecular weight, theoretical isoelectric point, and the grand average of hydropathicity was calculated using the above software which I've already mentioned. They have been classified into reliable classes like class 1 to class 5. The class 3 and 5 belongs to GH18 family, and class 1, 2 and 4 belongs to GH19 family. And they have been identified on the various locations inside the cell. The chitinase 16 is found to be the heaviest of all and longest, with the greatest negative gravy value indicating it's highly hydrophilic in nature, and it is located inside the nucleus, whereas the chitinase 33 was found to be the lightest in weight and its smallest, located on the chromosome, located on the chloroplast. The next major finding is done using the muscle software of next slide, please. The next major finding is done using the muscle tool of Mega 11 software for the construction of a phylogenetic tree, identifying the evolutionary relationship between the various chitinases which are identified. The 35 chitinases have been listed, and they were compiled for the construction of a phylogenetic tree. 4 major clades have been obtained through the results, and we have seen that the chitinase occurring in the similar clade shows similarity either in their conserved domains or catalytic functions, indicating they falls in the same family. Whereas the second phylogenetic tree indicates a comparative phylogenetic tree among 5 species. 23 chitinases from Arabidopsis thaliana, 18 from the Oryza sativa, 75 from Criticum aestivum, 34 from Sitaria italica, and 35 from Leucine Korokana were compiled for comparison among the chitinase gene family among the species. And the 4 major clades have been shown, and 4 major clades have been obtained as a form of result, which indicates that there is a similarity among the chitinases among various species. Coming to the next result, next major analysis is the expression analysis, which is obtained from the RT-PCR data. The RT-PCR data is plotted as in the form of a fold chain value, fold change plotted against the relative expression. The different chitinases, 35 chitinases have been plotted here, and among all of 35 chitinases, among all the genes, chitinase 6, chitinase 13, 31 and 20 have shown comparatively higher expression levels at the resistant line under blast pathogen infection, suggesting their possible involvement in defense responses. Next slide, please. So among all the 35 chitinases, chitinase 6, 13, 20 and 31 have been found to be the higher upregulated with a fold value greater than 1 at resistant line. The silent findings here are 35 identified chitinases, and the identified genes are distributed on the 7 chromosomes of finger millet, serving as a chitinase gene family. They are categorized into GH18 and 19 families. The last is chitinase 6, 13, 20, and 31 have shown comparatively higher expression. So the RT data, QRT PCR data can be used for identifying the potential candidate genes that can be further used in the resistance screening program. This work is a preliminary or can be considered as a foundation work for chitinase family dissection in case of finger millet. I'm deeply grateful to my advisory committee, Dr. Jeenu Jacob and Dr. C.H. Anuradha ma'am, currently doing my master's research at IMMR. And thank you so much for giving me an excellent opportunity for presenting my master's work. Thank you so much.
Thank you. Any questions from the audience? Yeah.
My question is that there are 35 chitinases identified, and the author has also presented the locations of those chitinases. Whether all of them are responsible for degrading the fungal cell walls, or those, is there any specificity, because they are present in all over the cell. I understand vacuoles and apoplastic space or extracellular are more important, and what is your opinion?
Yes, ma'am. In expression analysis data which is done using the RT-PCR have demonstrated that chitinase 6, 13, 20 and 31 have shown comparatively higher expression, indicating their upregulation, particularly against the blast pathogen, suggesting their particular role. Like 4 genes have shown the strong resistance against the blast pathogen, which can be used as a further candidate genes.
I agree that there is an upregulation, but I think a location of the chitinases is also important for its action.
Yes, ma'am.
Thank you.
Thank you so much, sir.
Okay.
Thank you for giving me an excellent opportunity.
So the 11th presentation is ready. Ms. Bhavana.
Next person.
Santomona Zoraisa.
Sir, there is one online presentation. T1OP20, Ansi Joseph. T1OP20.
20, yeah?
I have joined.
She has joined now.
Good evening all. I am presenting the details of in vitro and field trials conducted at Aromatic and Medicine Plant Research Station for the management of Fusarium wilt in cowpea. As we know, Fusarium oxysporum is a very destructive pathogen of cowpea, and it causes damping of and vascular wilt, leading to severe yield losses. Sometimes the loss goes even up to 100%. So the objective was to evaluate the field efficacy of Curcuma sedoria, that is Manyakuva, and Fedicium coronarium, that is Teliana sagundigam, which demonstrated Fusarium growth inhibition in vitro. Next. So regarding the materials and methods, in vitro screening was done using methanolic extract, adopting poison food technique, and the medium of growth was PDA, and source of test organism is Department of Plant Pathology, PADANNAKKAD. And field trials were done in RBD design with 3 replications and 7 treatments. And the treatments were given 4 times before planting and during the growth phases. And the first treatment is Curcuma sedoria rhizome powder, 10 grams per planting pit. It was given before sowing, then at the 20, 40 and 60th day after sowing. Fedicium coronarium, the same way it has been applied. Lime solution, 1% has been applied as a soil amendment to check its efficacy. Then trichoderma, 2%. Trichoderma viridae has been used. Then Pseudomonas, 1% seed treatment and 2% soil drenching. And there was an untreated control, then chemical fungicide, carbon dioxide plus mancozeb, that is SAF, at 2 grams per liter. Spray drenching has been given. This is the treatment, and it was done. This testing in field was done at AMBR's farm and also at one farmer plot. Next one. So these are the syngiberales which has been tested in vitro, and the most effective one was at 500 ppm. Manyakuva, that is Curcuma sedoria, that gave 51% inhibition. Fedicium coronarium gave around 39% inhibition, and it was followed by Alpinia calcarata and Curcuma angustifolia. So among these 13 syngiberales, Curcuma sedoria was the best, followed by Fedicium in vitro screening. So this is the field testing results. All the 7 treatments are there, and the mean percentage of plants infected is given there. So the most effective one were chemical fungicide and Curcuma sedoria. The results were on par, but the infection was comparatively high. That means 18% dose is there in Curcuma sedoria treated plot, and in other place it was 24%. And Pseudomonas compared to Trichoderma was less effective, and Lime was also less effective. And this is the field view and symptoms. This is an AMBR's plot, and this is the plot where over 20 years crop is being raised for seed production. So the inoculum is very high in this field, and the test has been undertaken here. Next one. And the effect of treatment at farmers' fraud. Here also the same 7 treatments were given, and their infection was less comparatively. And Curcuma sedoria and chemical fungicide was almost on par, and trichoderma here also better than Pseudomonas application. And the yield was not also satisfactory. And this is the field view of farmers' field, and there also inversion has been noted. Next one. So the prophylactic application of Curcuma sedoria significantly suppressed fusarium wilt, aligning with its in vitro antifungal activity. Efficacy was comparable to chemical fungicide. The effect is likely mediated by bioactive constituents such as essential oil and curcuminoids, which may inhibit pollination. Cadicium coronarium didn't show that much effect, and biocontrol agent was also less effective. So the demonstrated efficacy of Curcuma sedoria underscores its potential as a sustainable option for fusarium wilt management in cowpea. Large-scale validation will be essential to enable its integration into disease control program. Screening other plants. In addition to zingiberales, we can find out other active extracts also, so that there are chances of developing active formulation, botanical based formulation to control the disease. And even we can include this in crop rotation, which may be effective. That chances are also there. So this has been funded by 2 state projects. Thank you.
Hello, can you hear me?
Yes, yes.
See, here the chemical control gives almost 50 times more yield than the biological bioagent. Then the farmers will go for chemical control.
But even in that case, it is not an organic farming method. Chemical means it is vegetable and for consumption only. So we have an option here. That's the thing.
And what is the additional cost involved in applying curcuma? Curcuma is now very expensive.
Curcuma sedoria means manyakuva. It is growing as a wild crop, and the only thing is that we have to harvest when it is fully mature, powder it and use it. In current season, material is required.
The problem here is this wild curcuma is not cultivated. If you want cultivating, say, cowpea in large area, how much of curcuma you require? Powder. 1 acre of cowpea.
Yeah.
How much of this curcuma is required? Powder is required. From where are you going to get it?
That we have to collect from wild sources because it is available along the roadsides. That is an option only because we have just validated the result we have got in vitro trials, whether it is working that much with that much efficacy in field, whether it can is successful, it is giving result in the field also. If it is giving the result, there can be, but we have chances of developing botanicals from this extract. That is another option. This is bulk and to carry it is difficult. That is there, but usually along the premises the plant is available.
And see one just a kind of suggestion for you when you present the data analyzed. No, you just indicate what analysis you have made, either DMR, T, or whatever it is. Here only ABCD is given, so we are not in a position to appreciate whether it is CD value is also not given. That is number 1. Number 2, what prompted you to go only for methanol? Why not any non-polar compound?
Because methanol, this is initial testing, so methanol dissolves much more extracts from the plant than any other solvent. If you are going for ethanol, it is extracting less. So
no, I am talking about methanol is a polar compound, polar solvent. You would have used a non-polar as well, so that all the material in the non-polar also might have come to a solution. So don't use Trichoderma viridi, it is Trichoderma aspergillum. Thank you. So I think 11 is ready. Yeah, I think Bhavana is ready, no? Santomanas. Am I correct? She can present, no?
Yes, sir. Good evening, everyone. I am Bhavna M. Nair, MSc student, Department of Plant Pathology, College of Agriculture, Vellanikara. Today I am here to present on the topic anti-quorum sensing activity of medicinal plants against Xanthomonas oryzae, Pathovar oryzae causing bacterial blight in rice. Among the various pests and diseases inflicting the rice crop, bacterial blight of rice caused by zoopathogen is one of the most limiting factor in rice production. Conventional management practices, including chemical bactericides and planting disease-resistant rice varieties, are very less effective due to their concerns in environment. This emphasizes the need for a more sustainable disease management alternative. Quorum sensing or bacterial cell-to-cell communication is a mechanism which is used by bacteria to increase their virulence and pathogenicity. Medicinal plants from the previous studies have represented a rich reservoir of bioactive phytoconstituents capable of disrupting the quorum sensing mediated virulence factors of the zoopathogen. So, this study was investigated the anti-quorum sensing potential of selected medicinal plants against zoopathogen. The objective of research was evaluation of anti-quorum sensing effect of different medicinal plants against quorum sensing mediated virulence factors of zoopathogen. Coming to the materials and methods, firstly, the leaves of 15 medicinal plants, including Lawsonia enormis, Acorus calamus, Alobabadensis, Ocimum basilicum, etc., were collected and were subjected to rotary evaporation, and the crude methanolic extract thus obtained was then dissolved in 1% DMSO and was stored at 4 degrees Celsius for further studies. After that, the preliminary screening was done against Chromobacterium violacum, which is a biosensor strain, using the spread plate and agave diffusion assay. The antibacterial activity of the selected medicinal plants from the preliminary screening was then done against the zoopathogen using the spread plate and agave diffusion assay itself. After this, the anti-quorum sensing potential of the plant extract on virulence factors of zoopathogen such as the swarming, swimming and twitching motilities as well as the EPS production and biofilm formation was assessed. The EPS quantification was assessed using phenol sulfuric acid method and biofilm quantification was done using microtiter plate assay with crystal violet staining. At last, the qualitative estimation of bioactive phytoconstituents of the most promising plant extract was done using this QTOF LCMS analysis available at SAFE IIT Mumbai. Coming to the results and discussion, the preliminary anti-quorum sensing screening revealed that among the 15 plant extracts, only 6 extracts showed anti-quorum sensing effect against the Chromobacterium violacum biosensor strain by suppressing its violacin pigment production. Among them, Lawsonia enormis exhibited the highest inhibition zone of 1.2 with an inhibition percentage of 58.33. This was followed by Acorus calamus, which showed a moderate anti-quorum sensing activity with an inhibition zone of 0.9 cm. The antibacterial activity against zoo and the determination of MIC revealed that among the 6 extracts, only 4 extracts showed antibacterial activity against zoo pathogen, and among them Acorus calamus recorded the least MIC at 1% with highest inhibition zone of 0.83 cm, which was followed by Lawsonia enormis, which showed MIC at 3% with an inhibition zone of 0.8 cm. And after this, this was followed by Ocimum basilicum and Alobabadensis, which showed inhibition minimum inhibitor concentration of 5%. The anti-quorum sensing effect on the virulence factors of zoo showed that Acorus calamus exhibited the maximum inhibition of swarming, swimming as well as twitching motilities, and also the EPS production and biofilm formation. This was followed by Lawsonia enormis. This is the picture representing the inhibition of swarming, swimming as well as twitching motility of the treatments Acorus calamus and Lawsonia enormis after 24 and 48 hours of incubation. This table represents shows that the swarm diameter, swim diameter as well as twitch diameter in centimeter was least in case of the treatment Acorus calamus, which indicated the highest percentage inhibition after 24 and 48 hours. The quantification of exopolysaccharides was done using phenol sulfuric acid method, and from the picture it's clear that Acorus calamus showed the least red color compared to the control with a corresponding percent inhibition of 66.67%. Quantitative estimation of biofilm formation was done using microtiter plate method with crystal violet staining. From the picture, it's visible that the wells which are least stained with crystal violet represented the most powerful extract, that is Acorus calamus, with an inhibition percentage of 71.73. The most active plant extract, that is Acorus calamus, was then subjected to LC-MS analysis available at IIT Mumbai, and it was revealed that it contained several flavonoids and phenolic compounds such as rutin, camphorol, quercetin, isoferric acid, and 9-HOTE as the major quorum sensing inhibitory compounds from which was already given in the previous studies. So the salient findings from the study was that among the 15 medicinal plant extract green, Acorus calamus and Lawsonia inermis showed strong antiquorum sensing activity against both the biosensor strain Chromobacterium violacum as well as the test pathogen Xanthomonas oryzae, Pathovar oryzae, and among that Lawsonia inermis exhibited highest inhibition of violacin pigment in the preliminary screening, while Acorus calamus showed the lowest MIC, strongest antiquorum sensing activity at lowest MIC of 1% by inhibiting motility, EPS production and biofilm formation. The LC-MS analysis revealed that the antiquorum sensing activity was due to several flavonoids and phenolic compounds present in the plant extract. Thus, let me conclude my presentation by saying that methanolic extracts of medicinal plants exhibited antiquorum sensing activity against zoo, with Acorus calamus emerging as the most promising plant extract. Thank you.
Again, reiterate the same question to you. Why methanol alone? Why not any non-polar solvent?
Sir, in the previous studies, which was conducted earlier, there was a record that the maximum compounds were obtained when it was treated with methanol, when the methanolic extract was
taken. So whether any attempt was made with non-polar solvent like chloroform or dimethyl chloromethane or something like that?
Sir, hexane was used in some studies.
Yeah. So that was not that productive for you?
No, sir.
Okay, then again, as I repeated, the analysis, no, just mention what is the analysis you made before you spell out A, B, C, D and all. So that is also very equally important when you say. So can you pinpoint a couple of biomolecules responsible for this action in your Lawsonia as well as in Acorus calamus? Any one or two biomolecules responsible for this kind of action, or?
Sir, several phenolics and flavonoids compounds.
Anything which you found in the LC-MS with the highest peak?
Sir, rutin and quercetin. Quercetin actually it was shown by Acorus calamus as well as Lawsonia inermis. In both there was a presence of quercetin compound.
So you can spell out that it is quercetin which is responsible for this action? No.
Sir, it is a combined action of many flavonoids and phenolic compounds.
Any questions from the audience, please? Otherwise, thank you, ma'am. Thank you.
Thank you, sir.
Next is an online presentation, T1 OP18, Sherin Beulah.
Number?
T1 OP18.
OP18. So we are going backwards. Okay.
Sherin, you can share your slides.
Am I audible?
$18 is something else, no?
Sharing.
No, sir. Last one.
Am I audible? Is my screen visible?
No, your screen is not visible. Sherin, can you share it once again?
Is it visible now?
Yeah. You may start the presentation now.
Good evening, everyone. I am Sherin Beulah RJ from the Department of Nematology, College of Agriculture, Vellani. Today I am going to present my research work entitled Assessment of Avoidable Yield Loss and Integrated Management of Merodogen Fusarium Disease Complex in Black Pepper. Black pepper is known as the king of spices and is one of the most important spice crops cultivated in India. However, its production is seriously affected by many diseases and pests. Among them, the Malabar fusarium disease complex is one of the major problems. In this disease complex, root knot nematode damages the roots and create wounds. This wounds helps the fusarium fungus to enter the plant easily and cause disease, leading to severe plant decline and yield reduction. This disease complex causes serious economic loss to farmers and therefore effective management practices are necessary. The objectives of my study were to estimate the avoidable yield loss caused by Malabar fusarium disease complex in black pepper and to develop effective management strategy against this disease complex. To estimate the avoidable yield loss, a field infected with Malabar fusarium disease complex was selected, which showed the symptoms like yellowing, slow wilting, leaf curling and drying and shedding of immature berries, drying of veins, vascular discoloration, formation of root galls and necrotic lesions. And moving on to the identification of Malabar incognita, here we can see the egg mass of M. incognita, single egg, single second stage juvenile of M. incognita as well as adult female of M. incognita and the perennial pattern of M. incognita. And moving on to the identification of Fusarium solani, the microconidia, macroconidia and chlamydospores of Fusarium is seen. Moving on to the materials and methods, the experiment was conducted using the black pepper variety Pannur 1, which is the most susceptible one. The treatments used were T1 fluopyram 400 SC, T2 carbofuran 3% Cg, T3 carbendazim, T4 the combination of fluopyram, carbofuran plus carbendazim, and treatment number 5 is untreated control. Moving on to the results of this experiment, the results showed significant difference among the treatments. Among all the treatments, treatment number 4, that is the combination of carbofuran with the carbendazim recorded the best performance. It showed lowest nematode population in the 200 cc soil in 5 grams root and the number of adult females in 5 gram root, as well as the disease incidence is only 12%. This indicates that the combined application of nematicide and fungicide effectively managed both the nematode and fungal pathogen together. This was followed by the treatment number 2, that is carbofuran alone. And this is the pictorial representation of percentage reduction over control. Here, treatment number 4 recorded 82.52% reduction in the final nematode population and 90.94% reduction in the nematodes in 5 gram root and 93.47% reduction in the adult female. This clearly shows the effectiveness of integrated chemical management, and this was followed by the treatment number 2. Moving on to the yield loss assessment, it showed that the treated plants produced much higher yield compared to the untreated plants. The treated plants recorded a mean yield of 2.37 kg per plant, whereas the untreated plants recorded only 1.03 kg per plant. The avoidable yield loss due to the disease complex was around 56.36%. This result clearly indicates that the Malabar fusarium disease complex caused severe economic loss in black pepper cultivation. Further, another experiment was conducted on management of Malabar fusarium disease complex in black pepper under microplot condition. The treatments include the treatment number 1 is talc-based formulation of Pochone chlamydospore TNAU PC2 plus trichoderma aspergillum KUT6 2 application, and treatment number 2 is the talc-based formulation of Purpurecella lilacinum TNAU PL1 plus trichoderma aspergillum. Treatment number 3 is oil-based formulation of Pochone chlamydospore plus trichoderma aspergillum. Treatment number 4 is oil-based formulation of Purpurecella lilacinum plus trichoderma aspergillum. Treatment number 5 is growing marigold around the basin plus neem cake. Treatment number 6 is carbofuran 3% Cg. Treatment number 7 is carbendazim. And treatment number 8 is combination of carbofuran plus carbendazim. And treatment number 9, untreated control. Here the nematodes were inoculated first, and the fusarium multiplied in sand maize media is inoculated after 2 weeks. The oil-based formulation of bioagent were mixed along with the jaggery powder and then inoculated to the rhizosphere of black pepper plants. Also, the talc-based formulation of bioagents were incubated in farmyard manure under shade for 2 weeks and then inoculated to the rhizosphere of black pepper. Moving on to the results, among all the treatments, treatment number 8, which is the combination of nematicide and fungicide, carbofuran plus carbendazim, showed the maximum reduction in nematode population. But while comparing the bioagents treated, treatment number 4, which consists of the oil-based formulation of Purpurecella lilacinum plus trichoderma aspergillum, performed best. It reduced the nematode population characters as well as the root galling, and this was followed by the talc-based treatment number 2, that is the talc-based formulation of Purpuracilla lailacinum plus Trichoderma aspergillum. And comparing all the treatments, the best treatment is treatment number 8, that is the combination of nematicide plus fungicide, that is carbofuran and carbendazim. Moving on to the plant growth parameters, here also the treatment number 4, that is the oil-based formulation of Purpuracilla lailacinum and Trichoderma aspergillum, significantly improved the plant growth parameters like shoot weight, root weight, number of leaves and plant height, and this was followed by the treatment number 2. Moving on to the graphical representation of percentage decrease over control, treatment number 8, that is the chemical treatment, combination of chemical treatment showed the highest decrease over control, and this was followed by treatment number 4, that is the oil-based formulation of Purpuracilla lailacinum plus Trichoderma aspergillum, and then it is followed by treatment number 2. Similarly, in the plant growth parameters, the oil-based formulation of Purpuracilla lailacinum plus Trichoderma aspergillum showed the highest increase when compared to the control, and this was followed by treatment number 2. Moving on to the conclusion, treatment number 8, which is the combination of carbofuran 3% Cg plus carbendazim, effectively reduces the nematode population and disease incidence. Among the bioagents treated, Purpuracilla lailacinum combined with the Trichoderma aspergillum showed excellent potential in disease management and plant growth promotion. Bioagent-based management can be considered as a sustainable and eco-friendly approach for the black pepper cultivation. Future prospects are development of integrated nematode management strategies, exploration of new bioagents, improvement of bioagent formulations for farmer use, understanding molecular mechanisms involved in plant protection. Thank you all for your patient listening. I would like to express my sincere gratitude to Kerala Agriculture University, my guide, and everyone else who supported me in my research work. Thank you.
Shirin Julam, why do you use this carbofuran?
Sir?
Why do you use carbofuran?
Carbofuran is a nematicide that can be effectively used for controlling root knot nematode. If we control root knot nematode, means Physidium can be also controlled, and the disease complex can be controlled as well.
This is banned in Kerala.
Sir, come again.
This is banned in Kerala.
No, carbofuran 3% Cg is available now. Yes, sir. It is a granulated formulation. It is a granulated formulation, sir. It is currently available in Kerala. Only carbofuran 3% Cg is now available.
I don't know this particular formulation, but to my knowledge.
What about
yes, sir, carbofuran is banned in Kerala, but this particular formulation, carbofuran 3% Cg, that is a granulated form with 3% active ingredient. This is currently in use. This is not banned. It is available in the market.
Carbofuran 3G is the only thing available. I do not know what about the other thing we are talking about. Anyhow, if carbofuran, you should have kept an alternative like Vellum Prime or something, no? In this, just for curiosity, because carbofuran is already in the hit list. So it is high time to think about that. That's what the chairman was also mentioning. So that is number one. Why Chlamydosporium, Puchonia Chlamydosporium is not working?
Yes, sir. Chlamydosporium is also effective, but compared to Puchonia Chlamydosporium, Purpuracillum has highest effective, and it is this resulted in more reduction in nematode population compared to Puchonia Chlamydosporium. There is results in Puchonia also, but compared to that, Purpuracillum has a better action.
Okay. Any questions? Yeah. One last question, please. Avoidable yield loss. Can you explain more on the word avoidable yield loss?
So this avoidable yield loss, in this, with proper management practices, we can avoid this percentage of yield loss. Like if we use if we use this management practices, this percentage yield loss can be prevented. If no management is there, means we will be losing this percentage of yield.
Okay, thank you. So
thank you, sir.
Next presentation.
Next is T1 OP17, Akila Vijay.
Akila Vijay. OP17, sir. Online? Offline, okay.
Good evening all, respected dignitaries and my dear friends. I am here to present on my topic, plant protection in paddy using endophytic endomopathogenic fungus, Lecanicillium saxinae. As we all know, rice is a staple food for half of the population of the world, and now rice production is threatened by so many biotic and abiotic stresses. And the conventional pest management system has relied mainly on the synthetic chemical insecticides which have their own negative impact. So plant protection in rice is increasingly shifted towards eco-friendly biological approach using beneficial microorganisms. Lecanicillium saxinae is such an endophytic endomopathogenic fungus which can colonize plant and enhance defense response against pest and disease. Here, we are using seed priming as an effective delivery strategy for establishing this fungus in the rice plants. The objective of my research is to evaluate the potential of endophytic endomopathogenic fungus, Lecanicillium saxinae, in improving pest and disease tolerance in paddy through seed priming. So, first of all, we have done a lab study for fixing the dose for seed priming. First, the seeds were pre-soaked in sterile water, and the seeds were covered with muslin cloth for initiating germination, and these pre-germinated seeds were used for treatment. And the different treatments include different doses of L-saxinase for suspension and talc formulation at 25, 50 and 100 gram per kg seed, which is compared with Pseudomonas fluorescens and an untreated control. And the observations taken were germination percentage and seedling vigor index. Here you can see that the first two treatment, which is L-saxinase for suspension and talc formulation at 25 gram per kg seed, showed increased amount of shoot length, root length, and as a result, there is an increase in seedling vigor index when compared to all other treatment. And this here you can see the increase in shoot length and root length of L-saxinate treated plants when compared to the control, and which resulted in about 25 to 26% increase in seedling vigor index. And these two treatments were taken over to a pot culture study on plant defense induction by L-saxinae against rice bug infestation. Here plants at the milky stage were used for the study, and the headspace of the potted plants were covered with polypropylene cover, and 5 adult rice bugs were released. And here the catalase activity, peroxidate activity, silicon content and phenol content were measured. And the result shows that here the catalase activity is more in L-saxinate treated plants, that is L-saxinase for suspension and talc formulation, when compared to untreated control, even before the release of the rice bug, which means the endophyte have preconditioned the plant even before the release of the pest. And here also the peroxidase activity also followed the same trend, which means we can see that increased amount of peroxidase activity at 24, 48, 72 and 96 hours after release. And also in the pre-release also we can see improved amount of peroxidase activity. Silicon and phenol content also followed the same trend, which means we can see increased amount of silicon and phenol content in L-saxinate treated plants. So these treatments were done in a field experiment, and here different treatments like seed priming alone for L-saxinase for suspension and talc formulation was done, and also the seed priming was followed by foliar spray of L-saxinase for suspension and talc formulation at 80 days after planting, which is the milky stage. And this was compared with the Pseudomonas fluorescens, and the foliar spray lambda cyhalothrin act as the chemical control, and also an untreated control were followed. Then the observation taken were major pests and diseases. And here you can see the population of rice bug. Here the T3, which means seed priming with L-saxinase for suspension and followed by the foliar spray of L-saxinase for suspension at 80 days after planting, performed well, which reduced, significantly reduces the infestation of the rice bug, which was comparable with the lambda cyhalothrin, that is the chemical treatment. And also T4, which is seed priming with L-saxinate talc formulation followed by its foliar spray, also performed well. Next is the stem borer damage. This was recorded at 35, 50 and 90 days after planting. Here also you can see that the seed priming with L-succinase post-suspension and talc formulation reduced stem borer damage at both the vegetative and the reproductive stage. And also here you can see that the foliar spray do not have any profound effect in reducing the stem borer damage. This was also followed in the leaf roller damage also. We can see reduced amount of leaf rollers in L-succinase treated plants when compared to Pseudomonas fluorescens and the control. And also major pest diseases like bacterial leaf blight and the sheet blight were recorded. Here also we can see the two treatment, which is L-succinase post-suspension and talc formulation biopriming, reduced the sheet blight, and also here the foliar spray have no profound effect when compared to Pseudomonas fluorescens. So my salient findings are application of L-succinate through seed priming improved the seedling vigor index at 20 to 26%, and also it resulted in increased amount of antioxidants enzyme like catalase, peroxidase, and also defense related compounds like silicon and phenol. And also the seed treatment of L-succinate along with the foliar application at milky stage resulted in reduction in rice bug infestation 60 to 72%, and also the talc formulation also performed well, which resulted in 56 to 68% of reduction in rice bug. This also resulted in 24 to 64% reduction in stem borer and 20 to 36% reduction in leaf roller. We have also recorded a reduction in bacterial leaf blight and sheath blight. It is 12 to 40 and 21 to 40% respectively. So I conclude that the study demonstrated the endophytic entomopathogenic fungus like Ancilium saxinae can effectively enhance the plant protection in paddy by improving tolerance against major insect pest and disease, and also delivery of the fungus through seed priming and foliar application activated plant defense mechanism and reduced pest and disease incidents under the field condition. And the future directions include exploration of L-succinate as a broad spectrum biological plant protection agent in vegetables and also other crops under the field condition. Thank you.
Did you estimate the yield?
Yes, sir. I have
It
also.
was not given here.
Actually, I have done the plant growth promotion portion also. This is a small portion of my work. In that, I have also recorded and improved shoot length, root length, and also tillers.
The ultimate objective of a farmer is
Yes,
to
the
increase the
yielding.
yield.
Yes, sir.
But in your work, you have not given any indication whether the treatment is increasing the yield or not.
Actually, it is increasing yield by 20%. I just
20%?
Yeah, 20% increase is there. Along with that is we are doing seed priming along with the foliar application. We have recorded a 20% reduction in the chaffy grains and also an increase in the yield.
20% means it's a substantial increase.
Yes, sir. Actually, we have doing different research in different crops based on L-succinate throughout our AACRP work, and in there also we have recorded a significant increase in the yields. Sir.
So it is increasing, reducing the, say, rice bug. It is in reducing the BLB.
Actually, this is for rice bug. This can be used as a control measure, sir. But for BLB and also other disease, it is not acting directly. Actually, it is improving the growth of the plant and growth and defense of the plant so that the BLB recorded will be low, and it can't be used as a single measure to control BLB. But there is a reduction in BLB. But for rice bug, we can use this as a measure for controlling rice bug. There is a significant reduction in the rice bug control, sir.
So you have not used nano formulation in your study?
No, sir. I didn't.
So this is exclusively a different part, isn't it?
Yes, I just used the spore suspension.
Whether
and
this Acanicilium saxinae is registered under
no, sir.
CABRC?
No, sir.
It's only the data you have generated.
Actually, we are in the next step.
As pointed out by the chairman, if you give us seed priming, it eliminates or reduces infestation by earbug, which comes in the later phase of the crop, right? Final stages of the crop. Still, it is there. You feel that the endophytic association is very stable.
Endophytic association?
is quite stable. It is reaching till the chaff production, the grain production.
Actually, to about 45 to 50 days, my seniors have also done some works,
Okay.
and in that about 45 to 50 days there is a significant endophytic association with the plant. So during the milking stage we have given an additional
The yield
foliar.
enhancement to 20% is quite big, so you have to be very careful in saying that data. One final question, it's a basic thing which I wanted to know from you. How will you quantify an enzyme? You have done 4 enzymes here. How will you quantify?
Actually here I have done
Just similar, just generally you say.
in catalase and all I have done the spectrophotometry.
And how will you quantify? Just like in kilogram or gram or what is that?
It's unit per milligram per gram fresh weight of the leaf tissue, sir.
So it is, you are either measuring the product form or what is that? Or the substrate disintegrated?
For catalase and all, the disintegrated amount of hydrogen peroxide that we have recording in the spectrophotometry.
Okay, thank you.
How do you say, what can the possible mode of action of this organism against rice bug? Possible.
Actually, like Penicillium succinate is an endophyte, so it can go inside the plant body, and here it is regulating the ISR, that is induced systemic resistance of the plant. So that is, it is there, it is increasing the immune systems of the plants. And in case of rice bug, for rice,
Only worried about the rice bug.
for rice bug, it is acting like it is go inside the rice bug body, then it will multiply and it will entangle with its fungal.
Did you notice that?
Yeah, yes sir.
There's a growth of...
There is a growth from rice bug, yes sir.
Oh, that's fine.
Actually, this was isolated from the cropped soils of Vellaini, ma'am. This is
It is not isolated from the plant. It was
no,
isolated
it's
from
isolated
soil.
from soil, Vellaini soil, ma'am.
And how did you prove that it is growing endophytically in rice?
Actually, we have done so many works and it is proved that it is an endophyte. It can grow inside the
My
plant.
question is how it was proved.
Actually, it is inoculated to the plant. In the previous study, it have done in cowpea and rice. For cowpea, they have done all the possible ways, that is seedling dip, then seed soaking, then foliar application, and like that.
Yeah. Final, one more question, please. Can discuss later. See, the question very simple. Endomopathogenic fungus, how it becomes an endophyte? That's the question. You answer it to her separately. Please, you carry on.
My question is, you have mentioned about the catalase and peroxidases, which are actually functional proteins, which works downstream of some signaling pathways or something. So how they are expected to, they are actually connected to the general defense response of a plant. So how they are expected to give a tolerance to a plant against stem borer or a hopper?
Actually, for catalase, it is working inside the plant body. It can degrade the oxygen radicals which are produced during a stress, ma'am.
Yeah, but how it is giving a resistance to the insects?
It is improving the immune system of the plant so that the effect of the...
Thank you. Okay, I think we have spent a lot of time on the discussion. We can discuss during the tea time, please. Good.
Next is T1 OP21, Arun Prakash.
21, huh?
T1 OP21.
Offline. Cry for help.
Good evening, one and all present here. I am Arun Prakash, PhD scholar from Tamil Nadu Agriculture University, Coimbatore. And today I am going to present on the topic Cry for Help, the rhizosphere metabolic shifting and beneficial recruitment in foliar diseases infected glory lily. First of all, as we know, the glory lily is one of the important medicinal crop which yields the gliriosin and colchicine, which are the alkaloids which are used for the cancer and gout treatment. And the glory lily yield is very much reduced by the foliar diseases caused by Carularia, alternaria and coletoricum, and these diseases not only and these diseases not only reduce the yield, not only reduce the photosynthetic area of the leaf, but also it directly infect the flower buds and parts of the glory lily, and it directly reduce the seed yield. And the concept here is the cry for help. The cry for help means when the plant gets stressed, is release some of the metabolite in the root exudate, and the root exudate is helping for the recruitment of the beneficial bacteria, beneficial microbes in the rhizosphere, and by the way it overcomes the stress. In our case, the foliar disease is the pressure here, and due to this foliar disease, the root exudate shift is occurred, and it leads to the microbial recruitment in the rhizosphere. By the microbial recruitment, we can prevent the disease, and it also enhance the crop growth and resilience. And here the question is whether this foliar disease infected glory lily shows a coordinated shift of that metabolic shifting, and it coordinated with that microbes in the rhizosphere. For that, we frame this objective. First, we have to profile what are all the metabolite in the rhizosphere of the healthy and diseased rhizosphere in the field condition. And the second objective is what are all the microbes are associated in the same healthy and diseased condition. And finally, by integrating these two omics, metabolomics and metagenomics, we can frame the interpretation for the cry for help mechanism. For that, we assume that null hypothesis as there is no significant correlation between these metabolic shifting and the microbe association, microbe recruitment. And the working hypothesis is there is a significant correlation between that metabolic shifting and the beneficial recruitment. Here, for that, the experiment start with the soil sampling from 4 villages with the 2 condition, apparently healthy and disease condition with the 3 replication, totally 24 sample, 12 for healthy and 12 for the diseased. And the GCMS profiling, after that 16S rRNA profiling for the by metagenomic analysis, and matching these 2 analyses with the respective condition, we interpret for the cry for help mechanism, and this is the sample structure, and these are the method. We isolated the soil from the rhizosphere region, and after that the GCMS metabolomics PCA score plot, we can it depicts that we can see the clear separation of the diseased group from the healthy one, and it is consistent with the all over the sample of diseased disease. And the targeted metabolite are consistently present in the disease sample, and also it deviate from the healthy one. And here in the heat map, you can see that the healthy group is mostly consisted of the amino acid, but the diseased one are highly associated with the organic acid. You can see in the bar chart also, there is a highest expression of the organic acid in the root exudates of the diseased sample, and in the Venn diagram there is a 90 after matrix screening, the 96 metabolite or in the combining of healthy and diseased rhizosphere metabolite. In that 80 are shared in both of the condition, but there is a 13 compound are unique to disease and 3 compounds are unique to the healthy condition. And these are the top contributing metabolite to the PC1 and PC2. Here you can see that the anthranilic acid, 12-bromodecanoic acid, dodecanoic acid, and docosahexanoic acid, methyl erutate are highly contributed to the disease association, and the palmitoic acid are negatively leading to the disease association in the PC2. And these are the top ranked metabolite for the cry for help mechanism in disease association: the anthranilic acid, 2-palmityl glycerol, methyl arotate, 12-bromo-dodecanoic acid, docosahexaenoic acid, oleic acid, palmitoic acid. These are all the fatty acid. When compared to healthy, there is amino acid, but when it gets diseased, there is a shift in from amino acid to fatty acid. This is help for the microbial recruitment in the rhizosphere. And after that, for the second objective, we done that 16S rRNA microbiome profiling. In that, you can see that PGPR recruitment index are higher in case of disease when compared to the healthy one, and also the Bacillus pseudomonas recruitment abundance are high in the diseased condition when compared to healthy. And in the heat map also you can see the highest expression of the highest presence of the Bacillus and Pseudomonas in the diseased condition when compared to the healthy one. It suggests that the metabolomic shifting directly leads to the enrichment of the beneficial microbiome in the condition. It confirms the cry for help mechanism. And these are the saline findings from our study. We confirm the metabolic reprogramming. It leads to the microbiome restructuring, which is mostly of the beneficial microbiome. And these combining these omics approaches, we can confirm that the enrichment which leads to the which help in the cry for help, which overcome the disease or stress. It can be used for the either next generation in bioinoculant and disease supportive strategies. And by that I conclude that foliar disease infected glomeruli appears to reshape the rhizosphere chemical environment that will enrich the beneficial bacterial partner in the rhizosphere. And these are the next steps to be validated under control condition. And thank you.
Two extensive work you have made. One is on the metabolome, another is on the metagenomics.
Yes.
Right? So, from the metagenomics, you say a solution for the metabolome profile, you can very clearly spell out?
Sir?
Can you very clearly spell out from the metagenomics?
Sir, bacterial metagenomics. We can see.
Okay. So, some bacterial support can be given to the diseased plants, right?
Yes.
So, anything very specific bacterium you could get, that's what I'm asking.
Bacillus and Pseudomonas, sir.
Okay. So, these are the two bacterium which is responsible for this?
Yes, sir. Highly responsible, sir.
Okay. So,
their abundance are high in that soil, sir.
So, both these works are outsourced. Am I correct?
Maybe, sir. Yes, sir. Maybe.
No, I'm just asking you whether both these works are given to some private firms to get it done, or it has been done in your laboratory?
Metabolomics are done by myself, sir, and metagenomics are outsourced.
In TNAU?
No, sir, in nearby that laboratory called Syngenome, sir.
Okay. Any questions?
Just one doubt. Is the slide based on AA?
No, sir.
No.
That's a new generation thing, sir. Some support they get from the AA also. Okay. Anyway, if there are no questions, thank you so much, Mr. Is there any more?
Next is 23, Anushree.
23, yeah?
T1 OP 23. Anushree.
Good evening, everyone. Myself, Anushree K. I am from Department of Plant Pathology, College of Agriculture, PADANNAKKAD. Today, in this seminar, I would like to present a part of my research work. The title of my oral presentation is In Vitro Evaluation of Fungicides and Bioagents Against Stem or Tuber rot of Tuberose Caused by Sclerotium nolsei sac. Tuberose is a bulbous ornamental plant and it is highly valued for its attractive as well as fragrant flowers. Sclerotium rosei sac, it is the most important notorious soil-borne pathogen affecting this crop. That it causes the disease named as stem or tuber rot, and the disease results in severe yield reduction. And this study mainly aimed to identify the most promising fungicide as well as bioagent against this pathogen under in vitro conditions. Here I evaluated different systemic fungicides at different concentration like 250, 500 and 1000 ppm. Also non-systemic fungicides at 1000, 1500 and 2000 ppm. Also ready-mix fungicides at 500, 1000 and 1500 ppm under in vitro condition using poison food technique, and the experimental design used was CRD, and there was 3 repetitions for each treatment. And also I evaluated different bioagents under in vitro condition, and there was 5 different bioagents, and it also evaluated by using experimental design CRD, and there was 4 repetition for each treatment. And from the study, I found that among systemic fungicides, propiconazole 25 EC at all the tested concentration, that is 250, 500 and 1000 ppm, exhibited 10% mycelial growth inhibition of the pathogen, and all 3 were significantly higher than the remaining treatment. Among non-systemic fungicides, mancozeb 75 WP at 2000 ppm exhibited 10% mycelial growth inhibition of the pathogen, and none of the treatment was at par with it. Among ready-mix fungicides, tebuconazole plus trifloxystrobin, carboxin plus thiram, and carbendazim plus flucilazole at all the tested concentration, that is at 500, 1000 and 1500 ppm concentration. There was no mycelial growth of the pathogen in these concentrations. It shows the image of ready-mix fungicide evaluation under in vitro condition. And among bioagents, among the tested bioagents, the highest percent mycelial growth inhibition was observed with Trichoderma asperellum, that is 41.31%, as well as Trichoderma harzianum, that is 39.71%, and both treatments were statistically comparable. And from this study, I would like to conclude that different fungicides such as propiconazole and mancozeb, also ready-mix fungicides such as tebuconazole plus trifloxystrobin, carboxin plus thiram, as well as carbendazim plus flucilazole, also biogens such as Trichoderma asperellum and Trichoderma harzianum can be used to manage the pathogen. And also in future, these promising fungicides and biogens must be evaluated under greenhouse as well as field conditions, and there is a need of development of integrated disease management strategies by using these fungicides and biogens, and there is a need of evaluation of compatibility between these effective fungicides and biogens. Thank you.
Using bioassay for systemic fungicide, is it effective? Think about it. You may get results, but how is the method of action of systemic fungicides?
So systemic fungicides, after application to the plant, it will enter into the plant, and through xylem, mainly xylem, it will translocate to entire part of the plant.
Yes. Then, for example, in the phosphatal, what is the mode of action of phosphatal?
So phosphatal aluminum is mainly for Oomycetes class, and it act by causing natural defense mechanism, I think.
So natural defense mechanism. Again, if you are using it in a PD, how is it going to inhibit? There is no plan there. Then, similarly, the same thing, usually there are several reports saying that using this bioassay method for systemic fungicides is not very effective. Sit down.
So why do you want to thank Malabar Plant Protection Society as an acknowledgement? Just.
So because for providing an opportunity like this to present.
Oh, great, great. Thank you, ma'am.
Next is an online presentation. T1 OP24, Prashant Patidar. T1 OP24.
Am I audible, sir?
Yeah, you are audible.
Hello. Okay. A very good evening, one and all. I am Prashant Patidar from Division of Plant Pathology, IRI, New Delhi. And the topic of my oral presentation is Genomic Insights and Evolutionary Analysis of the Novel Lytic Phage RBS24, a potential candidate for Ralstonia biocontrol. Next. As we know that bacterial wilt of solanaceous crops is a devastating disease worldwide, especially in tropical and subtropical regions of the world. There is no effective or lasting control measure currently available, especially there is no durable resistant variety available. And we are over-relied on antibiotics. That comes with the concern of antimicrobial resistance in these biosis. Hence, we must look for an eco-friendly alternative, such as phage therapy, that is using phages, bacteriophages, for the treatment of bacterial infections. So the objectives of my research are to isolate bacteriophages against Ralstonia pseudosolanacearum from natural ecosystems, to understand the lifestyle of isolated bacteriophages through whole genome sequencing, and to evaluate the biocontrol potential of isolated bacteriophage. Next. The isolation of the bacteriophage RBS24 was done from a river, Banas River, which is flowing through Sanjay Dugri Tiger Reserve in Madhya Pradesh. And the purification was done through double agar overlay assay, and after 3 rounds of purification, the bacteriophage were stored in SM buffer. The DNA was isolated using phenol chloroform method, and the whole genome sequencing was done by myself by Oxford Nanopore Technology, available in Division of Plant in Discovery Center, IRI, New Delhi. Coming to the bioinformatic analysis, the phage scope and phage AI was used for structural and functional annotation as well as lifestyle prediction. Victor was used for whole genome based phylogeny. Mega 12 was used for single conserved gene based phylogeny, and Viridic was used for intergenomic distance calculation. Next, please. These are the results. This is the whole genome of the RBS24 phage. The genome spans around 39 kb. And the complete genome sequence revealed RBS24 is a strictly lytic phage, as there was no integrase, no antibiotic resistance, and no virulence genes was detected. There were several genes related to lysis function, including endolysin and choline proteins. Next, please. Phylogenomic and phylogenetic analysis was conducted using Victor software, and RBS24 was placed along with RPY2 in the genus Sarcovirus, and the phylogenetic analysis using 3 conserved genes such as major capsid protein, large terminus subunit, and DNA polymerase 1 revealed that RBS24 formed a well-supported monophyletic cluster with established Sarcovirus member, and hence these genes are highly conserved among the bacteriophages. Next one, sir. Intergenomic similarity analysis of RBS24 was done using Viridic software, and we came to know that RBS24 was not sharing more than 95% similarity with any of the reported bacteriophage. Hence, it is a novel species infecting Ralstonia phages. First strain test revealed that RBS24 was infecting 16 out of 20 strains we have tested in our laboratory. All these 20 strains are of Ralstonia pseudosolanacearum are isolated from different parts of the country, different endemic zones of Ralstonia, and they were isolated from tomato, brinjal, chili, potato, ginger, and cardamom. So it reveals that RBS24 is a polyvalent phage infecting many strains of Ralstonia from different parts of the country. Next, please. The salient findings of my research is the phage RBS24 is isolated from a natural ecosystem, a Banas river which is flowing through a Sanjay Dugri Tiger Reserve in Madhya Pradesh. Transmission electron microscopy revealed it is a typical photovirus with a short stubby tail. The complete genome sequence revealed that it is strictly a lytic phage with no integrase, antibiotic resistance, and virulence gene was detected, making it is a highly suitable biocontrol option for bacterial wilt disease. The phylogenomic and phylogenetic tree as well as intergenomic distance similarity calculator placed RBS24 in a Sarcovirus genera. It is a novel species. It does not match more than 95% with any recognized phage species. It is a polyvalent phage infecting 16 out of 20 strains we have tested in our laboratory. And this work represents the first comprehensive genome level characterization of phage infecting any plant pathogenic bacteria in India. Thank you. Thank you, sir.
Tiger Reserve and phage identification for the management of Ralstonia. Am I correct?
Yes, sir.
And I just want to know some of your phylogenetic trees and all, no, only some microscopic, support is needed to see it at least. So some of the phylogenetic trees can be a bit enlarged, is what I feel particularly. So what we can do with this phage right now?
Yes, sir. Can you repeat the question, sir, please?
Yeah, this you would have made a bit bigger. You know, what we can do with this phage right now?
So this phage is isolated from sir, this is the biocontrol option for bacterial wilt disease. We can inoculate this phage in the soil.
So it's
in soil to treat bacterial wilt.
You want to say that it's a viable biocontrol agent against Ralstonia?
Yes, sir. Yes, yes.
Is such a phage?
This is one of the phage we have, one of the several phages we have isolated against this pathogen.
Is there any practically anywhere these phages are used as a biocontrol agent against bacterial diseases?
Yes, sir. They are used against Xylella fastidiosa. They are used in Europe, sir, and America as well. Against Erwinia amyloura, they are used in America, sir. So and against Xanthomonas uvesicateria also they are used in America. But in India there is no report, no such reports.
So this is working this line. Okay. Any clarification, yes, on the audience, please?
So one thing.
Yeah, please. Sajesh.
Yeah. My question regarding the collection of that Ralstonia pseudosolanacearum, that is from water, I think. So what is the relevant?
Ralstonia pseudosolanacearum.
Phage. That's from Banas River.
Okay, sir. Yeah.
So
sir, this is one of the phage I have collected from several places. Okay. I have collected almost 20 phages till now. So this is one of the phage I am representing because its whole genome is characterized, and now we are going to use it soon for the biocontrol option. That's why I am representing this one here.
Okay. Right. Thank you.
How will you formulate this?
One more clarification.
Apply in the field. How will you?
Okay, ma'am. Till now we are like what we have planned till now is we are going to introduce it with SM buffer only. So it is cost effective. It's not taking much cost, and we can store the phages for at least 6 to 7 months in 4 degrees Celsius with SM buffer. That's why this is our formulation plan till now.
You are storing it at 4 degrees Celsius.
Yes, ma'am. 4 degrees Celsius in SM buffer.
So will it be cost effective storing this in 4 degrees Celsius and applying the field in larger?
Ma'am. For long duration, we can't store it at 4 degrees Celsius for 6 to 7 months, but surely we will further work on that, and we will try to figure out at what temperature we can store it for longer duration and what formulation, so that we can use it as soon as possible.
One more question: how will you multiply this?
We are multiplying it on Ralstonia only, ma'am. The host strains what we are having in our laboratory.
So again, the question is how it is cost effective. It will not be easy to multiply it on Ralstonia solanacearum.
Okay, I think he has identified a phage. That's what he is reporting, and I do not know the practical utility of that. That's exactly what we can say, right? Maybe it's what he has made it. Any more presentation on the?
We have completed.
Everything is over. Okay, thank you. So which means everything is over. I think I will now give to the chairman for his impressions, please.
Sir, there is poster presentations now.
Oh, yes. See, even though there were 23 presentations submitted for papers presented for submission. 24.
See here. See, there are only two. One is missing somewhere. There were 23 presentations given for presentation, out of which 16 were presented. Only 16 were presented. And most of the presentations are on somewhere related to biological control. And out of which one, interestingly, they about the last one, the use of bacteriophage. That is, I think this is the first time in India they are getting a bacteriophage biocontrol agents. But interestingly, I made a right of information to the government of India just to find out how many of the biocontrol agents are produced by the different research stations under the government of India. The right of information was given to ARA and almost all these things. And also the amount spent in interestingly, the result that we got was from 1980 onwards, even though there are several research work on biocontrol agents, only seven are approved for release. That is the result. No, worried because even after spending billions of rupees, I'm not saying millions, billions of rupees on biocontrol agents, they are not coming to the field, market. And there is a opposition from even not only biocontrol agents, for example, the non-microbial biocontrol agent, our Nanma Menma Shreya, it is a CTCRI. Even now they have not received approval from the government of India. So most of the biocontrol agents that we are using in the market didn't have any recognition. PGPR. Do we have any recognition for PGPR? PGPR 1 or 2, PGPR 1 and 2, produced by KAU or ICAR are different. What is the point in saying PGPR 1, PGPR 2? So that is one doubt which I want to raise, because I'm not sure about it, because I'm not well versed in this thing at present. So this biocontrol agent, we can do research, agreed. How to bring it to the market? None of these things are in the market. Only your trichoderma is there, pseudomonas is there, then a couple of another 6, total 7. That's the right to information act thing which I gave, and I got only that result. So that is it. But I think mainly because we conduct the research, and after the student is passed out of the MSc, there is no continuity. And another thing is the amount required to get the biocontrol agent approved. Again, the government of Kerala gave us 3 crores of rupees to get Nanma, Menma and Shreya released. So we apply for biocontrol agent certification from them. I will say you have to find out neem. So we did neem. Next they will say some other compound. Like that we applied from 7 or 8 times. At the end we said no. And we are marketing it. But what is the point in that? That is my worry about this. But the students many of the students have done good work on this biocontrol agent. But the only thing is the guides must take it forward. Otherwise there is no point in spending money on these things. So anything?
So thank you, sir. I think it was a very good learning experience for me as well. That is what I can say right now. We had different topics presented by the students here: entomology, pathology, nematology. I think there was nothing on the weeds. Otherwise, the presentation was absolutely holistic. And even the AI tools are very nicely used with the students. So that is what I can appreciate, the way in which the innovations have crept into the presentations as well. So some are even at the top level, they have gone at that level. But as rightly pointed out by our chairman, the exact biocontrol agents and its practical utility should also be reflected. All the cutting edge science have been presented. One thing is for sure, the presentation mode, style and the content has vastly improved, and I salute all my younger colleagues to come again in rising colors and see that you keep up the tempo and keep the spirit of science to the highest level. Thank you.
Only poster presentations, how many?
6.
6. Projection?
Yes.
Yes.
Nagajodi, you can share.
Hello, sir. Am I audible?
Yeah, you are audible.
Okay, sir. Very good evening to everybody. I am Anna Agajoti. I am from Indian Agricultural Research Institute, New Delhi, Division of Plant Pathology. I am here to present my work on exploring tomato phylloplant microbiome for sustainable management of bacterial leaf spot. As we all know that bacterial leaf spot of tomato is a major threat to tomato cultivation. Not only it is creating the yield losses, but also it is diminishing the fruit marketability. It is a centenary pathogen, and so many scientists, they try to manage this pathogen by using various methods. But an alternative solution is not found. So here is a phylosphere which harbors a diverse community of microorganisms which play a vital role in regulating both plant growth development and its health. So as a part of my research work, we have collected the samples from Himachal Pradesh, Solan, and we have chosen the distinct stages of the bacterial leaf spot symptoms. After that, we have brought these samples to the laboratory, and we have imprinted both on nutrient agar and minimal media. After that, we have gone through the serial dilutions, and we have isolated individual colonies on nutrient agar. The purified colonies will subjected to the DNA isolation, and the duplicates is removed with the help of the box PCR fingerprinting. After that, after the leaf imprinting, we have got 221 bacterial isolates on nutrient agar and 82 on M9 media. And to remove the duplicate isolates, we have performed box PCR. After box PCR fingerprinting, I have got 231 unique bacterial isolates. These 231 bacterial isolates are subjected to the 16S rRNA, and there I have found that the following genera: Pantera, Pseudomonas, Enterobacter, Stenotriphomonas, and this following genera I have found through the 16S rRNA. After this, I have to go through the evolution methods. Then we'll find the bacterial community which will help in managing the bacterial leaf spot of tomato. So here we are concluding that the phylloplant microbial communities will help in the development of microbiome-based sustainable strategy for managing bacterial leaf spot of tomato. And I want to thank ICR, IRI and DXT Inspire for providing fellowship, and MPPS for providing a platform for sharing my research work. Thank you.
So the bacterial leaf spot in tomato can be checked by a wide microbial community available, right?
Yes, sir.
So anything you can very specifically comment on that? Anything which can be practically exploited in coming days?
Sir, in this case, we didn't perform the evolution method, sir. I have to screen them, sir. Like bacillus and some Pseudomonas isolates may help in managing bacterial leaf spot.
Okay, thank you. Any questions from the audience? Yeah. Mike, please.
How many colonies did you get from single leaf?
Ma'am, here single leaf, I got many colonies, but out of that, I have to pick the distinct colonies. So from here, I imprinted both adaxial and abaxial. So for adaxial surface of the leaf is different and abaxial is different. And adaxial got more colonies compared to abaxial.
Nagajyoti, my question is, on an average, how many colonies did you get from a single leaf?
Single leaf, ma'am,
on an average,
I can get 10 to 15, ma'am.
10 to 15 colonies of bacteria?
Yes.
So you did not get any fungi?
Ma'am, my focus is on bacterial communities, ma'am, not fungal.
You used only specific medium for bacteria. You did not get any fungi. Thank you.
And here I have used M9 media, which is useful for slow growing bacteria.
You have a question?
Even as contamination, you did not get any fungus.
Ma'am, we will use the cyclohexamide before plating those dilutions.
Okay, I understood. Thank you.
They have used some specific fungicide so that the fungus are not coming out. Any more? Yeah, we can go for the next. PP.
Good evening, sir. Am I audible?
Lina Sinthu.
Good evening,
you are audible. Please go ahead.
Good evening, sir. My name is Lina Sinthu.
Leela Sindhu, you may present now. Leela Sindhu, is it audible? Leela Sindhu, you may present now. There is so much noise from your side.
We'll go for the next one.
Next presenter is Ria, T1 PP4.
Good evening all. I am Ria, MSc Plant Pathology student from College of Agriculture, PADANNAKKAD. We all know that cowpea is an important legume crop widely cultivated for its nutritional value. Web blight pathogen causing Rhizoctonia solani causing web blight causes severe infection on this cowpea. Increasing use of chemical fungicides have raised human, environmental and pathogen resistant issues. Softnut tree is a deciduous plant which is known for its fruit have high saponin content. Traditionally, it was used for its detergent purpose because of the foaming property. Recent study shows that in addition to the cleaning property, it also have an antifungal activity. The present study aimed at evaluating the antifungal activity of softnut-derived saponin against the web blight pathogen of cowpea. For the study, I have taken the disease samples and pathogen was isolated and characterization of pathogen was done. Saponin was extracted from the fruit pericarp using two different solvents such as aqueous extract and ethanol 50% and saponin was extracted. The resulted saponin content, the saponin was tested against Rhizoctonia solani using poison food technique. Coming to the results of the study, the collection of disease sample, I have collected the disease sample, pathogen was isolated, and pathogenicity was proved using coarse postulate. Through cultural, morphological, and molecular characterization, pathogen was identified as Rhizotonia solani. Saponin was extracted from the fruit pericarp using two different solvents such as aqueous and 50% ethanol. And we got an yield of aqueous extraction yielded a 25.16 gram of saponin-rich powder, and ethanol extraction yielded a much higher of 38.93 gram. The difference in the yield may due to the better solubilization of saponin content in the solvent. Once the saponin content was obtained, we have taken for its in vitro evaluation using poison food technique. From the pictorial representation, we can see comparing to control T16, all the saponin concentration showed a reduced radial mycelial growth. The concentration ranging from 0.1 to 3%. The inhibition also increases in a dose-dependent manner. From the graphical representation, we can see there is an increasing inhibition of mycelial growth as the concentration increases. 0.1% of saponin aqueous extract showed an inhibition of 37%. The highest concentration tested, 3%, showed an inhibition of 76.6% in case of saponin aqueous extract, and in case of saponin ethanol extract showed an inhibition ranging from 38 to 78.8%. From this we can see that also the chemical control carbendazim and mancozeb showed a maximum inhibition of 100%. Although they showed 100% inhibition, the plant-derived compounds like plant-derived saponin showed a promising inhibition comparing to the chemical control. From this we can say that saponin extracted from the soap net have antifungal activity and can be used for the sustainable management of web-blight disease of cowpea. Thank you.
You have used the entire soap nut or the pericarp alone?
Sir, pericarp alone I have to.
Used only the pericarp alone?
Yes, sir.
Not the nut?
Sir, saponin is both present in the pericarp as well as seed. I have taken from the pericarp. I have taken pericarp and it was ground and powdered and solvent, with the help of solvent extracted the saponin.
Any specific compound isolated from that, or is it known against the fungicidal action or something like that?
Sir, it was known for its antifungal activity. Like
any chemistry behind that?
Saponin have, by the application of, recent studies I have referred, it shows like by application of saponin, the resistant genes will be
any molecule, any bioactive principle available in soap net?
Sir, it will directly infect, directly attach to the fungal fungal cell membrane, especially ergosterol, and causing the disruption of the cell wall and causing the disrupting the integrity of the fungal cell wall and causing the death of causing the inhibition of the fungal pathogen.
I just wanted to know, is there any chemistry behind that? Any molecule from the soap net which is available?
So saponin is the main component.
Only.
It's the main component.
Right. Any questions from the audience? Okay. Thank you, ma'am. Please.
Next presenter is T1 PP3 Shaktivel M. Shaktivel T1 PP3.
Yes, sir, am I audible?
Sir, you may start your presentation now.
Hello, sir, am I audible?
Yes, you are audible. You can start your presentation.
Yes, sir. Good evening, everyone. I am Shaktivel, PhD Scholar, Division of Plant Pathology at ICAR IRA, New Delhi. I would like to present a part of my MSc research work entitled Field Evaluation of Fungicides and Biocontrol Agent for Management of Fusarium Wilt in Chili. Chili is an economically important spice skunk vegetable crop cultivated widely in India. It is consumed both as fresh vegetable and in processed form. In addition, it has high nutritional value as it is rich in vitamins and essential minerals. However, its production is severely affected by several diseases, among which Fusarium wilt caused by Fusarium oxysporum forma specialis capsicum is one of the major disease which causes 10 to 50% yield losses under severe conditions. As the pathogen is a soil-borne facultative parasite, it enters the plant mainly through roots and colonizes the soil, produce high-grade spores inside the vascular tissue, blocking water and nutrient movement. This leads to development of symptoms like yellowing, wilting, vascular discoloration, and finally death of the plant. Since the pathogen survive in the soil for longer period, management of the disease under field conditions remain difficult. Therefore, the objective of the study was to evaluate different fungicide and biocontrol agents for effective management of Fusarium under field conditions and to identify an economically suitable treatment for farmers. Coming to methodology, this is the chili plant showing typical wilt symptoms. We are collected from the agricultural field and the pathogen was isolated using the moisture chamber method. The pathogen was identified as Fusarium oxysporum based on cultural and morphological characteristics such as colony growth, microponidia, macroponidia, and chlamydospore observed under microscopic examination. The pathogenicity of isolated fungus was confirmed through root tip inoculation using 1 month old chili celling. The development of typical wilt symptom followed by re-isolation of the pathogen confirmed poach postulates. And for field evaluation, different treatments including fungicides, biocontrol agent were tested under field conditions using randomized block design with 3 replication. The treatment were applied through soil drenching at 15 days interval after disease appearance. The disease incidence was recorded after the first, second, and the third application. Disease parameters such as percent disease incident, percent disease control, and increase yield. Percentage yield increases over control were calculated using standard formula. The yield was recorded at harvest and the benefit cost ratio was worked out to determine economic feasibility of each treatment under field conditions. Now coming to results, the first graph shows the progression of percent disease incidence after different treatments. Among all the treatment, the treatment 5 thiophanate methyl consistently recorded the lowest disease incidence. Mainly after the third application, it recorded only 13.38% disease incidence compared to untreated control. Second graph represents the effect of treatment on yield and disease control. Among all the treatment 5 thiophanate methyl recorded highest disease reduction of 63.92% and also produced the highest yield of 107.59 quintal per hectare. This was followed by carbendazim and mangoseb treatment 2 and treatment 1 tibuconazole and trifloxystrobin. The table represents the economics of different treatment including yield, gross return, net return, and benefit cost ratio. The economic analysis is important because it helps to identify not only the biologically effective treatment but also the most profitable treatment for farmer. Among all the treatment, thiophanate methyl was recorded highest benefit cost ratio of 3.35, indicating the better economic return along with effective Fusarium wilt disease management. In the conclusion, the present study demonstrated that timely soil drenching with the thiophanate methyl effectively reduced Fusarium wilt incidence, increased yield, and produced maximum economic return. Therefore, this treatment can be considered as a effective and economically viable management option for Fusarium wilt of chili under field conditions. And finally, I sincerely acknowledge to my chairperson, Dr. Ranjanath, for constant guidance and support, and Department of Plant Pathology, Vishwa Bharati, for providing facility to conducting experiment, and ICR PG Fellowship for financial support. Thank you.
Say, Dr. Shaktivel, it appears that you have already published this paper. Shaktivel and Nath and all, 2024. Is it different from this thing, that paper?
No, so this is my paper, sir. After the research work over, we published one paper, sir. That paper only I cited.
It's not clear.
Sir, this paper is our research paper only. After the research study, we have published this paper. That paper only I cited here.
Whether the one which you have published in plant archives and the one which you are presenting here are one and the same or different?
Same, sir. They are both same.
You are not supposed to do like that. Once it is published, then there is nothing more to present here. Once you present here, you can publish later. But the published information cannot be presented here. Okay, thank you.
Okay. Thank you.
Shaktivel, can you hear me? What is?
Yes, ma'am.
He has already published this. You can see from his publication
No,
with the details.
I'm asking about the title. See, what is the scientific name? How will you write the scientific name? Capsicum annuum.
It's italic. A is capital.
A should not be capital.
It should not be capital.
Yeah. You have made it into a sentence case, I think. All capitals like this, thing like that. But the
Yes,
scientific name. Okay, thank you.
Sir, the next presenter is Anuranj, T1 PP10. This is the last presentation of today's technical session. T1 PP10, Anuranj.
So which means
Sir,
we have only 4 online, right? Organizers? Only 4 has been presented so far, right? This is the 4th one. This is the PP10.
Yes, sir.
And that's the last one.
Yeah, this is the last one.
Yeah, go ahead, Mr.
Sir, am I audible, sir?
Yeah, Anuranj. Huh?
Yeah,
go ahead.
So, good afternoon, one and all. Myself, Anuranj, PR, Department of Plant Pathology, College of Agriculture, Balani. Today, I am here to present our work titled Harnessing the Plant Microbiome, Endophytic Bacterial Isolates for Biotic Resistance Against Chili Leaf Curl Disease. So, we all know that chili leaf curl disease is a major constraint in chili cultivation, consistently causing severe yield losses. So we all need a sustainable management strategy for this. So we have investigated the potential of endophytic bacterial isolates, specifically sourced from the plant parts of tolerant and resistant capsicum species, which is available in the campus itself, that is the College of Agriculture, line. So to see if they could enhance the biotic resistance against this particular viral disease. So as a part of methodology, we have to evaluate this efficiency of the isolated bacterial endophytes. We have conducted a pod culture study under a completely randomized design. We utilized the chili variety Vellini agulia, which is the most susceptible for this particular disease. Our treatments included 10 distinct bacterial isolates, which is labeled as B1 to B10, that is bacterial endophyte 1 to bacterial endophyte 10, which we isolated from the plants at the instructional farm and the student farm at College of Agriculture, Vellini. So for the application of this particular endophytes, we prepared a bacterial solution at a concentration, and this was applied as 2% as a foliar spray method. To thoroughly assess their protective capabilities, we done it as a 2 experiment studies, that is a pre-treatment experiment and the post-treatment experiment. And the treatment here is the application of virus through grafting method. So a uniform disease score of 4 is used for the grafting, and 5 days prior to the grafting, the pre-treatment study has been conducted, and 5 days after grafting for the post-treatment study. After 5 days, the bacterial endophytes were applied. So disease severity was then assessed based on the 0 to 5 scale by Banerjee and Kallu. And then for the results, I would like to take your attention to the graph in the results section, which is the % disease incidence in the pre-treatment as well as the post-treatment studies. So in both the cases, the bacterial endophyte 8, 9, 10, when compared to control, like shown there, like the control is shown in the far right, exhibited expectedly high disease incidence. Like the control is showed as expected high disease incidence, whereas there is a significant drop in the bars for isolates B8, BE9, and BE10. These 3 isolates drastically reduced disease incidence in both the pre-treatment and post-treatment phases. So in the right side, there is the images, the visual representation of when compared to the untreated control, the virus disease symptoms are significantly reduced, and there is a considerably higher growth in the BE8, BE9, and BE10 isolates. So as a conclusion, our study successfully identified 3 potentially highly potentially endosperming endophytic bacteria that effectively manages chili leaf curl disease. And as well as this, we have identified this particular bacteria through 16S rRNA sequencing, and we recognized these powerhouses isolates as Bacillus valesensis, Bacillus albus, and Tricia arabidopsis. Once again, I thank for the opportunity provided by the MPPS and my guide, Raj.
Mr. Anuraj, what can be the possible mode of action of the endophytic bacteria against the virus?
Sir, actually my studies pointing in both aspects. Like I want to check for its disease incidence reduction and as well as the growth promotion. So one of the characteristics may be the growth promotion.
I just want a simple answer. What can be the possible mode of action? How did it inhibit the virus?
Maybe increasing the growth, like as we are.
Is it growth of virus?
No, the growth of plants. Like the growth of plants also seem to be significantly increased by applying these bacterial lysages compared to the untreated one. So maybe that is also a reason. Because this virus nature also crinkling and shortening and all, right? So maybe that's also a reason.
So the endophytes are improving the growth of the plant. That may be the possible reason for inhibiting the virus. Is it so?
Yeah, there are several studies like this, endophytes like bacteria, this Bacillus valesensis and all, improving their growth of the plant. So it can also be a study, and by further experiments and all, I can also get to know what is the actual, by using gas chromatography and other molecular docking techniques and all. Is there a specific compound present in that particular bacteria or something like that?
Thank you. Any other questions from the audience? If not, thank you. Thank you very much.
Oh, thank you.
Thank you and best wishes to all the participants. To conclude this session, we invite Dr. K.M. Srikumar and Dr. K.V. Sumia to present the memento to the chairman and co-chairman of the session. I invite Dr. K.M. Srikumar and Dr. Nisha to present the memento to chairman and co-chairman of the session. Thank you all. As we are about to conclude today's session, I request all the participants and delegates to join in for a photo session. A series of cultural programs performed by our talented students and staff members. That will be followed by dinner.